Je suis tout à fait désolé de commencer avec une demi-heure de retard. Il y a des choses qu'on...
Parce que sur les 5 dernières années, on a beaucoup évolué et c'est principalement grâce à vous tous et grâce à la confiance que chacun d'entre vous a mis dans le projet, dans ce que nous proposons et on espère que l'année...
Qui est en train de parler? Parce que c'est pas moi. Pour expliquer une situation. On a fait déjà cet atelier il y a 2 ans presque. C'était en juin 2023 et on avait fait ça sur le contexte du MED programme. Je ne vais pas reprendre à nouveau ce qu'on a fait. Je ne vais pas l'expliquer parce que vous avez tout dans l'invitation, la note conceptuelle et tout ça. Mais à ce moment-là, c'était M. Sidi qui n'était pas satisfait avec le workshop qu'on avait prévu pour le pays. Ce n'était pas une faute de Medwave, que Medwave est l'organisation qui gère ça comme centre régional d'activité de UNEPMAP, avec le ministère, bien sûr, sur le contexte du MED programme. C'était une conception qu'on a planifiée une chose par rapport à ce qu'on avait pensé que le pays avait besoin, et après, on s'est rendu compte que le pays avait besoin d'une autre chose plus formelle, plus technicienne. Et c'est la chose qu'on est en train de faire. Donc, ça, on montre la coopération institutionnelle. Quand vous avez des doutes, c'est à nous d'essayer de les résoudre. Donc, on a dépensé des années, de très longues années. Ça sera la dernière activité qu'on va faire en Tunisie, mais on attend que ça va être profitable pour toutes les institutions ici. Donc, maintenant, je vais inviter le directeur de l'Agence nationale pour qu'il parle. Directeur général au ministère de l'Environnement. Parce qu'avec l'autre personne qui est en train de parler, je ne sais pas ce que je vais présenter. C'est peut-être la personne de l'autre. Mais c'est à vous, monsieur.
Mais on essaie de garder quand même les petits bons aspects qu'il y a eu. Parce que nous, on avait déjà planifié de lancer le projet en juillet.
Bonjour à tous et à toutes, chers invités, chers amis et experts parmi nous qui viennent pour nous appuyer sur un dossier très important, la pollution par les POPs. Comment les identifier, comment les évaluer et comment faire pour atténuer leur impact sur l'environnement. Au nom de M. Habib Abid, ministre de l'Environnement, je suis avec vous pour assurer l'ouverture de cet atelier très important qui vient juste quelques jours après la COP réservée aux 3 conventions qui traitent de ce dossier. Et nous, en Tunisie, nos programmes pour la lutte contre la pollution sont déjà mis en place. Et nous œuvrons grâce à nos moyens et grâce aux appuis qui nous est fournis par le FFM, par le programme d'action pour la Méditerranée, par le PNUE, pour renforcer nos activités, pour aller dans le vif du sujet et pour promouvoir nos actions en termes de prévention de ces pollutions et de lutter contre ces pollutions. Je tiens à remercier les organisateurs. Je tiens à remercier les bailleurs de fonds qui ne cessent de nous appuyer dans nos efforts dans le cadre d'un projet régional duquel la Tunisie tire bénéfice. Notre objectif aujourd'hui, c'est, en présence des acteurs nationaux impliqués sur le sujet et en présence d'éminents experts internationaux et de nos amis de Medwaves avec lesquels nous avons eu déjà de très bonnes expériences fructueuses et qui ont apporté des fruits. Chers amis, même si on a eu des difficultés, la vie, c'est qu'on améliore. C'est un processus d'amélioration continue. Et le fait de nous réunir aujourd'hui, c'est que nous allons continuer notre œuvre pour promouvoir nos actions compte tenu de la science, compte tenu de la connaissance, pour que nos actions soient mieux basées pour promouvoir nos actions. Et que dire, comment promouvoir nos actions pour lutter contre ces POPs, ces polluants qui nous emmerdent et qui sont présents dans l'eau, qui sont présents dans le sol, qui sont présents dans l'air. Aujourd'hui, j'espère qu'après vos travaux, nous allons avoir suffisamment d'informations et de connaissances qui puissent nous éclairer la voie pour le futur. Ce n'est pas une ouverture, l'ouverture va être assurée par Madame Zuhour Metahammam, chef de cabinet, qui est contrainte d'ouvrir un autre atelier. On s'est divisé les tâches. Elle viendra après pour prononcer le discours d'ouverture de l'atelier de Monsieur le ministre, qui a été aussi retenu dans un conseil des ministres. C'est uniquement pour vous dire que ce dossier ou bien cet atelier revêt une très grande importance, parce que notre objectif, c'est comment faire de sorte à ce que nos actions en Tunisie contribuent à minimiser les pollutions en Tunisie et au niveau global, compte tenu de nos stratégies, et notamment notre stratégie nationale de transition écologique élaborée il y a 2 ans et qui ouvre des ambitions fortes et importantes pour l'action, pour promouvoir un développement durable et un développement qui répond à toutes les demandes des différents acteurs et intervenants pour minimiser les effets de la triple causés à la fois par les changements climatiques, par la perte de biodiversité et le cas pour cet atelier par les pollutions de toutes ses formes. Donc, j'espère que cet atelier constituera une occasion très riche d'échanges et de discussions entre experts internationaux et experts nationaux que vous êtes pour promouvoir notre activité et aller vers une action mieux éclairée et mieux basée sur les sciences et les connaissances pour promouvoir notre développement durable. Merci infiniment.
Je vous remercie beaucoup vos paroles, parce que ce sont des paroles très sages, en disant ça de la collaboration des experts internationaux et des experts nationaux. C'est très important. Et justement, je vais revenir vers vos mots avec un personnage que vous connaissez très bien ici en Tunisie, Yugurta. Donc, je prends un morceau de la guerre de Yugurta, de Saloust, que j'avais lu il y a très longtemps, même en catalan, imaginez-vous, mais que je crois que c'est très pertinent pour cet objectif de cet atelier. Donc, dans la guerre de Yugurta, on dit « C'est à tort que les gens humains se plaignent de sa nature et déplorent qu'impuissante et de courte durée. Son existence soit régie plus par le hasard que par la mérite. À bien y réfléchir, au contraire, on ne saurait trouver rien de plus grand et de plus excellent. Et l'on constate que c'est davantage l'activité qui manque à la nature humaine que la force ou le temps. Et pourquoi j'ai dit ça? Parce que ce n'est pas l'hasard qui va faire que la Tunisie progresse. Ce n'est pas l'hasard, ce n'est pas sorcier, ça. C'est les connaissances. Et c'est les gens experts du nord de la Méditerranée, du sud de la Méditerranée, la collaboration. C'est la chose qu'on a essayé sur le VRS. Et par exemple, ça on a essayé, c'est la transférence de connaissances. Et que tout le monde puisse lutter pour un objectif commun, que c'est l'objectif de la lutte contre la pollution. C'est ça le but. Donc, Jugurtha disait ça de l'hasard, c'est la force humaine. Je crois qu'aujourd'hui, c'est la possibilité de faire cette force humaine. Donc, on va faire un rapport de l'histoire et à la fin, je suis sûr qu'avec ces connaissances, on va parvenir au but que nous avons l'agence, le ministère, le gouvernement, Medwave, le BRS. Donc maintenant, on commence. Je vous remercie beaucoup de votre présence. On va attendre Madame Cambian ici, on va lui donner sa parole. Et maintenant, c'est le tour de Keyono. Keyono, comme vous voyez sur l'agenda, c'est la responsable du BRS sur des activités, elle travaille sur ça. Elle va nous présenter qu'est-ce que ce sont ces polluants persistants organiques, qu'est-ce qu'on fait. C'est une introduction pour après aller dans toute la discussion plus en profondeur. Donc, Keyono, c'est à votre tour. Merci beaucoup.
Bonjour à tous, je m'appelle Keyono, j'habite à Genève, donc je parle français, mais ça pas good enough to make a presentation. So I will be speaking in English. Hope this will also go through to your understanding on persistent organic pollutants. Will my presentation be here? Okay, let me try. Voilà. So how many of you know what are persistent organic pollutants? The definition? Yes, yes. Expert. So definition of persistent organic pollutants. Very important elements are listed here. They're all persistent by name. What it means is that it stays in the environment. It doesn't break down for many years. But it doesn't mean that it doesn't break down at all. There are also transformation products that are equally toxic sometimes, or there are also related compounds that are equally concerning. So persistence, and then bioaccumulation, it means it will be higher concentration over time inside your body. In the old POPs, most of them were accumulating in your fatty tissue because they were hydrophobic. They're not dissolving in water, but staying in oil phase. But newer POPs are more hydrophilic. They dissolve in water, and they don't necessarily accumulate only in fatty tissue, but also other parts of body. For example, PFAS. They are one of the hydrophilic POPs. So it's not just only fatty tissue, but other part of the body could bioaccumulate. Adverse effects, we don't call it toxicity because definition of toxicity change different from country to country. Some countries think endocrine disruption is not toxic in some countries, but there are adverse effects. So endocrine disruption is one of the adverse effects considered. Carcinogenicity, immunotoxicity, there are several of adverse effects, not only on human health, but also ecosystems. And then the last one, potential for long-range environmental transport. This is very tricky. It means that the chemical can be found in long distance, far from the source, far from where you have used. Like in old POPs, for example, pesticides, they traveled through a phenomena called grasshopper effect. So with the chemical goes up in the sky, falls as a rain, and then it goes up again and then falls down with the rain. And this one was this movement of water cycle tends to go towards the polar region, from south to north, or from from equator to south. It was moving towards the polar regions. And that is why some of the nasty pesticides listed as the initial 12 POPs were found in the Arctic region. By detection, by monitoring of these chemicals, they found toxic chemicals in the Arctic region or Antarctic region, and they found it very important to address these chemicals at the global level, because you can't manage them if the countries that are using those chemicals take action. So that is why the Stockholm Convention on Persistent Organic Pollutants was agreed upon by parties. We have 186 parties to the convention. That includes very important provisions. For example, number one, to stop the source, right? Intentional releases. Prohibit use and production, export and import of these chemicals. Yeah, first to cut the tap. The export and import is allowed only for the purpose of environmentally sound waste management. That means that if you don't have a capacity to manage PCB, for example, polychlorobiphenyls, then you can export it to countries like Germany or France. You know, they have facility to destroy these chemicals. And this is allowed. But if you do that, you need to follow the protocol under the Basel Convention on Waste. So I work for BRS, it's Basel, Rotterdam, and Stockholm Convention. There's another waste convention that governs the waste part. Then there's a specific exemption in Article 4. So some of the chemicals you have to continue using, like DDT for malaria control, or PFAS for firefighting foam. You know, when you don't have alternatives ready, countries want to continue. Still, you have to phase out, but there's a time-limited specific exemption, and also acceptable purpose with no time limitation. Like, so DDT for malaria control is listed as acceptable purpose. So that's a very important function of Article 4. We have Article 5. It's about unintentional releases. So like dioxins, furans. You don't produce these chemicals for use. They are released unintentionally when you burn materials that contain chlorine at a temperature that is not high enough. So it's an incomplete combustion that will release toxic chemicals. So dioxins and furans are one example. There's also pentachlorobenzene, hexachlorobenzene. Some are listed in Annex C. And they have promotion for BAT and BEP, best available technique, and best environment practice. And finally, very important provision is in Article 6 about waste management. So the chemical itself, the pesticide itself that's banned are, okay, they are waste. But not just only that, but also products and articles containing POPs, like carpets that has very toxic flame retardants. They need to be managed as POPs waste. And there is a whole range of technical guidelines under the Basel Convention. So as you can see, Basel and Stockholm Convention, we have very strong linkage. And in order to evaluate whether the Stockholm Convention was effective, we have Article 16 on effectiveness evaluation. And how do you evaluate whether something was good or bad or doing fine? Or you need numbers, no? You need indicators. You need to measure, compare day 1, day 100, 10 years, 20 years. So there are several indicators, but one of the most important indicators that the Stockholm Convention has is the monitoring data. And this is measured through global monitoring plan. And through this GMP, global monitoring plan, we have background data that was collected 20 years ago for initial 12 POPs. Now we measure them. Most of them are going down, reduced, thanks to the prohibition of use and production and so on. And to implement this, we have a committee and expert groups established, like effectiveness evaluation committee, and then regional organization groups and global coordination group, as you can imagine. Yeah, the initial GMP, the first set, it's every 6 years. The first phase was from 2004 to 2011. And then 2011 to 2017, 2017 to 2023. So the previous COP, not that this COP just happened, but the previous COP, we have the third GMP report. However, there are several challenges with GMP. First challenge, as you can easily imagine, is the laboratory capacity in the countries. Not every country can measure. They don't have GCMS, LCMS, measure the data, even from sampling technique. I'm organic chemist by training. So if you send me, I can assist you. But I cannot go to 150, developing countries and, help. And even one person cannot do it because you need to have a laboratory, you need to have supply, you need to maintain the lab. And then more challenging is that at every COP, they're adding new chemicals. So that just 2 weeks ago or 1 week ago, our 2025 COP added another 3 chemicals: chlorpyrifos, medium chain chlorinated paraffins, and long chain PFCAs. So we have organic chemist experts over there knows how challenging to measure MCCPs in the environment. Who can measure them? Do you know how many MCCPs there are? There are like thousands of congeners there. And we already have short chain chlorinated paraffins. Okay, so what are we now measuring? Chlorinated paraffins of which congener, C13 to C14, with this chlorination level at or above 45% chlorine level. Like, how do you measure these very complicated newly listed chemicals? Is a challenge. And then another challenge is that what are they telling you when you measure them? When you measure these chemicals at the background level, most likely it's below detection limit because you don't have good capacity to also measure. The detection limit is high if your technique level is not high enough. So, almost zero, whatever, is it's very difficult for policymakers to use that kind of data. The third challenge is, I mentioned about that the initial 12 chemicals, many pesticides, traveled towards Arctic. Now, when they measure the levels in Arctic region, some of the pesticides are increasing. Not necessarily because of the Stockholm Convention non-effectiveness, but scientists are saying, estimating, that it's from climate change. Because of climate change, the ice melts and some of the chemicals that are trapped in the ice are released. So it's increasing. And then is it telling you about the effectiveness of the Stockholm Convention? Not necessarily. So after 20 years, in my view, it is getting very difficult to maintain GMP because of the complexity in chemicals, and also the limitation in measuring just only background data, telling you that it's mostly declining, but with the climate change, it's increasing. While you're not measuring actual data like exposure data, hotspot monitoring, or chemicals in products, which is more difficult to measure, these are not included in the current thinking of GMP. So yeah, and here I have a list of 31 POPs that are measured during this period, and the core media for GMP is air, human tissues like blood and milk, which is very, very important information, by the way, because that really tells you how much we have been exposed. And the data from human tissue is showing really that the levels are decreasing, at least for initially listed chemicals. And then those PFAS that are hydrophilic, not found more in water phase, we have additional core media, water. So GMP reports are available on the website, and you can also access the raw data from GMP data warehouse. You can see the link here. Maybe you can Google and you will find it. UNEP Chemicals branch, which is also located in the same building in Geneva, also developed, and they are supporting, by the way, the implementation of POPs monitoring, and they have dashboard. So it's a bit long URL, but you can access and you can see it more visually by mapping. And here are several of air monitoring stations that are contributed to GMP3. So it's difficult, because this is global report, it's difficult for just one country to do something and then provide that information for coherency and comparability of data. So it's important to have regional cooperation. And you can see that some Latin America has a lot of stations, North America as well. So GAPS network are covering that area. European continent is also full of stations, but you can see the gaps in the African continent. Here, including in Tunisia, you have maybe one dot, but not much in the middle. Same for Central Asian region, Arabic region. So we call it GMP, but with a bit of gaps. And as I have mentioned earlier, so initial POPs, like what are they? HCH, so hexachlorocyclohexane, like alpha, beta, and gamma, which is linden, are listed under the Stockholm Convention. They are decreasing. You can also see PCB and PCN. The graph is a bit not necessarily always clear, but in general, it is showing decreasing trend. That is a good news. Also in the mother milk sample, you can see over years from 2000 compared to 2016 to 2019 survey, the WHO's dioxin PCB TQ is quite getting in a decreasing trend. Yeah, it's a very good news. So for these initial chemicals and looking at the mother survey is a good information for government to be confident about the Stockholm Convention. But on the other hand, look at this data from PFAS. We don't know what this is telling because it's all over the place. It looks like it's going up and then down, but okay, what about that 2018? That's really have a gap. There are several reasons possible to explain why this is so scattered. Maybe the data is not accurate enough, very limited stations, but also maybe consistent input to the environment, that it is indeed sometimes it increases. So yeah, the PFAS in the environment data is challenging. And sometimes it's very sensitive as well. People get scared of drinking water or so. So we would need to even think more about how to continue PFAS monitoring. Here you can see the PFOS and PFOA ratio, try to analyze what these are telling us. This is a data from the Asia Pacific region. And then finally, the GMP also includes long-range environmental transport data. So from the air sampling data, they have colored where these POPs are found more. And you can see in the northern hemisphere, the more north area, the higher the concentration, possibly explaining the long-range environmental transport, the grasshopper effect, and so on, but also maybe naturally human activities are concentrated on the northern hemisphere. So I have like a few boring slides, I'm sorry, to summarize the GMP and GMP timelines. But what is very important is that currently we are at the fourth cycle, the 6-year cycle. So we're doing the same, like background data. But I am thinking, and I'm talking to experts, that this is not enough, and this is not sustainable. We need to look at more of the exposure data, more from the chemicals in products and articles, maybe try to find where the hotspots are, how the waste, the stockpiles are found, so that policymakers can take action based on the monitoring data. We should continue with the good news of trying to show that the concentration levels are decreasing. But that is not all what the current status of POPs, especially for emerging chemicals, like the ones that were listed under the convention at the last meeting. And another one very complicated, UV328. We just had that listing of UV328 amended to add another exemption for aircraft. That means that the use of this chemical will continue, and including for spare parts, like 2044. It's a very, very long time. And so, yeah, it's maybe, we should start considering how best the GMP data can help making policy. And within these 6 years, before the next cycle starts, we should have a bit better idea of implementing the paradigm shift of GMP. So we have the list of regional groups that are helping GMP projects, and the MED program is one of them that is contributing to this region. Thank you very much.
Thank you very much, Kay. Comme nous sommes en retard, Kay a oublié une partie très importante, que c'est la vidéo. Donc maintenant, on va passer une vidéo qui va synthétiser tout ce que Kay vient de dire. S'il vous plaît, vous pouvez la mettre.
We need to talk. It's about the intimate relationships you are in. What I mean is, do you realize the encounters you are having with chemicals that last forever? The air we breathe, the water we drink, the food we eat, and the products we use, these are all ways we are in relationship with persistent organic pollutants. POPs, or persistent organic pollutants, are not only a threat when we first encounter them. They continue to live on in nature even after they are disposed, bioaccumulating, casting a long-term and wide-range threat for human health and the environment. There is a way to reduce and eliminate the threat of body burden. It starts by making visible the invisible. Pollution by hazardous chemicals and waste cross borders and boundaries. This is not a problem that can be solved by one country alone. It is a global problem requiring global cooperation for global solutions. The BRS conventions are legally binding agreements which means that parties are required to take measures to protect human health and the environment from persistent organic pollutants. The BRS conventions bring us together so we can actually have international cooperation, promote the exchange of scientific information, and support countries in implementing measures to prevent and reduce harmful exposures, ultimately contributing to the reduction and elimination of body burden. The work of the conventions is successful because of each of us. As individuals, we can advocate for stronger national policies by raising awareness in our communities. As governments, we can integrate chemicals and waste management into national development plans and enforce the existing regulations. As businesses, we can adopt sustainable production practices, invest in non-toxic alternatives, and do what it takes to make our supply chains transparent. As civil society organizations, we can help monitor what is happening, support the engagement of our communities, and bring forward our science-based recommendations. This is how we make visible the invisible.
Donc, merci beaucoup, Keyono, pour cette présentation que vous avez menée, parce que c'était très intéressant, réellement. Merci beaucoup et merci aussi pour toute la présentation. Il y a des choses que je n'ai pas dit à l'avance parce que je n'ai pas eu le temps, mais c'est très important. Après chaque session, vous pouvez poser des questions, tous les experts, c'est bien sûr. Donc, si vous avez des questions, n'hésitez pas à poser des questions. Mais aussi, si vous regardez l'agenda, à la fin de toutes les sessions, on va avoir une table ronde où vous pourrez poser des questions à tous les experts qui vont être ici. Donc, si vous considérez, par exemple, dans la prochaine session que vous avez des questions pertinentes, vous les faites. Et sinon, vous réfléchissez pour faire ce partage des informations à la fin. Donc, vous avez tout le temps ouvert le micro pour intervenir. Pas de souci sur ça. Et le deuxième point, c'est que le déjeuner est compris par l'acte, il est payé, il sera au 8e étage. Donc, tout le monde a un déjeuner gratuit pour prendre ici. Donc, ça, c'était très important. Maintenant, c'est le tour de M. Sidi, que je ne le vois pas. Il vient. Donc, M. Sidi, c'est aussi le point focal du MED programme par la Tunisie. Donc, il va présenter, après l'introduction que Keyono a fait sur la problématique des POPs, quelle est la situation des POPs ici en Tunisie. S'il vous plaît, M. Sidi, vous avez la parole.
Pardon, bonjour tout le monde, marhaba bikum, soyez le bienvenu. Donc, comme vous voyez, cet atelier a comme objectif de donner plus d'informations sur la Convention de Stockholm, plus éclaircissement sur l'engagement de la Tunisie vers cette convention-là et quelles sont peut-être les mesures ou les efforts qui ont été mis en place afin de respecter la Convention de Stockholm. Donc, dans cet exposé, on va voir ensemble une aperçu sur la Convention de Stockholm, les objectifs de la Convention, l'état de présence de POPs, la liste de POP inscrites au niveau de la Convention, les différentes catégories de présence de POPs, tels que les pesticides, le retardateur de flammes, les produits industriels et le revêtement et les imperméabilisations. Comment la Convention va appuyer les pays pour protéger la santé, les exigences de la Convention, et je terminerai par les efforts mis en œuvre pour appliquer la Convention de Stockholm. Donc, comme vous voyez, les polluants organiques persistants, ce sont des composés organo-halogéniés. Il a 4 caractéristiques essentielles. Essentiellement, ne décompose pas. Donc, il s'accumule au niveau de l'organisme, au niveau Je dois revenir en arrière. Donc. Oui. Normalement, c'est celle-là. Donc, il y a 4 principales caractéristiques. C'est la toxicité de ce produit-là. Il se transporte à longue distance et s'accumule au niveau de l'organisme et surtout ne se décompose pas. Donc, la convention a été adoptée en 2001. Elle a entré en vigueur en 2004 et actuellement, il y a au moins 187 pays qui ont ratifié cette convention. La Tunisie a ratifié la convention en 2004. La convention de Stockholm traite essentiellement, a pour objectif essentiel de protéger la santé, mais les produits qui sont inscrits au niveau de la convention sont étudiés avant par une comité technique qui suit toute une procédure ou un protocole d'après l'article ou l'annexe D, c'est-à-dire il y a toute une démarche. Cette équipe-là fait leur étude et leur analyse et par la suite, ils proposent au COP pour inscrire ou pour ajouter ce produit-là au niveau de l'annexe de la Convention. Donc, la Convention a pour objectif, c'est définir quels sont les POPs, les produits qui peuvent être considérés comme POPs, et aussi, il essaye de pousser ou d'appuyer les pays afin de protéger l'environnement contre le risque de ces produits-là. La Convention, elle a 2 moyens ou 2 outils afin de réduire le risque de polluants organiques persistants. Commençons par la réduction des émissions de rejets non intentionnels à cause de certains process qui génèrent certains polluants organiques persistants tels que le dioxine ou le furan. Aussi, il y a l'identification et la caractérisation des sites pollués par le POPs et aussi l'identification de stocks des POPs périmés, essentiellement les pesticides. Et par la suite, la Convention aide les pays à gérer d'une manière rationnelle, écologiquement rationnelle, les différents types de POPs qui existent dans les circuits industriels. Donc, le POPs, il existe sous plusieurs formes. Donc, dans des cas, on peut trouver le POPs dans un mélange ou dans un produit ou en ajoutant d'une manière intentionnelle un POPs, ou dans un article de produit, ou en ajoutant aussi des produits POPs. Dans certains des cas, il y a 2 produits qui sont produits entre guillemets nobles, mais de temps en temps, il y a 2 contaminations au niveau du process de production. Donc, il y a un produit qui est contaminé par le POPs, mais c'est un produit qui a été ajouté à un autre produit, donc ça peut être aussi considéré comme un produit POPs. Donc, il y a au moins 37 produits POPs qui ont été inscrits jusqu'à maintenant au niveau de la Convention de Stockholm sous 4 ou 5 catégories. Première catégorie, c'est le pesticide. Donc, vous voyez devant vous les différents produits inscrits au niveau de la Convention comme pesticides. Donc, il y a 16 pesticides qui ont été déjà inscrits. Dernièrement, il y a 3 produits qui ont été ajoutés à la Convention. Donc, vous êtes un peu familiarisé de ce produit-là. En Tunisie, comme vous le savez, il n'existe aucun produit utilisé actuellement en tant que pesticide. Donc, il y a aussi de retardateurs de flamme. Il y a 10 articles ou 10 produits qui ont été utilisés pour le retardateur. Vous voyez que les produits, dernièrement, ils ont ajouté d'autres produits aussi à la dernière conférence. Aussi, il y a d'autres types, c'est le type industriel, exactement. Il y a 6 types de polluants organiques persistants qui sont classés industriels, essentiellement le PCB. Aussi, il y a autre activité, c'est la tension active ou le revêtement. Il y a 4 types qui sont utilisés avec des pourcentages et des concentrations très limitées, mais reste toujours un produit POPs. Donc, la Convention, elle a des dispositions essentielles pour les différents pays. Donc, il doit pousser les pays à réduire les émissions intentionnelles, surtout au niveau du process. Aussi, il doit aider les pays à identifier et caractériser les sources des POPs dans toutes les différentes utilisations de POPs. Aussi, elle a mis en place un certain book technique qui s'appelle les meilleures techniques disponibles, qui donne des solutions techniques pour substituer ou pour changer un certain produit par d'autres produits moins dangereux ou produits non POPs. Et aussi, bien sûr, le volet le renforcement des capacités aussi est un volet très important qui touche tous les aspects pour les pays. Donc, le pays a des engagements essentiels. C'est d'élaborer un plan d'action national pour la mise en œuvre de la Convention de Stockholm. Aussi, il faut adapter ou mettre à jour les textes réglementaires afin de s'adapter aux dispositions de la Convention. Et aussi, le volet surveillance est très important. Chaque pays doit essayer de mettre en place un programme de surveillance et de contrôle et de suivi de la pollution par le POPs. Et bien sûr, chaque pays est tenu de faire les échanges d'informations afin de distribuer les expériences et échanger les expériences entre les pays. Donc, l'article 3, bien sûr, c'est un article qui a exigé une liste bien déterminée de POPs qui sont inscrites à l'annexe A. Ce sont des produits à éliminer totalement, à ne pas utiliser, à ne pas importer, à ne pas exporter. Aussi, à l'annexe B, il y a une restriction d'utilisation, c'est-à-dire certains produits POP sont utilisés exceptionnellement dans certaines activités et bien sûr pendant une période bien déterminée, 5 ans, et c'est renouvelable, tout dépend du demande du pays. L'article 7 aussi, il exige ou il recommande l'élimination ou la réduction ou le contrôle des émissions intentionnelles. Et aussi, il y a une dérogation spécifique. Chaque pays peut présenter des demandes de dérogation spécifiques s'il voit qu'il est nécessaire de continuer à utiliser certains polluants organiques persistants dans certaines applications avec des arguments bien définis. Il peut être autorisé pour continuer à utiliser ce produit-là. Donc, qu'est-ce qu'on a fait jusqu'à maintenant au niveau de la Tunisie? Au niveau de la Tunisie, on a essayé de faire des inventaires nationaux. On a identifié, on a caractérisé les différentes sources de POPs dans toutes les activités, que ce soit agricoles, industrielles et autres. Donc, on a caractérisé notre capacité nationale de gestion des produits POPs. Aussi, on a identifié les priorités ou les activités prioritaires qu'on a besoin pour qu'on puisse être en mesure de gérer le POPs d'une manière rationnelle. Il y a le volet recherche et développement aussi. Il y a certaines relations avec les chercheurs et les laboratoires pour encourager la recherche en la matière. Aussi, il y a des projets d'élaboration de certains projets pour appuyer la mise en œuvre de la Convention. Il y a tout un texte réglementaire pour arrêter une liste de POPs à ne pas importer, à ne pas exporter, à ne pas utiliser. Il est en cours. Aussi, il y a un autre projet de loi, c'est une loi cadre qui va englober ou qui va gérer d'une manière globale dans le cycle de vie de POPs. Aussi, c'est un projet qui a été préparé, il est en cours de finalisation. Aussi, on a préparé 2 plans nationaux de mise en œuvre de la Convention, 2 plans qui ont été préparés et élaborés et transmis au niveau de la Convention de Stockholm. Donc, côté surveillance, la Tunisie a participé 2 fois successifs au niveau de l'effort mondial pour le monitoring ou la surveillance ou le contrôle de la pollution par le mercure, par le POPs. En fait, c'est un effort fait par nos partenaires de CETED qui a participé dans cette campagne-là. Donc, il y a 2 résultats. Et nous sommes en cours de préparation d'une 3e campagne d'analyse va démarrera normalement à la fin de cette année-là pour vraiment continuer l'effort pour mieux connaître l'existence et le niveau de contamination de POPs dans notre pays. Vous voyez ici le point ou le champ de prélèvement des différents échantillons. واد مجردة في الهواء في même dans certains produits alimentaires كما الحوت Donc aussi, on a exécuté une campagne d'analyse des prélèvements essentiellement dédiée pour les PFOS ou les HPCD. On a peut-être ciblé certaines zones ou certaines activités afin de chercher le taux de concentration de ces 2 polluants. Et heureusement, on n'a pas trouvé grand-chose du point de vue concentration. Pour les PCB, aussi le PCB, comme vous savez, c'est l'un des plus grands POPs qui est très dangereux, qui existe essentiellement dans les transformateurs. Donc, on a fait tout un grand effort pour éliminer une grande quantité qui existe déjà dans les transformateurs. On a éliminé presque 1200 tonnes jusqu'à maintenant et nous sommes en train de préparer un programme d'élimination d'une autre quantité. C'est à peu près 400 tonnes qui va être éliminées des différents organismes ou des différentes entreprises qui tiennent cette quantité-là de PCB. Bien sûr, aussi, on a pu exporter 1800 tonnes de pesticides périmés jusqu'à maintenant. Bon, sur le plan réglementaire, comme j'ai dit, nous avons préparé 2 lois, 2 textes. Sur le plan renforcement des capacités, nous sommes en train d'exécuter un projet de renforcement des capacités en matière de mise en œuvre de 3 conventions, y compris la convention de Rotterdam, Stockholm et Bâle. Donc, il y a tout un programme de renforcement des capacités de formation, de sensibilisation et des études de diagnostic, des stratégiques, études d'évaluation et de diagnostic afin de savoir quels sont nos besoins, qu'est-ce qu'on a réalisé, qu'est-ce qu'on doit réaliser encore. Donc, et merci pour votre attention.
Merci beaucoup, M. Sidi. Très intéressant de connaître les points sur la Tunisie. Donc maintenant, on peut aller vers les experts. Mais avant, j'ai 2 bonnes nouvelles. Je suis content maintenant. Petit à petit, on a réussi à remplir cette salle. Donc même si on est en retard, il y a plus de monde maintenant qu'en effet quand ça devait démarrer. Donc je suis content. J'espère qu'on ne va pas faire à l'inverse après le déjeuner. Donc après le déjeuner, il faut rester ici. Mais pour les gens qui ne sont pas venus, il y a la 2e bonne nouvelle. Toutes ces présentations vont être partagées avec vous. C'est pour ça qu'on a demandé de mettre bien et d'écrire bien l'adresse email, parce que ces présentations dans une semaine, plus ou moins, vont être partagées avec vous. Mais pour les gens qui sont restés dans le laboratoire, dans les universités, à SFAC, à Gabès, à n'importe où, et qu'ils ne sont pas à Tunis, si vous entrez maintenant sur le site internet de LinkedIn Medwave, que vous l'avez maintenant pas, mais après vous verrez à nouveau le logo de Medwave très gros, seulement LinkedIn Medwave, vous verrez que tout cet événement, ça peut être suivi en direct sur Internet, sur la plateforme. Donc LinkedIn, Facebook, Medwave, vous verrez les posts qui viennent d'être faits. Donc tout peut être suivi. Toutes les présentations de Rainer, Pierre, Begoña et tout ça seront disponibles maintenant. Tout à fait. Et pour les gens qui sont à Gabès, SFAC, SUS, ça n'importe où, ils ne peuvent pas les regarder maintenant. Toutes ces présentations, ces sessions seront partagées sur le site internet du MedProgramme et aussi sur le site de Medwave, le ministère si on veut, mais toutes ces vidéos seront après disponibles pour tout le monde. Donc je ne parle plus parce que maintenant c'est le tour de Dr. Reiner. So I will not present you, Dr. Reiner, because we are ahead of time. We are in a hurry. But for sure, he's a good expert. He would be talking about 2 sessions in 1 hour. He will do his best, but I am sure you will like so much. So, Reiner, thank you very much. Now it's you.
Good morning, everybody. Thanks for the kind introduction and thanks for the invitation to this workshop to contribute. And I hope that this presentation will be helpful and useful for your country. So the presentation will comprise 3 parts. First, monitoring of POPs and human biomonitoring. Then, as reliability of results is important for any discussion and conclusions, few words on analysis, in particular long-term quality control, and then finally monitoring of POPs in foodstuffs. So as you know, humans are exposed to many chemicals in various ways. As example, the main exposure ways to chlorinated paraffins, different uses, plasticizers, paints, adhesives, and so on. So chlorinated paraffins can also be used in consumer products where they can then finally contaminate humans by dermal absorption. Chlorinated paraffins can then evaporate and can be inhalated, so air or dust can contribute to human exposure. Chlorinated paraffins can evaporate and bioaccumulate in feed or food, or also can be used in kitchen appliances, and it has been found that contaminated kitchen appliances contributed to contaminated food, which then caused concern. Human exposure to harmful chemicals can cause various health problems, ranging from immediate or acute symptoms to long-term or chronic effects. Here, as an example, the risk assessment for polybrominated diphenyl ethers, PBDEs, in food, an EFSA assessment, EFSA European Food Safety Agency of 2023. And you see that these address acute toxicity, reproductive toxicity, immunotoxicity, neurotoxicity, genotoxicity, carcinogenicity. So a document of 230 pages without appendices, and this shows just the overall complex toxicological assessment. That's only one POP as example. As Key already pointed out, the main objective of the Stockholm Convention is the protection of human health and the environment from negative impact of listed man-made POPs by reducing or eliminating releases to the environment. And Key already has explained the expansion of number of chemicals, the effectiveness evaluation periodically required, and the GMP. Human biomonitoring can be defined as method for assessing human exposure to chemicals or their effects by measuring these chemicals, their metabolites or reaction products in human specimens. Human specimens can be bodily fluids as breast milk, blood, urine, saliva, sweat, others as feces, hair, teeth, or nails. Compounds measured in these specimens can be persistent organic pollutants, non-persistent organic pollutants, their metabolites, metals, or others. The EU has started a biomonitoring process with 28 countries participating between 2016 and 2022. 17 substance groups were identified as priority substances. These are partly chemical groups like aniline, bisphenols, PAHs, PFAS, phthalates, sometimes product groups like emerging flame retardants, pesticides, mycotoxins, and also chemical mixtures were addressed. A review of 2023 shows the increasing number of studies on groups of contaminants in human milk. So in 1960 to 1980, just organochlorinated pesticides and halogenated flame retardants, two groups were of interest. And over time, the number of groups increased to 20. So there is an overwhelming amount of data available, and in the following I try to get some conclusions what might be of importance in general and for your country. So first, not all compounds measured in human biomonitoring studies are POPs. So in the following, I will address POPs as listed by the Stockholm Convention. Then second, as Key already has mentioned, not all matrices are key matrices but recommended by the guidance document on the GMP. Key has already clarified that there are three key matrices: air, water porphyphers, and human milk and blood. And in the following, I will focus on bioaccumulation in humans with human milk as key matrix, and the WHO UNEP coordinated exposure studies as key contributor to the GMP. WHO has started exposure studies in human milk at the end of 1980s, early 1990s, focusing initially on PCBs, dioxins, and furanes. Also, the third round was started in 2000 with this focus. In 2001, the Stockholm Convention was signed, and WHO asked us as a pilot study to expand the number of analytes to cover also the Stockholm Convention POPs. So these studies became of interest also for UNEP. Two studies were performed jointly. Before then, UNEP took over and performed the last two studies. In the period 2000 to 2019, 82 countries participated with an increasing number of analytes of interest. And the idea was of this joint collaboration to support the assessment of the effectiveness of the Stockholm Convention. So, as you understand, there is a huge amount of data from 82 countries, 30 listed POPs, 20 years. So there are three pillars for assessment. First, individually for the POPs. These 30 listed POPs as listed until 2019, two proposed POPs. Then you can address regional aspects on a country level, on UN regional base or global, and also assess time trends. As it is impossible to present all these results in one short presentation or in one short publication, a special book has been published with 13 papers or publications in 5 parts. And this book has roughly 700 pages, 300 figures, 27 authors. It was supported by UNEP and CVUR Freiburg and is open access available, so you can download the whole information, the book or individual chapters, free of charge. We concluded that there are 4 key messages. The first key message is these studies are an efficient and effective tool with global coverage as a key contributor to the GMP. So the concept of these coordinated exposure studies is to collect representative samples representative for a country. So the national coordinator should collect usually 50 individual samples from mothers fulfilling protocol criteria. From these samples, aliquots are taken to prepare a pooled, physically averaged sample considered to be representative for a country or a subgroup in the country. The analysis is performed of these representative samples in reference laboratories, which reduces contributes to reliability and reduces uncertainty. And this was CBO Freiburg for chlorinated and brominated POPs and Örebro University for PFAS. This concept includes also capacity building, so remaining aliquots can be analyzed by a laboratory selected by the national coordinator, and then you can compare results, and so this would confirm the analysis in the country. This is an extremely cost-effective concept because the analysis of one or few pooled representative samples from human milk in a country is far less expensive than the analysis of a high number of individual samples, in particular for dioxins or chlorinated paraffins. As already mentioned, 82 countries participated from all 5 UN regions. As you might know, UN region is not equivalent to continent. So this is true for Africa. However, European countries are split between Eastern European group and Western European and others group, and others then include US, Canada, Australia, New Zealand. So it's a kind of split as we had politically between the 1950s and 1980s. And so therefore then GRULAC, Group of Latin America and Caribbean countries, and Asia Pacific are the other 2 UN regional groups. The graph on the right illustrates the participating of countries. Some countries participated only once, like US or Russia. Other countries twice, 3 times, like Australia, or 4 times, as few countries in Europe. This has already been introduced when the Stockholm Convention was signed in 2001. The so-called Dirty Dozen was listed, comprising 9 organochlorine pesticides, PCBs as industrial use chemicals, and 2 unintentionally produced chemicals, dioxins and furanes. For these 12 chemicals, the GMP guidance document recommends analyzed to be monitored in human milk, and you see 57 analytes have to be determined to cover these 12 chemicals. When the last round of WHO UNEP coordinated exposure study started in 2016, 26 chemicals were listed. At the end, 2019, then 30. So the number of chemicals analyzed for the last study, 2016 to 2019, comprised all 30 chemicals as listed until 2019, and 2 chemicals in addition on voluntary base, MCCPs and PF-hexasulfonate. For these purposes, 101 analytes had to be determined for chlorinated and brominated compounds, and furthermore PFOS, P4, PF-hexasulfonate. As you know, there is no multi-method for simultaneous determination. About half a different analytical methods are necessary to determine all analytes of interest. And it's a unique characteristic among the core matrices of the GMP that the results of the full set of 32 POPs of interest are available for samples of the 2016-19 period, including DECA-VDE, SCCP, Dicofol, P4, MCCPs, and PF-hexasulfonate. Key has already mentioned that with COP10 and COP11, 4 more chemicals were listed. At that time, 4 more chemicals were proposed for listing, and just recently 3 of these chemicals were listed, now having 37 chemicals listed and 1 still being proposed. A question is, are all these 30 chemicals equally important also for your country? So we try to derive a relative importance from the data bioaccumulating in humans. you can try to derive a ranking based on increasing or decreasing concentrations, which is possible for chlorinated brominated POPs, which are reported nanogram per gram lipid base. Separate, of course, dioxins, which are reported in picogram per gram lipid base, and PFAS, which are reported in fresh weight base or volume base. So the example of dioxins, factor 1,000 lower concentrations than the other one, show that risk assessments need to consider potential adverse effects as well. Having this said, if you look at the range of concentrations of lipophilic chlorinated and brominated POPs in human milk from all 43 countries, participating only in the 2016-2019 period, with median, with error bars indicating minimum, maximum, then you see that the by far highest concentrations were found for DDT and chlorinated paraffins. The maximum found for DDT, 7,100, was roughly a factor of 10 higher than chlorinated paraffins, 700, as some of S and MCCPs. However, the median concentrations are quite comparable. And then you see that MCCPs have a tendency of being higher than SCCPs. PCBs, which otherwise have been of interest for a long while, are a factor of 10 lower than the chlorinated paraffins. Then, next in the group, nonachlor, some of PDD6 and PDE7, including the decacongener, dieldrine, beta HCH, HCB, have median ranges between 1 and 10, maximum up to 100. And then there are many chemicals below 5 nanogram per gram lipid, which is seen as background contamination. And this is seen as some concentrations also below the LOQ. The total sum of POPs ranges between 240 and 640 nanogram per gram lipid. Roughly 50% comes from pesticides, roughly 50% comes from industrial chemicals in more or less all human regions. In Africa, in Asia Pacific and Gulag, roughly 90% of the industrial pesticides comes from chlorinated paraffins, whether short or medium chain, and roughly 10% comes from other industrial chemicals, which is more or less PCBs. Whereas in Western and Eastern European countries, roughly 30 to 40% comes from chlorinated paraffins, and 60 to 70% comes from chlorinated from PCBs. If you look at the estimated global production, PCBs were historically produced roughly between 1935 and 1990 at about in a range of about 1.3 million tons over these 60 years. The chlorinated paraffins have been estimated to be produced annually in this range. It's difficult to estimate it exactly. Main producers are China and India. It was estimated that the total production until 2020 was about 30 million tons. And therefore, short and medium chain chlorinated paraffins dominated the share of POP groups of industrial chemicals. And this is certainly cause for follow-up. And as in the case of MCCP's regulatory efforts, although MCCPs have just recently been listed. Then important regional differentiation. Start with DDT as usually highest contaminant. The concentrations vary between UN regions and between countries in UN regions. You see it here. Africa has a range between 17 and 23,500 microgram per kilogram. So this is 3 orders of magnitude, and Asia Pacific is quite comparable, whereas, for example, in the Western European and others region, it's roughly a factor of 10 lower. And in the graph to the right, you see on the left side, the lowest level, 17, found in Egypt, and on the right side, the highest level of 23,500 microgram per kilogram found in Ethiopia. And so in the round 2012 to 2015, and in the last round 2016-2019, these levels in Ethiopia were reduced to 77,000 roughly. By the way, Tunisia is in the last round, yellow, 2016-2019, at the lower end of the frequency distribution, and the upper third of the frequency distribution would give more reason for follow-up. Next example, beta HCH. Again, a range between below limit of quantification and 1,000 microgram per kilogram lipid, 3 orders of magnitude, most concentrations between or below 50 microgram per kilogram lipid. Some countries also above 200 microgram per kilogram lipid. Africa in the range up to roughly 50, and Tunisia is in the middle with, I think, below 10 or so. Tunisia and other organochlorine pesticides and industrial chemicals is the range of low background contamination below 5 microgram per kilogram lipid. Next example, PCBs. Again, you find a range over 3 orders of magnitude, roughly between 1 and 1,000 nanogram per gram lipid, this time dominated by Eastern and Western European countries, and other regions have much lower concentration ranges. Again, you have to differentiate, you see, between regions and time. So this graph has 2 kinds of differentiations. You see the 5 periods performed between 2000 and 2019, and in different colors you see the different UN regional groups. Dark blue is Eastern European, light blue is Western European group, and you see the dominance, high values of PCBs in the 2000-2003 study for European countries decreasing over time. And you see here Tunisia participated in the last round and was roughly in the upper third at that time. Another example, dioxins. Total dioxins in the African group has the widest variation in concentration with total TEQ. Ethiopia, as well in the 2012 as in the 2019 study, at the lower end of the frequency distribution, and Egypt in the 2000-2003 study with quite high dioxin levels, comparable to levels as you would find in European countries at that time. Then, so you see in Egypt reducing levels until a follow-up study in 2019. Sorry. Then in the upper third, Côte d'Ivoire, Ivory Coast, and Congo, having quite high dioxin levels. Tunisia is more or less in the middle. Dioxins are always of concern, therefore we tried to help to identify also possible sources. and the dioxin pattern in Egypt could indicate combustion and drying processes. Whereas in Ivory Coast on Congo, the pattern hints at consumption of clays, a practice called geophagy by pregnant women. For reasons of time, I do not wish to give more information here. Who wishes to follow up, there are some references left here. Then brominated contaminants, PVDEs, again, 3 orders of magnitude between 0.3 and 350 nanogram per gram lipid, with a median of 1.6, Tunisia below this median. HBCDD in Tunisia, all congeners below limit of quantification. The same is true for hexabromobiphenyl. Then to chlorinated paraffins. We differentiate here between 2 periods, 2009 to 2014, 2015 to 2019. And you see that Africa and the Asian Pacific group has higher CP levels on average as European or GRULAC countries. And in the African group, Tunisia is quite in the middle of the levels of chlorinated paraffins. Then finally, PFOS. Again, Tunisia is in the middle as well of all countries in Africa, as also if you compare it with the median ranges of all 68 samples from the 2008 to 2019 period. So both for PFOS and PFOA in the middle range. Finally, and important, time trends. Again, it is the aim to provide data for the effectiveness evaluation with minimization of sources of variation by the sampling design, harmonized protocol for representative pooled samples, and analysis of pooled samples by the reference laboratory. For clarification, the GMP guidance document says temporal trend studies should be able to detect a 50% decrease in the levels of POP within a 10 years period. However, there is no stipulation of a quantitative goal for a reduction or decrease in levels of PUPs in countries or regions. The objectives are either to eliminate or reduce production, use and releases depending on the matrix, but the rate of decline is nowhere specified or required. If you start to assess time trends, you usually follow median or mean values. If you do this, then you see the problems. Overall, the DDT levels in all 5 regions and globally are lower in the 2016-2019 study than initially in the 2000-2003 study. However, you find a wild up and down depending on participating countries and so on. In this case, in Africa, participation of Ethiopia in the 2012-2015 study was very high DDT levels, which were reduced to the last round. So a much more precise approach is to estimate time trends based on results of countries with repeated participation over time. Then you see here for all African countries that there is a decrease to the following rounds. And, Also, you see reduction rates have to be seen in the context with the concentration range. Here for, where are we? Anyways, for Ethiopia, you see high levels which are decreasing because there is a clear source use of DDT against malaria, whereas at lower background levels, other factors like long-range air transport have to be considered, which is not so much in the hand of the countries. The GMP guidance document recommends to apply simple linear regression or TLCen estimator for power analysis of statistical trends. Important. Trends can be derived if the trend test is positive, p-values below 0.05. For this, you need a minimum of 5 data points. Many countries have less than 5 data points. So in these cases, you cannot derive a statistically significant trends, but then you get a tendency. However, you can combine points from different countries on UN regional base or global, and then you get statistically significant trends. With this, we calculated the overall decrease rate per 10 years. And you see for DDT, globally, the decrease is roughly 60%, for beta HCH 80%, for HCB 60%. Next example, PCBs. This example is for all 25 European countries, which had the highest levels at the end of the 80s, early 90s, and participated already in the first and second round of WHO coordinated exposure studies. You see that significant reductions were already achieved in the 1990s. The reason is that already in 1970, PCBs were first time determined in human milk, which then caused that already in 1973, OECD recommended to stop use of PCB in open systems. So you see a clear decrease starting in European countries already with the 1990s. The decrease rate roughly in the range of 90% between the end of 80s and 2090s in these countries with the highest levels. If you calculate it as a 10-year rate, then you see that roughly 70% is the global decrease rate for PCBs. Then for dioxin-like compounds, again, significant reductions were already achieved in the 1990s. In 1990, Germany, for example, held an international symposium and found that in Germany, the total daily intake would be exceeded. So therefore, measures were recommended to detect sources and to eliminate sources. And this concept was then later applied in 2001 by the EPU. So you see the overall decrease rate per 10 years for dioxins is roughly as well as for the total TEQ, 50%. PFOS between 2008 and 2019, again, in nearly all countries with repeated participation, decreasing tendencies from 2008 to 2016-19. And you can calculate it as well for all countries, then it's 48%, or countries with repeated participation, it's roughly the same. Decrease, increase of total chlorinated paraffins, 2 periods, 2009-14, 2015-19. And you see that there is a slight increase in Africa. There is a significant increase in the Asian Pacific region. There is slight decrease in Latin America, a significant increase in Eastern Europe, although at lower levels than in the Asian Pacific region, and a decrease in Western European countries. Globally, an increase of 30% for chlorinated paraffins in human milk. So, to summary, you see we found median decrease rates for 10 years for a number of chemicals. However, an increase of total chlorinated paraffins as emergent pop in some UN regions and globally. So that would certainly ask for follow-up studies. Again, this is only a short overview. If you wish to follow up the whole picture, then much more information is available. And this comprehensive work was only possible thanks to the support of WHO, UNEP, countries, the national coordinators, funding bodies, laboratories over decades. So it's the success story of so many contributing to these studies. Now, some words on analysis, long-term quality control. WHO performed an interlaboratory study on levels of PCBs, dioxins, and furanes in human milk for qualification of laboratories to perform the third round exposure study. And it was only the CVUR Freiburg which met all preset criteria and therefore was selected as the WHO reference laboratory for that round. In 2006, the EU had a call for laboratories as EU reference laboratory, and FVO, Food Veterinary Office, and EFSA, European Food Safety Agency, assessed all applications, and CVUR Freiburg was selected as the EU reference laboratory for dioxins and PCBs. This task was expanded in 2016 to all, and as the URL for pesticides in food of animal origin. All laboratories of the official food control have to be accredited since 1996. So you might understand that there are quite comprehensive quality control measures which are all part in the book. PFAS was then done by Örebro University. Just shortly, we have internal quality control, procedural blanks, vegetable oil, spike, in-house reference material, and so on. And then the internal quality control is cross-external participation in proficiency test. So for dioxins and PCBs, we participated in 32 PTs with 81 test samples, and 40 pages describe it in detail. For organochlorine pesticide industrial contaminants, we have two methods for non-polar substances, for chlordecone and pentachlorophenol. Again, the same procedure, internal quality control charts from spiked samples, in participation in PTs. The pesticide lab participated in 53 PTs with determination of 150 analytes, which is 10 times more than listed as pesticides. So then as last aspect, monitoring of POPs in foodstuffs. So first, as introduction, in the EU, we have 3 levels of laboratories: official laboratories performing the routine analysis, then national reference laboratories, and then on top EU reference laboratories, which then mission. We have 44 URLs from these 25 for food and feed, and again, dioxins, PCBs expanded in 2018 for POPs. We see Freiburg here, a URL in the middle of more or less Europe. The task of the URL for halogenated POPs comprises 3 groups: chlorinated POPs, dioxins, PCBs, chlorinated naphthalines, chlorinated alkanes, brominated POPs, PBDEs, HBCDDs, emerging POPs, fluorinated POPs, PFAS. The organochlorine pesticide POPs are in the task of our URL for pesticides in food of animal origin. In the field of pesticides, the EU has established 4 reference laboratories for various purposes. And again, the correct title is for food of animal origin and commodities with high fat content, is also in Freiburg. The idea is that the URLs, of course, support the URL Commission and the NILs to organize interlab studies, to organize workshops, analytical methods and have working groups for special tasks. So we organize proficiency tests and inter-laboratory studies for the whole range of POPs in food and feed. And the participation of the national reference laboratories is obligatory. Official laboratories and other laboratories can participate as well. For this purpose, we have to be accredited as well, just for performance of the interlab studies and for assessing the results. The difference: PTs, proficiency tests, assess the analytical performance of laboratories. Interlaboratory studies assess a test method. This just gives you an idea of, I think these were 17 PTs performed over the 5 years and the whole range of analytes of interest covered. And if you want to follow up, there is the homepage where you can find more information, and the PTs are also open for other laboratories. It's free for NILs. Other laboratories might have to pay a fee. Finally, 4 chemical groups of interest and more recent developments: dioxins and PCBs, which is of importance if you want to follow up. Dioxin PCBs, you know the concept of TEF values. TEF values express dioxin-like properties compared to 2378 TCDD as most toxic congener, which then allow to determine toxic equivalence. TEF factors were introduced at the end of 80s. You see some organizations revising it again and again. At present, we have the TEF factors assessed in 2005 by WHO. These TEF factors, WHO TEF factors 2005, are at present the basis for maximum levels and action levels, as we have it in feed and food law in European legislation. And these have also been applied for the WHO UNEP coordinated exposure studies. And now new, there was more or less recently in 2022 a reassessment of the TEF factors by WHO. 3 congeners contributing significantly to total TEQs got reduced TEF factors for pentadioxine, for pentafurane, for PCB 126. So the conclusion is that the total TEQs will approximately decrease by a factor of 2 when the new proposed TEF factors will be applied. That's one aspect. The other aspect is tolerable intake. Tolerable intakes were recommended by WHO in 1998. A tolerable daily intake of 1 to 4 picogram TEQ per kilo body weight. And so in 2000, the European Commission Scientific Committee on Food proposed a tolerable weekly intake of 14, which is 2 per day, and concluded that given the average daily intake of dioxin and dioxin-linked PCBs in European countries, a considerable proportion would exceed this TWI. At the same time, globally, the joint FAO-WHO Expert Committee on Food Additives, JECFA, concluded a provisional tolerable monthly intake, of which is also roughly 2 per day. However, just recently, 2018, the European Food Safety Agency concluded a tolerable weekly intake of 2, which is a factor of 7 lower than what was concluded in 2000. And it was confirmed again that the dietary exposure to dioxins and dioxin-like PCBs might be a health concern, and that a huge part of the population would exceed this recommended intake. So we have at present a mandate from the Commission to EFSA to convert the results in the new TEFs, to update the results data of the past 10 years, to update the risk assessment. And then we will see a comprehensive reassessment and revision in the EU legislation, and the UL for POPs is then asked to help to decide whether these new proposed maximum levels can be achieved with analytical methods. And for time trends, then there will be confusion, because then you have results for whatever reported with WHO tests of 2005 and then 2020 again, and you have a reduction of a factor of 2 only by these changes in test factors. Polychlorinated paraffins. First, for nomenclature, it is now recommended to use the term chlorinated paraffins for industrial products, to use the term polychlorinated alkanes as quantifiable main ingredient of chlorinated paraffins. So you should report individual chain lengths, if possible, allowing an easier comparability, toxicological risk assessment, and to report the sum of measured PCAs. And it's a general recommendation that studies should be performed giving more data. The core working group Chlorinated Paraffins of the URL-NL network has developed a guidance document with quality control data, quality control criteria, and also proposing 2 kinds of analysis: semi-quantitative methods and quantitative methods. The idea is, we all know that analysis is quite different, but semi-quantitative method should be easier. Just do it, and if it is possible to find something, then think of quantitative methods. So for monitoring, the approach is to determine the sum of PCBs as semi-quantitative method with GCEI MS, which is more or less affordable, against the threshold value, and if this threshold value is exceeded, then specific analysis should be performed. Brominated flame retardants. The Commission has asked for monitoring programs on brominated flame retardants in 2014. EFSA has assessed these results in period 21-24. The URL has developed again a guidance document on criteria and also proposed example methods for determination of PBDEs and HBCDDs in feed and food. And the reason is that the EFSA assessment of 2024 said it's likely that the current dietary exposure to PCDDs raises a health concern. So HBCDD, the EFSA assessment was the current dietary exposure to HBCDD does not raise health concern, exception breastfed infants with high human milk consumption. So then PFAS. The EFSA risk assessment of 2020 was done for 4 PFAS and for the sum of these. A tolerable weekly intake was established for the sum, and the content panel concluded that parts of the European population exceed this TWHI, which is of concern, with most important contributors, fish and seafood, followed by eggs, meat, food. For PFUA, also vegetables and drinking water. So the EU has established a maximum level for PFOS, PFOA, PFOS hexasulfonate, and PFNA, as well on individual basis as for the sum in certain foodstuffs of animal origin. No maximum levels for milk, there are only indicative levels. In drinking water, the correct term for maximum level is minimum requirements for parametric values used to assess the quality of water intended for human consumption, which is only a longer word for the same meaning. For PFAS total, total means the totality of per and perfluoroalkyl substances. And for sum of PFAS, and this means the sum of the 20 PFAS listed to the right. So this is for drinking water. The UL has published a guidance document on analysis, again with criteria for feed and food, and has also an example method for determination of food on feed. Analytes of interest to the right from various groups of PFAS. PFAS also have branched isomers, which is a little bit complicated, and so the UL performed also a PT on determination of linear branch and total PFAS. And in this guidance document, you have 4 different approaches available. Drinking water is separate. So the Commission notice of 2024 gives 2 methods of analysis, European norm methods with performance criteria and a recommended method. So drinking water is not in our hand of the UL POPs. We just informally exchange with competent analysts at the workshop. And however, we have to perform these analyses as official routine laboratory. Finally, the question is, with all these expansion of analytes as decided at the last COPs, these 7 newly listed POPs. So PF hexasulfonate is already covered. MCCPs would already be covered by the chlorinated paraffin projects. Long chain PFAS could be included more or less without problems into the PFAS method. Brominated dioxins, furanes, mixed halogenated are still under discussion. The UL-IO has 3 pesticides which can be included, and we have established already also method for UV filters, so that could be done. It would be one additional method to be applied from all these studies. With this, I'd like to thank my colleagues Alex Schechtele and Björn Hadebusch very much for all their help. You know, I have been retired, and so they updated me with more recent information. And I'd like to thank you very much for your attention. Thank you so much.
Est-ce que quelqu'un a quelques questions maintenant? Non, c'est pas maintenant. Non, c'est comme ça. Il n'y a pas d'état. C'est la chose que je voulais bien dire. Donc, maintenant, on a ici Madame Soukour Medhamen Halali, chef du cabinet du ministère de l'Environnement. Si je n'ai pas bien prononcé, je suis désolé. Donc, maintenant, c'est son tour de prendre la parole. C'est à vous, madame.
عسلامة الناس الكل. السيد جوردي مول ممثل المركز الإسباني للأنشطة الإقليمية لخطة عمل البحر الأبيض المتوسط لبرنامج الأمم المتحدة للبيئة ميدويفز. السيدات والسادة ممثلي الوزارات والمؤسسات العمومية والخاصة. السيدات والسادة ممثلي المنظمات غير الحكومية والجمعيات. السيدات والسادة الضيوف الكرام. يسرني الحضور معكم اليوم نيابة عن السيد وزير البيئة السيد حبيب عبيد أشغال هذه الورشة الوطنية حول الملوثات العضوية الثابتة وتقنيات مراقبتها وتحليلها. وأود في البداية أن أتوجه بالشكر الجزيل للبرنامج الإقليمي للبحر الأبيض المتوسط ميد بروغرام لتعزيز الأمن البيئي الذي يساهم في العديد من الأنشطة المتعلقة بالمواد الكيميائية والنفايات الخطيرة ببلادنا، ومن بينها تنظيم هذه الورشة. وأوجه أيضاً شكري إلى المركز الإسباني للأنشطة الإقليمية لخطة عمل البحر الأبيض المتوسط لبرنامج الأمم المتحدة للبيئة ميدويفز، الذي تم تكليفه من قبل برنامج ميد بروغرام لمعاضدة عدد من الدول المتوسطية ومن بينها تونس لإنجاز أنشطة لدعم القدرات في مجال التصرف الرشيد في المواد العضوية الثابتة ونفايات الزئبق. حضرات السيدات والسادة، تلعب المواد الكيميائية دوراً هاماً في تلبية حاجيات المجتمعات البشرية من خلال استخدامها في الأنشطة العلمية والصناعية والزراعية والبترولية والصحية والمنزلية، ولكنه يتوجب التعامل معها بصفة آمنة وسليمة لتفادي تأثيرها على صحة الإنسان والبيئة بسبب المخاطر الناجمة عن عمليات الإنتاج والنقل والتخزين والاستعمال، وكذلك خلال مرحلة التخلص منها كنفايات. وقد أصبحت مسألة السلامة البيئية وبالخصوص السلامة الكيميائية من أبرز الاهتمامات، باعتبار أن نفايات المواد الكيميائية مصنفة ضمن النفايات الخطرة التي من شأنها تهديد صحة الإنسان وبيئته. وعلى هذا الأساس فإن الحد من المخاطر الصحية والبيئية الناجمة عن تداول المواد الكيميائية يتطلب وضع خطط ونظم خاصة للسلامة الكيميائية تشمل الأساليب الآمنة للتصرف فيها تداولاً ونقلاً وتخزيناً، ثم التخلص منها أو إعادة استعمالها بطرق سليمة وآمنة مبنية على أسس علمية وعلى معلومات وبيانات دقيقة. وقد وضعت المنظومة الأممية عدد من الاتفاقيات الدولية التي تعنى بالتصرف الرشيد في هذه المواد الكيميائية والنفايات الخطرة، بادرت بلادنا بالانخراط فيها والعمل على تنفيذها. يواجه متداولو المواد الكيميائية في مواقع الإنتاج أو الخدمات أو البحث أو التعليم عديد المخاطر بسبب طبيعة العمل في حد ذاته ونوعية المواد الكيميائية. ويتسع نطاق السلامة البيئية ليشمل السلامة الكيميائية وحماية المحيط بجميع أوساطه من خلال اتباع الطرق والمناهج الآمنة والإيكولوجية في استخراج واستعمال الموارد الطبيعية والموارد التصنيعية والتخلص من النفايات الناجمة عنها بما فيها المواد الكيميائية. وترتبط أهمية السلامة الكيميائية بتعدد وتنوع أصناف المواد الكيميائية المتداولة في العالم، والتي يناهز عددها حالياً ما يقارب 100,000 مادة كيميائية، مع الإشارة إلى أنه يتم إنتاج ما يقارب 1500 نوع جديد من المواد الكيميائية سنوياً. ويقدر الخبراء ارتفاع إنتاج المواد الكيميائية خلال 15 سنة القادمة بحوالي 85%. حضرات السيدات والسادة، لقد بادرت بلادنا بالمصادقة على الاتفاقيات الأممية ذات العلاقة بحماية البيئة وصحة الإنسان، ومنها بالخصوص المتعلقة بالمواد الكيميائية. نذكر منها على سبيل الذكر اتفاقية ستوكهولم حول الملوثات العضوية الثابتة موضوع ورشتنا لهذا اليوم، واتفاقية روتردام بشأن تطبيق إجراء الموافقة المسبقة على دراية بالنسبة لبعض المواد الكيميائية ومبيدات الآفات الخطرة، واتفاقية بازل لمراقبة نقل النفايات الخطرة عبر الحدود وإزالتها. لإبداء الرأي والتحكم بخصوص المواد الكيميائية بلادنا. وفي هذا الصدد وفي إطار اتفاقية بازل واتفاقية باماكو تمكنت بلادنا من إرساء منظومة متكاملة للتصرف المحكم في النفايات الخطرة، ارتكزت بالأساس على جملة من القوانين والنصوص الترتيبية على غرار القانون الصادر سنة 1996 والمتعلق بالنفايات وبمراقبة التصرف فيها وإزالتها، والأمر الصادر سنة 2000 والمتعلق بضبط قائمة النفايات الخطرة، والأمر الصادر سنة 2002 والمتعلق بضبط شروط وطرق استعادة زيوت التشحيم والمصافي الزيتية المستعملة والتصرف فيها. كذلك الأمر الصادر في 2008 والمتعلق بضبط شروط وطرق التصرف في نفايات الأنشطة الصحية، والأمر الصادر في 2009 والمتعلق بضبط شروط إسناد التراخيص لممارسة أنشطة التصرف في النفايات الخطرة. كما تستعد وزارة البيئة لإعداد تشغيل مركز جرادو لمعالجة النفايات الصناعية والخاصة ومركز التجميع والتحويل بصفاقس وبنزرت. كما يتم تشجيع القطاع الخاص للاستثمار في مجال جمع ونقل ومعالجة النفايات الخطرة. حضرات السيدات والسادة، حتى تتمكن بلادنا من التوقي بصفة نهائية ومحكمة من مخاطر استعمال المواد الكيميائية، فإنه يجب تضافر جهود كل الأطراف المعنية لتقييم المخاطر الناجمة عن المواد الكيميائية ومزيد التنسيق خاصة وتبادل المعلومات فيما بينها بخصوص المواد الكيميائية وإرساء وتطبيق قواعد الوقاية من مخاطرها والرفع من مستوى الوعي خاصة لدى الناشئة ولدى مستعملي تلك المواد. وتتضمن هذه الورشة تقديم مداخلات من خبراء دوليين لمزيد توضيح مقتضيات اتفاقية ستوكهولم حول الملوثات العضوية الثابتة التي صادقت عليها بلادنا منذ سنة 2004، ومخاطر الملوثات العضوية الثابتة ومخاطرها الصحية والبيئية وتواجدها في المواد الاستهلاكية والصناعية والفلاحية. كما سيتم التركيز على آخر التقنيات المعتمدة دولياً لتحديد الملوثات العضوية الثابتة ومراقبتها وتحليلها في كل الأوساط: الهواء، الماء، التربة والنفايات، والتعرف على تجارب الدول المتقدمة في هذا المجال. وفي الختام أود أن أؤكد على الأهمية التقنية والفنية لهذه الورشة لمزيد بلورة الرؤية والتوجهات المتعلقة بإرساء منظومة وطنية لمتابعة ومراقبة الملوثات العضوية الثابتة لدرء مخاطرها والتحكم فيها. مع تمنياتي لكم بالنجاح. شكرا على الانتباه. مع الشكر.
Je dois vous remercier, Madame Chef du Cabinet. Je ne peux rien dire parce que j'ai compris Bamako, Stockholm, Medwave et Medprogramme, ce sont 5 mots. Donc la prochaine fois, je devrais apprendre l'arabe parce qu'il est très beau à écouter, mais je ne peux rien dire. Mais pour m'assurer, on est très en retard, qu'après le petit déjeuner, la pause café, vous reviendrez. Ce matin, j'ai commencé avec Jugurtha et les rois de Numides. Maintenant, on fait une évolution dans l'histoire et on arrive dans votre poète national du XXe siècle, Abou el-Kashem Chebi. Donc, je vais lire seulement une chose, la volonté de vivre. Lorsqu'un jour le peuple veut vivre, force pour le destin de répondre, force pour les ténèbres de se dissiper, force pour les chaînes de se briser. Avec fracas, le vent souffle dans les ravins. Au sommet des montagnes, et sont les arbres disants. Et pourquoi j'arrête ici? Parce qu'après, je vais dire quelle est la relation avec ça, et toute cette détermination et tout ça. Donc, on va faire ce voyage ensemble avec le ministère. Je suppose qu'on a dit qu'on doit travailler ensemble. Je suppose que c'est ça. Donc, on va mettre ça. Medwave, Medprogramme, on le connaît, et on va suivre sur ce chemin. Merci beaucoup. Et maintenant, la pause déjeuner, 15 minutes. Merci. commence à nouveau. Je ne suis pas très content parce qu'il y a quelques places vides. Hein? Vous n'êtes pas très intéressé par la continuation du poème. Hein? Mais pour l'instant, c'est le tour de Begoña qui va démarrer avec l'eau. Donc, Begoña, c'est à vous.
Merci beaucoup pour la présentation, Jordi. Merci beaucoup aussi pour l'invitation. Mon français, c'est pas bon, donc je vais parler en anglais. So, good morning, everybody. It's my pleasure to be here and to be able to show you the work we are doing in my group. We work at the Institute of Organic Chemistry in Madrid from the Spanish National Research Council, and you are all invited to visit our lab whenever you want. So I will start with my presentation about pop in water. Here you have the outline of my presentation. I will have a brief introduction. Well, I don't need to talk too much about POPs now. I am sure that you are very familiar with this chemical compound. And in my presentation, I will mostly focus on a specific class of POPs, the PFAS compound, the forever chemicals. Then I will show you a little bit about the analytical challenges when you have to analyze this kind of compound, PFAS. And then finally, I will show you different case studies where I have been working during the last year. So I always like to use the context where we are. We all know that human activities are dependent on many chemicals. And then all the human activities produce and release a lot of POPs, chemicals, and also emerging contaminants, not yet POPs, but maybe in the future. And this increases, of course, the environmental and health risk for humans. To give you some numbers, we know that there are more than 143 million of substances registered. Some of them, a small proportion, are regulated. And then the bad news is that about 200,000 are identified as highly toxic. But among them, the most toxic compounds, the chemical of major concern, are POPs. So this morning, you are already familiar with the main concept for the POPs. They are highly persistent. They have capacity for bioaccumulation and biomagnification. All of them are highly toxic in general. And of course, another key property for a POP compounds is that the capacity for long-range environmental transport. Well, regarding the convention, as I said before, I will mostly focus in this presentation on PFAS regulated under the Stockholm Convention. So one of them, the first one, was regulated in 2009, PFAS. Then 10 years later, we had PFOA was added to the convention, and then the most recent regulated under the convention was the PFAS, the hexasulfonate PFAS. And I will mainly focus on these compounds in this presentation about monitoring in water. So I'm not sure if you are familiar with PFAS, but for sure, did you hear about the forever chemicals? Some of you? Do you know something about PFAS? Yes, I see that many of you are familiar with this kind of chemicals, no? They are class of chlorophenic, carbon fluorinated compounds. It is recognized that at least there are about 5,000 different PFAS in the global market. We can say that today PFAS are almost everywhere. It could be in technical clothes, in fire foam. Oh, it is difficult to use this. Sorry, in fire foam used for fire control, makeup, anything, non-stick cookware in the kitchen, in the food contact material, and so on. So, unfortunately, PFAS are everywhere, and this is because of the good properties of this chemical, because they are stain repellents, water repellents, and so on. But we have to fight with them, unfortunately. So I don't want to bother you about how many different kind of PFAS we have, but just a small view of the general classification for these compounds. We can have polymers, but also the non-polymers, and we can say that the most studied PFAS today are the perfluoroalkyl acids you have here, the carboxylic acids, the sulfonic acids, the phosphonic, and so on. And these are the most studied PFAS nowadays. But as you can see, there are thousands of them in use. And then coming to the next topic I want to discuss with you, the problem is that there are, let's say, more than 5,000 PFAS compounds. And the question is that only a few of them are regulated, and the other problem is that we have also a small amount of standards to analyze them. So this is what I call the big box, no? We have to quantify a lot of compounds among a small regulation and with the problem of having a small amount of analytical standard for this issue. So let's move to this part. I would like to give you a general view of different points we have to consider when we have to think about PFAS analysis. One of the problems nowadays is that we are not only focusing on the regulated, we have to be aware of the new emerging PFAS, of the new compounds coming from the market. So this means that we will need to analyze many different environmental matrices, let's say water, food, water, food, air, soil, different material, and so on. Another problem is that the detection levels usually are very, very low. So it is not easy to find these compounds if you are not using a good analytical method, as Professor Rainer Mallis was explaining before for the general analysis of POPs. Then also we have to cope with the question of the fast evolving regulation. So we must be aware that we need to have new standard methods. We have to cope with different accreditation and audit in order to get a good data integrity, security, and compliance. And of course, depending on the topic we have to work on, there is a high demand for many analyses, faster analysis, and this is why we need always to develop the best methods to be able to detect these compounds in any kind of sample. Then coming to the lab, I don't know how many people in the audience is working in an analytical laboratory. How many of you are familiar? One? No. Okay, there are different people working in pop analysis. So of course, when we think about the lab, we have to take a special care with many elements in the atmosphere of the lab, different materials. We have to be aware of potential contamination on the, for example, it is unbelievable, but in the solvent caps or the tubing of the instruments, for instance, PFAS are in the Teflon tubing. So if you want to analyze PFAS in the lab, you have to change the tubing. You cannot use Teflon tubing in the lab, things like that. Also, we have to be careful with the solvents we use in the lab. Normally, the water we use for the UPLC system or for the sample treatment, sometimes you have to check it because sometimes you can get some kind of contamination from the water you use in the analytical protocol, and so on. So I don't want to, even with the clothes you wear, you have to be careful because sometimes if you are using waterproof clothes, maybe you can get some contamination by this kind of compounds. So also when we look at the sample treatment, here you have the sample we commonly use for PFAS analysis in water sample. Well, you can see that normally when we have to analyze a water sample, we use solid phase extraction. That means that we need to use a cartridge. And normally you need to activate the cartridge, then you load the sample, you add the surrogate, then you have to wash the cartridge, and finally you load the analyte you want to identify. So in all this process, sometimes you can face problems like losing some of the analytes, or sometimes you get potential contamination, and that means that you can gain contamination by PFAS in your sample treatment protocol. So as you can see, there are a lot of critical points we have to control when we need to analyze this kind of samples. Then another consideration regarding PFAS analysis is that depending on the target compounds you are looking for, depending on the objective, you can use different strategies to achieve as much as possible low detection limits. But I know that, of course, this also depends on the budget of the lab. So that's something also very critical in many cases, no? What everybody wants to have in the lab is a wonderful high-resolution instrument, but this is not always possible. That depends on the budget, on the project we have. So anyway, there are different options, and as you can see here, you can use direct injection. This would be the most simple way. But in this case, the detection limits could be higher. You can also use sample enrichment, as I was presenting before, and this allows to detect PPQ levels in the sample, and so on. So here I would like to give you a general overview of problems we have to consider when we have to analyze PFAS in environmental samples, and all the precautions you need to have. So we have to avoid problems like the contamination, as I said before, of the solvent material, laboratory materials. Also, we have to avoid problems with the sampling and sample storage. That's very important because that could mean that you lose the analyze in the sample, so the final result would not be good. It is also very common to have different matrix effects, and that gives you overestimation of the quantification and so on. So we have to take care with the proper material to be used in the lab. Normally, when we work with PFAS analysis, we don't use glass material, we use PP material. For example, it is very important to use the right analytical standard. I think Roland Weber will talk about this in the evening. And more or less, that's all I would like to tell you. So this consideration, just to summarize what we have to consider when we analyze PFAS, is that contamination is always there because these compounds are everywhere. So field and analytical blanks are mandatory. I mean, we have to analyze a real sample, but when we have to do this analysis, we have also to consider a high quality control, and that means that we have to use field blanks and also laboratory blanks. That's very important. Well, the question that nowadays we have many emerging PFAS, I'm not talking only about the regulated PFAS, but the new one coming to the market. This increase, of course, all the analytical challenges. When we have to choose the method we are going to use in the lab, we have to consider that depending on the techniques, there are pros and cons. So choosing the most appropriate technique or method will depend on the type of study. Talking about the top instruments we have available on the market now, the high resolution instrument, I assume that you are familiar with the good possibilities we have with the non-target analysis, but nowadays this could provide very useful information just to give an overall idea of the problem, but then nowadays the use of suspect screening studies do not allow to perform the routine analysis. I mean, if you need to analyze just PFOS in your samples, it would be better if you move to more simple techniques like, let's say, the use of tandem mass spectrometry. Well, now I will show you a few studies where I have been working during the last year. I'm not going to provide you a general overview of the general trend data at global scale, as Kay did or Rainer did, because they are using a big number of samples, so my studies are on a small scale, but just to show you how you can work in different scenarios. So just to explain you the context in our country, in Spain, in terms of the Stockholm Convention, well, you know all the days and all the history of the convention, and in our country, in 2003, fortunately, the Ministry of the Environment decided to define the National Implementation Plan. Maybe you know our focal point in Spain, Monsieur CD, not sure if you know the person from Spain. You know them, no? So they organized a very, very nice technical group on POPs, and they involved many sectors, the academy, regional and national administration, industries, NGOs, and so on. And these technical groups regularly meet every year. In fact, this year we will have a meeting in September. So this NIP in Spain was presented, the first one was presented in 2005 and was approved by the Council of Ministers in 2007. And one of objective number 5 established a monitoring system for POP concentration. And fortunately, in our country, that started in 2007, and the government decided to fund 2 very nice monitoring programs, one in air and another one in human. And in my case, I've been involved in the Spanish monitoring program on air, and more recently in water, as I will show you. So in this context, the result I'm going to present you will be about the PFAS monitoring in water. This started in 2013. For air, we started before in 2008, and I will show you after lunch. But now I will focus on the study regarding water. And so the main objectives of this PFAS monitoring in water is to assess the presence of the 3 regulated PFAS now on the Stockholm Convention, as I said before, PFOS, PFOA, and the hexasulfonate. We are focusing on the Duero River Basin. It's in the middle of Spain, more or less. The idea is to get data enough to be able to see the spatial trends, the temporal trends, and the seasonal trends, if possible. And also, one of the objectives is to identify potential sources of pollution and to evaluate if the measures of the Stockholm Convention are really effective. So here you have the field design for the sampling. Here you have the Duero Basin, and the data I'm going to show you are corresponding to data between 2013 and 2023. That means 39 campaigns in 4 different locations, and we were doing regularly seasonal sampling, taking samples in winter, spring, summer, and fall. So here you have the detail of the different sampling points. What I would like to remind you is that the first point, not easy to, sorry. Well, the first point is supposed to be the control point, and then we have 2 potential hot points because the sampling is done near urban areas, near the cities of Burgos and Valladolid. And then there is a final point in the limit of the Spain with the country of Portugal. So in general, our protocol for the analysis is shown here in this slide. Basically, we have this device for the solid phase extraction. It's a kind of semi-automatic device, and this is very convenient because this allows you to process a bigger batch of samples. You don't have to work individually sample per sample. And this is, so we basically use about 200 ml of water in the case of river water. The amount of samples is always dependent on the kind of matrix we have, and in the case of river water, 200 ml is the more convenient amount. Then we have to add, of course, the surrogate to our sample, and then we do the solid phase extraction, we evaporate, and then finally we do the final analysis using UPLC with mass spectrometry in tandem. Well, let's move to the results. Here you have a global view of the spatial distribution in the different sampling points. And you can see, if you remember, I told you that sampling points number 2 and number 3 are close to urban areas. And in general, you can see that the highest level of PFAS and most of the individual compounds, I mean PFOS, PFOA, and the hexasulfonate, were usually detected near the industrial and populated areas. Normally, the profile was dominated by PFOS, then PFOA, and then the hexasulfonate. Almost in all the sampling points, there was some exception in sampling point number 1, because we got, unfortunately, some extreme outliers for PFOA. This sometimes happens. Then moving to the spatial trend, normally we can express the concentration per sample, but in the case of a river, it is convenient to consider the mass flow rate, because this could have an important influence on the seasonal trends. So here you have the information about the difference in concentration depending on the sampling point. But if we move to the data concerning also the mass flow rates, you can see how there are statistical significant difference among the different sampling points. Also, regarding the seasonal trends, we found some statistical differences, in particular for PFOA and the hexasulfonate. And as you can see, depending on the season, concentration were higher in summer and fall in general. This is the case for the hexasulfonate. We didn't find this trend for PFOS. In terms of temporal trends with our set of data, I'm not talking about global data, but this is a small set of data nowadays for us in Spain. But the good news is that you can see that for some compounds, in particular for PFAS and PFOA, in terms of both concentration and also in terms of the mass flow rates, there are significant decreasing trends, and this is a really good news. Then moving to the environmental quality standard, which is proposed with the value of 0.65 nanogram per liter, you can see that, unfortunately, in our case, for PFOS, in more than 51% of the samples, all the values, all the concentration values were exceeding the EQS. So, having a look to the potential source of pollution in our different sampling points, it seems that the human influence, the anthropogenic activities, of course, are responsible for the higher levels we found in sampling points number 2 and number 3, because are close to the city of Burgos and the city of Valladolid. And we know that there are activities which are very related with PFAS emissions, let's say the airport, for example, or the waste treatment plants, treatment of coating and metal, and disposal of hazardous waste, and so on. So the good news in the case of this study in the Duero River Basin in Spain, we found an overall decreasing trend for PFOS. This is a really good news, maybe because these compounds was regulated in 2009 in the convention, but unfortunately there are still different hot spots where water do not reach the quality standard. So we we need to continue the monitoring of these compounds in the area. Okay, let's move now to another topic. Let's talk now about ocean waters, and I will show you our study in the global ocean. This is a paper published about 10 years ago by our group, and what we did was a really nice global study during the Malaspina expedition on the tropical and subtropical ocean. So this expedition was done between the end of 2010 and the mid of 2011. This is the boat, the Spanish boat, Esperides. And the boat was going around the world during 6 months. You can see here all the legs. I was participating in this leg between South Africa and Australia. And just to let you know, the daily ship schedule is really, really busy. Some example, how was the program every day when we were working on the boat? We were collecting many types of samples and many types of measurements. And we were busy almost the whole day collecting samples. But then focusing on the water sample, on the oceanic water sample, sorry, just a minute. Well, we were able to collect surface water and also water at different depths in the water column. So it was very interesting to be able to use this device, which is called commonly CTD. This is a kind of rosette. And this allows us to take water samples at different depths, and we were collecting the DCM water. And also we were collecting plankton samples, but I'm not going to show you this because I'm talking just about water. Anyway, here you have the picture of the CTD working on the boat, and once you collect the sample on the right bottle, remember, if you are working with PFAS, you have to use PPP bottles. Then you have to filter the sample, you have to add the surrogate standard, and then on the boat, we have a lab where you can concentrate the sample on the cartridge, on the SPE cartridge. And this is stored at -20 until we have the sample in a clean lab where we can do the PFAS analysis. I will show you briefly a few data about the global analysis we did on the global ocean. And you can see here the concentration, the mean concentration for the sulfonic acid, the carboxylic acid, and some of the phosphate we studied. And as you can see, in general, the highest levels were found in the South Atlantic Ocean. Also, as I said before, we were analyzing not only surface samples, but also DCM samples. And again, you can see that as surface water, the highest levels were found here near the coast of Brazil. One of the explanations was that maybe this is because the high use of the pesticide, the sulfuramide, in the Brazilian area. Also, the levels of the DCM were quite similar, always higher in this area. And in general, in terms of average value, the highest mixed concentration, were found in the Atlantic, then in the Pacific, and then in the Indian Ocean. So in general, from this global study, it seems that concentrations are supposed to be higher in the northern hemisphere compared to the southern hemisphere, but it's not always true. as you have seen before, Brazil in the South Atlantic has a very high contamination. And regarding the compound chemistry, normally the sulfonates were always higher in DCM, but more present in surface water. And in the case of the carboxylic acid, let's say before, this compound was much higher on the surface water. Anyway, this is a very complicated study because we have to consider many different factors influencing the PFAS in ocean water. We are talking about different oceans, the coastal distance, also the ocean currents could influence, and so on. Well, this is all the people. I would like to show you and to thank all the people involved in this nice sampling campaign. And then just to finish, because Jordi asked me to explain something about our future activities, I would like to show you the next plan we have for coming soon. In a couple of weeks, there will be a Mediterranean campaign. It's a Spanish project funded by the Spanish Ministry of Science and Technology, and the plan is to take samples all around this sampling point. In this case, the boat, the research vessel will be Sarmiento de Gamboa from CSIC, our institution. And the idea is to do the more possible comprehensive sampling, and that means we will be collecting water samples, surface samples, CTD samples, all possible vertical profiles, even deep sample at 2,000 meters. Also the surface microlayer. You can see here how we collect this kind of samples. Of course, we are planning also to collect a sample, and well, here is the sample of the water sampling. And another idea is to collect sediment sample, and here you have different devices we may use for this kind of sampling. And well, this is all by now regarding water. We are open to any kind of collaboration with you, any help you need from our lab, we are open. Thank you very much. Merci. Gracias.
Merci beaucoup, Begoña. Donc, vous avez vu jusqu'à présent ça biomonitoring sur le lait maternel, par exemple, sur les aliments. Maintenant, avec l'eau, par exemple, vous connaissez la situation en Tunisie et vous avez la photo générale de qu'est-ce que ce sont les polluants organiques persistants. Donc maintenant, c'est le moment d'aller au déjeuner. C'est au 8e étage. On doit aller vers le hall et au hall prendre l'ascenseur directement au 8e étage. Donc, on y va et après, à 1h, je suppose, on commence maintenant. On a 1h pour déjeuner, c'est entrée plat principal dessert et on reprend la session. Donc, on se retrouve. Merci. Merci.
What is the? Merci. So, hello, welcome back. So I'm going now with the second part of my presentation, and this time I will show you our work on POPs monitoring in air. So I think we already are familiar with the contents, so we can skip all these slides and I can go faster, so because we need to economize the time. And I will focus on the Spanish monitoring program on POPs, particularly in air. This program in Spain is based on the use of passive air samplers. Let me see. Yes, now it's working. Yeah. No, but before it was not on, so now it's working. Okay, so the idea when we decided to establish this monitoring program on POPs, the decision was to be able to have a long-term and stable program. I know that our program is a little bit young because we just started in 2008, but now it has been running for some years, so we are very happy. And the idea was to select a wide regional distribution, looking for information from both remote and urban sites. So here you have the map of the Spanish peninsula. And you have all the sampling points we decided to have in the Spanish monitoring program. This was a discussion with the Spanish Ministry of the Environment. And in this project, it is involved our institution as CSIC and also another institution which is called CIEMAT. So we have been producing data now since 2008. Well, I would like also to point out that our program is collaborating with the GAP program from with the leader is Professor Tom Harner from Canada, and we are deploying a sampling point for GAPs in Spain here in the south. I will show you here. Here in the southwest of Spain, the green point, where we have the Doñana National Park, a beautiful place you have to visit. So in this presentation, I will show you some data from this monitoring program, and I will show you the information regarding the sampling point where our group is working. That means that I will be showing half of the data of the whole monitoring program because we are not the owner of the whole data set, okay? Anyway, just to let you know how many samples we have, until now we have a total amount of 406 field campaigns. That means not only 513 samples, but also the same number of field blanks. Again, this is a very important point. You have to collect the real sample, but you have to take a lot of care with the sampling, and this is why you need to use also field blanks in order to check for any kind of contamination, in order to produce a high quality data. So basically, as I said, we are using this kind of passive sampling. Here you have the model we are using. This is a model from United Kingdom. It's quite similar to the model, to the Canadian model. And what we are doing is to collect 4 samples per year for the winter time, spring, summer, and fall. So we are analyzing different class of puffs, and that means that we need to collect at least 4 puffs for the air samples. So we need to use 3 puffs, as you can see here, for all the analysis regarding dioxin, furans, and dioxin-like PCBs. And then we use another different puff, which is used for the analysis of PBDEs and other chlorinated pesticides. This is very important because in the case of dioxin and furans, fortunately, the levels are really low. So we need to collect at least 3 puffs in order to detect the levels of this contaminant. And usually we do a shortlist extraction, and then we need always to do some cleanup, and then finally we use the high-resolution MS instrument specific for dioxin and furan analysis, a DFS instrument. So for data treatment, we usually follow all the guidelines from the GMP. Again, very important to consider the field blanks and also the recoveries of the analyzed. So all concentrations are analytical and field blank corrected. So let's go quickly for the results, and I will show you something of the results we have from our sampling points. Here in this table, you can see the concentration. In this case, the good news for us is that concentrations for dioxin and furan, as you can see, are really, really low. We are almost on the PPQ range, and that is a good news. Then, in the case of industrial contaminants, let's say the PCBs, this is the POP family with usually the highest levels, okay? And also in the case of the ACAs, we also find the highest levels for the pesticides. So looking at the contribution of each family, we are monitoring. Here you can see the general trend when you compare urban and background sites. And in general, you can see that if we look at global scale, dioxin and furans are always the lowest one, and the same go for background sites and also for urban sites. And then in general, the highest levels are always for PCBs. PCBs are always everywhere. Then here you can see the spatial distribution depending on the sampling point we have. Here you have the sampling points in different cities from Spain, and here you have all the sampling points from background sites. All the background sites are usually at the IMEP station in Spain. And as you can see, there are urban locations usually have significant higher levels than background locations. This is quite common. Again, here you can see how for some families in particular, we always found higher level of POPs in urban than in background for PBDEs, PCBs, dioxin and furan, DDTs, and ACAs. In the case of HCB, endosulfan, and pentachlorovincen, we didn't find significant differences between urban and background sites. Then it was also very interesting to see that depending, you can find general trends when you compare urban and background site, but if you look specifically at the sampling site, as you can see here in this figure with the mean contribution of the different families, you can see the differences, and in particular here in the case of the city of Barcelona, you can see how the OCDD congener has very, very high levels. And usually the OCDD used to be related to combustion sources. This is quite common for dioxin in air samples. Again, looking for the spatial variability, when we compare urban and background sites, you can see significant differences. In this case, you can see here data for TEQs. The calculation of TEQs was previously explained by Dr. Rainer Malik. And you can see how, in general, levels for the total of dioxin or non-ortho PCBs or mono-ortho PCBs are always higher in urban compared to background sites. The same goes for the brominated flame retardant for the BDEs. And again, here a nice example is the case of the DECA mixture. You can see how levels are much more higher in urban sites. Again, comparing data in the different cities where we are working, you can see the particular differences depending particularly on the sampling site. And again, you can see how the city of Barcelona is very particular. And here, we always find very, very high levels of DECA BDE. We also tried to explore the seasonal variation because, as I said before, we are collecting samples in different seasons of the year, and we compare winter, spring, summer, and autumn. And you can see here that we found significant seasonal variation, in particular for DDTs, endosulfan, ACV, pentachlorovenzene, and also for dioxin and furan. Coming to the temporal trends with our small data set, what we can see, well, I think we have very good news. We find significant decreasing trends for endosulfan, PCBs, and also for dioxin and furan. But the bad news is that in the case of flame retardants, in the case of PBDEs, we cannot find this trend yet. Particularly because of the high contribution of the DECA mixture in the whole PBDs. The BDE 209 is a very, very high contributor to the total PBD level. Again, here we have the information regarding the toxic equivalent quantities for dioxin and furan. And again, you can see the good news that the levels are decreasing. And even you can see that in the case of background and urban, background in green and urban in red, levels are almost completely similar in both type of location. The same goes for dioxin-like PCBs, where you can see in the case of non-ortho PCBs how concentration for TQs are decreasing and tending to be quite similar at both urban and background side. So just to conclude, some good news is that, in particular for dioxin, furans, and dioxin-like PCBs, both families are reaching low concentration values. So this seems a positive output of the Stockholm Convention. It seems that the measures are being really effective. And in the case of the BDEs and some pesticides, unfortunately, it's not the same, particularly, as I said before, because of the deca mixture of the polybrominated flame retardants. So the question is that maybe in the case of dioxin, we can discontinue this monitoring, or could be we don't need to do it continuously 4 times per year, but in the case of other families like some pesticides or PBDs, we need to continue the monitoring. And just to conclude, I would like to thank all the people from my group, and here you have my contact details in case you need anything from our group. Thank you very much.
Merci beaucoup, Begoña, merci beaucoup. Donc maintenant, on a cette vision générale de l'eau, de l'air, de l'alimentation, de la lait maternel. Maintenant, c'est le moment, par exemple, de préciser sur, par exemple, the guidance on sampling, screening and analysis of persistent organic pollutants in products and articles. Donc maintenant, on va vers le produit. Et c'est le tour de...
Okay. So can I start? Jordi? Okay. Okay, good. Yeah, so good day, everybody. Thank you very much for inviting. My today's talk will be monitoring of POPs in products and the introduction to the Stockholm Convention draft guidance on sampling, screening, and analysis of POPs in products and recycling. When you look to Article 6 of the Stockholm Convention on POPs, which requires parties, among other things, to develop strategies for identifying stockpiles, products, and articles and waste containing POPs. So identifying POPs in products and articles is crucial for their environmentally sound management. And it is at the same time a significant challenge for parties, including Tunisia, but also for the POP Reviewing Committee. The challenge is identifying chemicals in products and articles. One is because of technical limitations, the cost of monitoring, the limited expertise and knowledge, and also that there is a lack of labeling of articles. So therefore, the Stockholm Convention Conference of Parties acknowledged in the 11th meeting these challenges and urged parties to implement Article 6 effectively. So here, the Conference of Parties means the countries requested to the POP Reviewing Committee to explore options for identifying POPs in products and articles, and they were asking to develop a report on this. And this report was just published as an information document at the Conference of Parties in this May, 2 weeks ago. So this document highlights that it recognizes the complexity of identifying POPs in stockpiles and products and articles in many countries and regions, especially in low and middle income countries. And it notes that the report identifies challenges in identifying POP stockpiles, products, and articles, including financial and technology capacity challenges, global regulatory challenges, complexity in value chain, and the lack of disclosure of information on chemical content in articles and products throughout the value chain. So in the first presentation this morning, Kay from the BIS Secretariat highlighted and showed this complexity in the value chains and let's say the understanding of how the flow of POPs in products is with this complex value chain. Also, there is a lack of traceability and transparency in this value chain. And one big issue is regulatory limits. At the moment, when we look, for example, in Tunisia, for most of the industrial POPs in products, probably you do not have a regulatory limit. Yeah. So therefore, when we talk about monitoring POPs in products, the first question is at what concentration we should monitor. Yeah. Monitoring make only sense when there is also a limit and a restriction and regulations. So I have put here a slide from the European Union on the POP regulation with the different limits. And you see on the very right side, here you have the so-called Annex 4 values, limits. So this is for waste. Yeah. And even more important, in Europe, over the years, so-called unintentional trace contaminant limits have been developed. And these are limits for products. And only when you have such limits, then you can make reasonable monitoring and you know at what levels you need to monitor in products, that you can tell this article is a problem in respect to our legislation or not. When we look to our 37 POPs group, meanwhile, we have many POPs listed, which are mainly used in consumer products, often as plastic additives. We have 5 brominated flame retardants. We have 3 chlorinated flame retardants. Begonia just has presented on the PFAS, but let's say she has presented on air and water, but the first part is PFAS in products. So PFAS are also mainly in products, including, for example, textiles or furniture and so on. And some of these POPs are high volume chemicals, yeah, including, for example, from the PBDEs, the decap bromodiphenyl ether, the hexabromocyclododecan, the short chain chlorinated paraffins, the medium chain chlorinated paraffins. So they have been produced in millions of tons in the past. And you have seen from the presentation of Dr. Malish in human milk, yeah, how, for example, the chlorinated paraffin levels are increasing in human milks globally and will be soon the largest POP monitored in human milk. There's also now the first non-halogenated UV stabilizer, UV328, which have been listed, and soon the polybrominated dioxins and furans and mixed halogenated dioxins and furans will be listed, which are also related to products and articles. And the major of these POPs, the major share is in plastic. And this plastic is mainly used in electronics, in transport sector like your cars, in the construction sector. And overall, at the same time, these 3 sectors make around 30% of all plastic used in production. And when you look to Tunisia and to your total plastic stock in Tunisia, these 3 sectors have likely more than 50% of all plastics in your country. This is a view of the sectors: construction sector, electronic sector, and the transport sector. And here on the left side, you see the range of POPs they include. The ones which I marked in yellow, these are basically more or less only in these 3 sectors present. But also, for example, short chain chlorinated paraffins and medium chain chlorinated paraffins have their major use in plastics in these 3 sectors. But when you look into more detail, only a share of the plastic in these major uses contain POPs. What you see in this figure is first the different polymers. This means polyethylene, polypropylene, polystyrene. And on the left side, you see the different application area. For example, here for packaging, you see packaging normally don't contain POPs. I have here included in the red circles the share of plastics which I consider contain POPs, and also roughly the share of that product. When you look here to the building and construction sector, you see, for example, the polystyrene extruded and expanded polystyrene, which is used in insulation foam. A large amount of this foam in the past have been flame retarded. So therefore, we know here this product really contain a large share POPs. But for all others, it's only normally a relatively small fraction. And for most of the spots, for example, here for automotive, you see, I did not put a red spot because there are any data. So this means the use frequency of POPs in products is often unknown. It can be high, like I showed for the EPS, XPS in buildings, or low. And this needs monitoring, and actually it needs more monitoring. I will introduce in this presentation also some case study. But first, coming to the guidance, to the Stockholm Convention guidance, here you have an overview of guidance documents which have been developed in the frame of the Stockholm Convention, a range of inventory guidance. One of them, a new one, is the sectoral POP inventory guidance, which are addressing the three sectors: electronics, buildings, and transport. And here is the guidance on monitoring of POPs in products and recycling. So the background of that guidance was that in 2009, for the first time, POPs which are used as plastic additives or otherwise in consumer goods have been listed. That was at that time polybrominated diphenyl ethers, tetra to hepta BDE, which are also used in electronics, vehicles, and buildings, and also PFOS have been listed in 2009. So at that time, the Secretariat of the Basel, Rotterdam, and Stockholm Convention saw that monitoring of products in the consumer market and in stock and use and waste will be needed. And also some monitoring of electronics is needed to better understand the extent of contamination of plastics also in end of life and the risk of recycling. Because when the PBDE in 2009 were listed, the Conference of Parties decided to make an exemption for recycling because it was unclear if not whole recycling areas would need to stop when listing PBDEs. So therefore, at that time, a guidance document was needed that support parties in the monitoring of PBDEs and PFOS in products and also give information on PBDEs and PFOS in products. So therefore, the Basel, Rotterdam, and Stockholm Secretariat initiated in 2010 a monitoring activity for PBDE in cathode ray tubes in Nigeria that was at that time financed by the Norwegian government. And Professor Osibanjo from the Basel Convention Regional Center in Nigeria and I were tasked to guide and conduct the monitoring study. Additionally, I was tasked to develop a guidance document on monitoring PBDEs in electronic waste plastic and also PFOS in products. So the first guidance which I developed in 2010-11, this included finally the PBDEs, the PFOS, and also we decided to include pentachlorobenzene and hexachlorobenzene, which pentachlorobenzene was also listed in 2009. And by this, to have a monitoring guidance which includes the three major halogen groups: brominated, fluorinated, and chlorinated POPs in consumer products. This guidance was then extended in 2016 and 17 to include the POPs listed in 2013 and 15, including hexabromocyclododecan, PCN, pentachlorophenol. And the guidance was updated in 2021 with then the POPs listed in 2017 and 2019, including also short-chain paraffins and PFOA. So when we developed in 2021 and updated the guidance, we also included the circular economy and recycling aspect in the guidance, because we have now a global push to circular economy. And also when we are moving to circular economy, there need to be even a better control of POP in recycling. Yeah. So at the moment, the recycling rates in Tunisia are probably also relatively low for plastics. But now you certainly will have governmental activities to move to more circular economy. And when you move to more circular economy of plastics, you need to think on the fate of POPs. And this is one reason for that guidance. So here, this guidance provides guidance on monitoring, including sampling, screening and analysis of POP content in articles and products listed from 2009 to 2022. So guidance is provided here, first on different articles and products possibly containing POPs, to develop strategies for monitoring of POPs in products and circular and recycling streams, on inventory development aspects, and also to determine emission and impact factors for major material flow. And when we look into detailed chapters of the guidance, you see here the fluorinated POPs are addressed here in chapter 3, brominated POPs, PBDEs, HBCD in chapter 4. We have one chapter about polychlorinated naphthalines and PCBs in products and recycling, one chapter of short chain and medium short chain chlorinated paraffins, one chapter about pentachlorophenol, in one chapter because pentachlorophenol is, for example, used in leather, in textiles, and in wood, so also major product categories. And also we developed one chapter about all unintentional POPs in products, including dioxins, PCBs, hexachlorobutadiene, pentachlorobenzene, PCNs, and hexachlorobenzene. In chapter 2 of the guidance, at the start, there are general consideration and cross-cutting issues. This includes also capacity building of monitoring in low and middle income countries, a section on quality assurance and quality control, a section on international standards for analysis of POPs in products, and one section about certified reference materials and interlaboratory studies. So when you are thinking in Tunisia, for example, to develop monitoring of POPs in plastic, the first thing is really to establish that and to have a high quality monitoring. And for example, for this, you need certified reference materials and interlaboratory studies, where you then finally can conclude that your laboratories are appropriate to do such monitorings. The monitoring guidance has a step-by-step approach to monitor POPs in articles and products. And these steps are elaborated for all the major POP groups in the individual chapters and annexes. So it is a 5-step approach. The first step is a survey of products and recycling streams containing POPs. You can do in Tunisia. The second step is the sample collection. The third step is screening of the products. I will come to details on that. The step number 4 is quantification of POPs in products. And step 5 is documentation and reporting. Now I go through the 5 steps. Starting with the first step, that's the survey of products and recycling flow, possibly containing POPs. Before collecting samples, a survey is needed to conclude and to preliminarily determine major consumer products in use and reuse in the countries that might contain POPs and in which your government or your research institution is interested. Also, in this step, you can look to material flows, those to possibly contain POPs, which are used in recycling, for example, electronic waste plastic or recycling of polyurethane foam or recycling of carpets or textiles or rubber. And here in the guidance, we have in Annex 1 all major product groups and major recycling streams for the individual POPs. So you see here in Annex 1, for example, 1A, we have the PFAS and related compounds in products, then Annex B for the brominated POPs and so on. And you see that this annex alone is nearly 30 pages. Yeah. So here, when you are thinking to develop such a monitoring in your country, you could have first a look to these 30 pages and see, okay, what could be useful or not useful. And then you could select what you find interesting for your countries. So this is just now Annex 1 here for the PBDEs. You see here a long list. And all these individuals like electronics, second-hand electronics, e-waste plastic, there's always a description and some background, yeah, on these different product categories. Then step 2 is sample collection. For sample collection, different stakeholders for the different consumer product categories might be contacted for input, for support, possibly also for providing samples. Relevant stakeholders to be contacted for different POPs use. Sectors would be compiled in this phase. And also here the POP inventory guidance document, and also especially for the different inventory guidances can help you to find stakeholders. Sampling campaigns might be conducted by a research institution, possibly in collaboration with ministries or other competent authorities, or directly with the industry or waste management facilities and related recycling. Samples can also be collected, for example, by the customs at import or by competent authorities, such as factory control or consumer protection authorities. We have also included some good studies which describe different sample methodologies in different case studies. I will come later in the case studies to that. The third step is screening in the field or in the laboratory. As I showed you with the plastics, only a minor share of target products contain POPs. For example, less than 20% of cathode ray tube casings contain PBDEs, and also only a minor share of carpets or textiles contain PFOS, PFOA, or other PFAS. So therefore, sampled articles can be screened for the presence of bromine, chlorine, or fluorine in the field or in the laboratory to minimize the effort of analysis of samples. So such screening enables a relatively cheap and simple pre-selection of samples, and also screening helps to minimize the time and expenses in the laboratory. It does not make sense to measure any plastic which does not contain bromine for PBDEs, for example. The Stockholm Convention guidance for monitoring POPs in products gives an introduction to the different screening approaches in the sampling step. The guidance compile information on screening methods for bromine, chlorine, and fluorine in products and recycling, which can be used for sample pre-selection. Also, some instrumental screening methods for the individual POPs are described, which do not need the extraction and cleanup step, for example, pyrolysis GCMS. Yeah, all this is explained in the guidance. When screening methods are applied, it has to be ensured that the detection limit of the screening method is more sensitive than the limit required for the sampling. For example, if you have a legislation limit, for example, 50 ppm for PBDEs in waste or in a product, then of course your screening method need to be lower than this 50 ppm. Yeah, the same, for example, for PCB, yeah, for chlorine. What you see here, this is the different sections of screening methods for fluorine and organofluorine chemicals possible in products and articles. You see there are 11 methods described, starting from the very simple droplet test where you just put a drop of water or a drop of oil on a textile or on a carpet or on a furniture, and where you can understand from this droplet test if this material contain a fluorinated compound or not, yeah, up to very complicated methods like NMR spectroscopy or certain high resolution methods for screening. Same here for brominated compounds. You see here in chapter 4.4, there are 8 screening methods for brominated compounds. Most of you might know the X-ray fluorescence, XRF spectroscopy, but we have also listed other methods where you could have a look at. For example, for sure, you also have FTIR spectroscopy in Tunisia, which you might use, and also, for example, combustion ion chromatography. Here, just a bit detail to the XRF screening because let's say that's so practical. So screening in the field or in the laboratory can be done with the XRF spectrometer. X-ray fluorescence spectroscopy can be used for detection of bromine in products with a quite low detection limit. It can go as low as 5 ppm. For the detection limit of chlorine, that's higher. Normally, it is higher than 100 ppm. Recently, also the first handheld X-ray fluorescence spectrometer has been on the market. So also now by this mobile, you can screen here products even in shops. But this XRF analysis is limited to the detection of elements. Yeah, it does not have the capacity to identify the chemical. But like I said, it is super for pre-screening. It only takes around less than 1 minute. Yeah, and after that, you can decide if this sample is interested to further analyze or not. If a sample is heterogeneous, for example, if an electronic product contains different plastic parts, then different parts need to be screened here with the XRF, which is also possible. It is non-destructive method, so even you might be able to go to shops and do some screening. And but the use of XRF instruments require a specific instruction for the operator because you are handling X-ray. Yeah, so therefore, probably also in Tunisia, there will be a certain regulatory frame which you need to consider when you buy or handle such an equipment. Step number 4 is quantification. So where available here for quantification, the guidance compile international standards for POP analysis in products and the related references. But for a number of product matrices, no international standards were available. So there I have looked if there are some robust methodologies from some research groups, so-called in-house methodologies. And we have also described for a range of products in-house methodologies, which are not POPs in products. And recycling. And the guidance further referencing in Annex 2 to case studies. And also many of these case studies contain analytical procedures for the POPs in the respective matrices. So here I give you an example on sample preparation, extraction, and cleanup for the brominated flame retardants. So here is a dedicated section about preparation of polymers and plastic samples, then on extraction of brominated flame retardants from polymers and plastics. PBDEs from flexible polyurethane foam, from HBCD in textiles. And this is quite complex and complicated, this method, yeah, because as you will see, plastic is a very versatile matrix. Different plastics behave different in extraction and cleanup, and therefore the preparation need to be adjusted and optimized. I have a friend who is doing this since 20 years, and every month he has some surprises in the cleanup and in the analysis. And care has to be taken that the polymers do not contaminate the instrument. So you deal with a full matrix, and it's easy to get here some of these oligomers into your instrument, and the result is that the GC column is crushed, or even the mass spectrometer might be contaminated. Yeah, so therefore a very optimized cleanup is important for this method. And the second is that when you deal here with samples which can contain up to 20% of POPs, you need to take care not to contaminate your whole laboratory, and also take care of memory effects in glass and in the analytical equipment. Normally, a room which is used for such products, normally the same room you cannot use to analyze low contaminated samples like food or environment or water. So here, then there are different methods on quantitative analysis of the individual POPs. So here you see also as example for the POP BFRs. So here in one section we have a measurement standard for the PBDEs, example of a GCMS setting, but also example of GC-ECD setting or LCMS setting for the instruments. And again, we have a full annex which includes for all relevant POPs in products a full analytical method for the instrumental analysis. Yeah, so here you see this annex is also nearly 40 pages. And for all the individual POPs, you have a full description of an analytical method. Yeah. For example, here for PBDE, you have one method for GCMS described, and also one method of GC-ECD described, or HPLC-MS method for hexabromocyclododecan. One example here just for the GC method for PBDEs. So you see the full temperature program is described, what type of column, what possible instrument, how to make the setting of the injector block, everything. And this instrumental setting we have from top leading laboratories from the world, a big share of them from Shimatsu Techno from Japan. So they were for several years the best laboratory in the world for interlaboratory comparison. Also, we have for all the compounds the detailed masses. So here you see the full masses for the PBDEs, including the quantification mass, the confirmation mass, but also the carbon-13 standard masses, so that you can do a full setup of an equipment for that. And we included for all the methods also a chromatogram. Here, for example, for the PBDEs, and I found it always very helpful. I also worked for 6 years in a research laboratory when I have a good detailed description, including also the chromatograms and the individual congeners numbered. Here, for the short chain and medium chain chlorinated paraffin, we also have 3 methods described. One method, low resolution GCMS. This can be used also for low and middle income countries, this method with normal GCMS. Then we have one method with an Orbitrap, very quite sophisticated instrument Dr. Malish has one in his laboratory. But in many countries in Africa, I'm not sure if there is any orbit trap in whole Africa. And we have described LCMS method from the National Institute of Japan. And this method also allows the monitoring not only of the short and medium chain chlorinated paraffin, but also of the long chain chlorinated paraffin, which you cannot measure with the gas, with the GC. Also, we have three analytical methods for PFAS. We have described two LCMS methods. One is the method of the National Institute of Advanced Science and Technology from Japan, which at the same time is the ISO 21675 method you see on the right side. And also we described a GCMS method from Professor Francis Oral. He made his PhD in Germany, but is since many years back in Kenya and is doing PFAS monitoring in Africa. One challenge here is that most PFAS related compounds, because PFAS and PFOA is just one compound, right? But the related compounds, for example, for PFAS are 165 compounds, and PFOA related substances are more than 300 compounds. And for most of these compounds, no analytical standards are available, as Begonia already highlighted in her presentation. And recently we wrote a paper in which we requested of standards from industry because at the moment many products which are produced from industry are not available as commercial standards. But for example, when you look to pesticides and the EPA, all pesticides need to be given to the authorities in Europe and America, that the laboratories also can analyze these compounds. And in our paper, we proposed that the same should be done for PFOS, PFOA, for the industry, and best for laboratories then globally. At the moment, there's just the total oxidizable precursor assay, where we can, let's say, also analyze and screen for the precursor compounds. And at least by this method, we can also cover and roughly estimate what is the amount of precursor compounds in a sample. Then in Annex 2, we have compiled best practice case studies, where available best practice case studies for monitoring of key product categories, possibly containing POPs, are referenced in Annex 2, where possible case studies or publications were selected, which are also open available. By inclusion of case studies, the guidance endeavors to provide information on already performed major studies and approaches used. So these case studies can be assessed with the view of selecting the most appropriate approaches and methodologies for screening, for sampling and analysis. But my recommendation is not just to repeat, so rather to add good and innovative new case studies. And I hope maybe in 1 or 2 years' time, we also see some good case studies from Tunisia monitoring POPs in products and recycling. So here in Annex 2, you see an overview on the case studies. Also, this is more than 20 pages. And here now I will show and go through the major sectors and show some best practice case studies. First for electrical and electronic sector. So that's actually the case study which we conducted in Nigeria in 2011-12. So at that time, we sampled cathode ray tubes in Nigeria, which contain the average most amount of PBDEs in electronics and electronic waste. So here, two students, PhD students, sampled 380 CRT casings, and then they collected information on manufacturer, brand, model, serial number, year of origin, And we targeted televisions and computers from 1980s to 2006. Why? Because the aim was to understand the former use of the PBDEs which were listed in 2009. And this was commercial octa-BDE and commercial penta-BDE. And their production stopped in 2004. Yeah, that was the reason why we selected and focused on this. So here we also did then a pre-screening with XRF, and then in the second step, a confirmation analysis with GC-ECD and GCMS. So for the pre-screening, the CRT samples were prepared by cutting out a small piece. And these pieces, together with a PhD student, was sent to Germany, to Fraunhofer Institute, and they did the screening here in laboratory. But if Tunisia, if you have a XRF, you can directly do this screening in the field. But at that time in Nigeria, there was no handheld XRF in Nigeria. So therefore, the students cut out the samples and brought them to the laboratory here to Germany. So within 3 months, she did the screening and also the analysis. And here in Fraunhofer, that's actually the institute which is doing since 25 years monitoring of POPs in plastics of electronics. So they have developed a good methodology here, a dissolution precipitation method, where 0.5 gram of polymer is dissolved in 5 milliliter tetrahydrofuran, and then it's precipitated with hexane and filtered, and then with a specific dilution factor, which is also quite complex because such a plastic can include 20% of PBDEs, or it can contain 100 ppm of PBDEs. Yeah, and you want to understand and see them all. So therefore, also this is quite sophisticated, and you might need several injections. And like I said, plastic is a very difficult matrix to analyze with a high risk to contaminate your GCMS, and you really need to take care and have such a kind of a cleanup which is protecting your instrument. This is result from the study. So you see that a high share of these cathode ray tubes were flame retarded here in violet, yeah, purple. So you see that a large share of the computers here from Asia, also the computers from America, contain brominated flame retardants. Here for Europe, the rate was a little bit lower because our flame retardant standards are a little bit different. Yeah, but you see overall the regions were not so different. Yeah, we sampled from each region to understand if there is a difference. Finally, our conclusion was not a too big difference, but for Europe, the flame retardant use was a bit less. Also, when you see here this one in purple, so these were fully brominated flame retardant sample, and this one in green and in red, they contained brominated flame retardant at a level of 100 to 10,000 milligram per kilogram. And this concentration is considered only to stem from recycling and not from full application of flame retardant, because normally you need more than 3% of brominated flame retardant here in your television. And when we then analyzed the PBDE, we found that from the 380 samples, only 4 samples were intentionally flame retarded with commercial octa-BDE. But these 4 samples were already sufficient when you would mix the whole plastic, that this plastic is above 1000 milligram per kilogram and therefore above the low pop content. Yeah, 4 samples out of 400 samples. And 34 of the 380 samples, around 9%, contain deca-BDE in concentration between 617 to 230,000 milligram per kilogram. Also here, the average concentration would be nearly 4,000 milligram. This means 3 to 4 times above the low pop limit of the Stockholm Convention. Therefore, if you just mix these samples together, these polymers can only be for recycling after removal and bromine containing cases and separation. So most electronics consist of several electronic plastic parts, and often only a few of these parts are flame retardant. Therefore, some screening of plastic parts might be needed. I give you here one example. So when you look to the CRT televisions, often the casing is flame retardant, but here the stand, where the CRT is standing on, the plastic is normally flame retardant free because it's not getting hot. And normally only these parts are flame retardant which get hot. So there is one best practice case study for monitoring PBDEs in large and small electric and electronic equipment and individual plastic parts from UK and from Wales. So they screened plastic parts in fridges, and this showed that only a very few pieces and only in some fridges contain high levels of POP BFRs. And these were only the casings, the small casings of electrical and the compressor, and the electrical and junk box and the cable box. But the most outer major plastic parts like doors, side panels, trays, shelves, and so on, they did not contain any flame retardant and any POP. Also, in other large household appliances like washing machines and dishwasher, only a few control boxes contained flame retardant, while all other major plastic components did not contain flame retardants. But this is actually really the only full-scale study which have done such a monitoring. And I think that more studies on monitoring individual plastic parts in electronics for POP additives are needed, including now also the new listed UV328 and Decloran Plus, and best with analysis of all flame retardants and not just a few target components. Then a second best practice study is from the Swiss authorities in 2008. They monitored 1,360 consumer products for brominated flame retardants, including electronics, building materials, and lighting equipment. The monitoring approach taken was also first to do a screening of products with the XRF, then to analyze with GCMS the bromine positive, which had more than 500 milligram per kilogram, and they analyzed PBDEs and other commonly used other brominated flame retardants. In bromine positive samples where neither PBDEs nor commonly used brominated flame retardants were detected, then a Swiss laboratory performed a non-target screening of new brominated retardant to understand what kind of flame retardants are used on the Swiss market. So the study showed that the PBDE content in products in Switzerland and likely Europe market in 2008 was already low. So from the 1,360 consumer product, only 17 samples, this is 1.3%, contain DKBDE above 1,000 milligram per kilogram. And only 2 samples, this means around 0.1% of the samples, contain commercial PBDE. So you see only a very, very few samples in 2008. And before you saw with the televisions from 1980s, 1990s in Nigeria, that they are a large share of the products were flame retardants with PBDE. So already in Europe in 2006, the ROS directive included the DKBDE, and therefore industries started to phase out. This kind of information also is quite helpful for you when doing such monitoring. Overall, the Swiss market survey analyzed 1,900 components. This means also they screened different parts of plastics in products. In total, 470 components contained bromine above 500 ppm, and 214 samples were then quantified for the PBDEs. So here you see more detail of the results. 60 samples contained at least one of the target substances. Yeah, and here just a little bit on detail. When you look here to building materials, you see that in 2008, still a considerable share of the building materials screened. It were only 17 samples, but still around 30% contained DKBDE. Yeah, but the electrical devices already only 10%. Yeah, contained PBDEs. Yeah, for the automotive devices, it was only 7 samples. Yeah, none of them contained PBDEs. Yeah, what you see here in red is that other brominated substances, which were not at that time in the Swiss monitoring for general flame retardants. Yeah, and so you see this kind of monitoring is quite complex. You really need to do a good planning and thinking what you want to analyze, and then also how you want to screen for those where you do not know finally what kind of brominated or fluorinated compounds are there. This is still from the Swiss study. So you see here, these are pictures from those products which contain DKBDE. Yeah, you see most of them black plastic. Yeah, some of this hair, but also tetrabromobisphenol A in different electric products, and hexabromo cyclododecan here in electronic products, and of course in the polystyrene, expanded polystyrene. Then, very important are other screening of the consumer market, like, for example, toys and food contact materials. So often in these black toys, or here you see this coffee cup with the black lid, you find PBDEs at low level, often below 1,000 milligram per kilogram, sometimes above 1,000 milligram per kilogram. And this shows that these have been made from recycling. Yeah, some best practice case studies are here from Kashiwara. She analyzed 1,100 consumer goods from 18 countries, especially toys. And we have this in a webinar where I will give you also the link at the end. But still further studies are needed, especially, for example, there is no study on UV328 in consumer products or Decloran in consumer products. Looking a bit to transport sector, including textile in the transport sector. So there is only one best practice case study actually on the transport sector in the whole world. Yeah, that has been done also in Japan from Dr. Kashiwara. She analyzed 515 parts indoor of 45 vehicles produced between 1993 and 2012. Also, she used XRF approach and then analyzed in the laboratory. What you see finally, the XRF screening showed that only 32 out of the 500 materials and components contained bromine higher than 0.1%, and only 16 of these contained PBDEs or HBCD above 0.1%. The major components were seed fabric. Actually, most of the high contaminated PBDE materials were the seed textiles you are just sitting on when you are in your car, with direct exposure when you have shorts. Also, there were some soundproof materials and floor coverings, and also some seed polyurethane foam contain high level of PBDEs. And actually, that was a penta-BDE. This was a car from the United States, which have used much penta-BDE. 90% of all penta-BDE has been used in the United States, and partly it has been used here in polyurethane foam in vehicles. And finally, you also find it in Japan. What was also interesting was that the low bromine contaminated samples. So you see that 60 more than 10% had bromine content between 0.01 to 0.1%. And 260 out of 500 samples, this means more than 50% of the samples, had bromine levels more than 5 ppm, 5 milligram per kilogram. This indicates that 50% of interior plastic had a secondary contamination with brominated flame retardants. It is not clear if this mainly comes from recycling or partly come from secondary contamination indoor. This means PBDE can evaporate, for example, from the sea textile and then can deposit on other plastics. Yeah, and over the years, this can increase to levels of more than 5 ppm. But similar comprehensive screenings of cars is needed from other regions, including also other. There is no monitoring of Dechlorant Plus and UV 328, which we know are heavily used in cars and other transports, but there is no study on these. Also interesting here, and we will hear more in the next presentation from Pierre, is shredding, shredders and analyzing of shreds of live vehicles. Why I bring it here is to show it's very complicated to understand what is the average content of POPs in vehicles. So it's very complicated to different cars and the different plastic parts. You see already the 45 cars in Japan was for sure a study which was longer than half a year. But here, if you take the shredder from a certain cars, then an average can be generated. And I give you here some examples. Also here, good studies from Japan. For example, they shredded cars which are older than 1996 or 1999. And you see also, like for electronics, the levels here in these cars are relatively high, around 80 gram PBDEs per car. But for the cars which were younger than 2000, so they did a specific shredding for cars which were younger than production 2000, only 20 gram of PBDEs were included in average. Yeah, but you see the whole thing is quite complex, and there will tell you more on the complexity of end-of-life monitoring of POPs. Coming to the building and construction sector, in the building and construction sector, major plastics is PVC, expanded extruded polystyrene, EPS, XPS, polyethylene, and polyurethane. The EPS, XPS, and polyurethane in buildings are frequently flame retarded with POPs, including hexabromocyclododecane or PBDEs, but also other hazardous flame retardants like halogenated phosphorus flame retardants. Also, plasticized PVC often contains large amount of additive, up to 60%, including POPs like short chain and medium chain chlorinated paraffins or restricted phthalates like DEHP or DBP. And I give you a few best practice case studies here for materials. Here I was involved from Beijing University. We screened 124 products on the Chinese market. A high share of the soft PVC and 50% of PVC is finally going into building and construction. And a large share of the polyurethane foam spray, which fully goes into construction, contain very high levels of short chain and medium chain chlorinated paraffin, up to 50% of the product. And the same was found in Europe. You see here a study on polyurethane foam used also in new buildings. So in the Netherlands, they screened also for chlorinated paraffins, and they found that a range of foams contained up to 50% of medium chain chlorinated paraffins and up to 30% of long chain chlorinated paraffins. Yeah. Additionally, also here, organophosphorus flame retardants is contained, and these materials then are also gassing out these additives and contaminate finally the indoor environment with high levels in house dust. This is a study also contaminating indoor environment from a friend of mine, Professor Vetter, and his PhD student Sprengel. They analyzed kitchen huts, and they found in the kitchen huts where the suction system is high levels of short and medium chain chlorinated paraffins. And then they were looking in the kitchen in different materials where these short and medium chain chlorinated paraffins come from. And finally, they found that a major source were ovens, the baking oven. And the baking oven, they contain PVC cables. The PVC cables contain up to 10 to 15% of chlorinated paraffins. And when you heat the oven, then these chlorinated paraffins evaporate from the cables. And they directly go not only in the kitchen, but they directly go into the food. And Professor Vetter also analyzed that. What was impressive, that 50% of 20 of these baking ovens in Germany contain these very high levels of chlorinated paraffins in the indoor of the baking ovens. Here, a best practice study from monitoring of additives in PVC in Switzerland. So they analyzed 150 flooring samples. They determined the polymer type, and only for PVC they were looking. They looked for the phthalates. Range of the phthalates are restricted by REACH regulation. They also analyzed what alternative plasticizers are in, and they analyzed elements like cadmium and lead, which is frequently used as additive in PVC in the past. And they also did biomonitoring for toxicity of extract of these flooring samples. And they found that 16% of the samples contained regulated chemicals above 0.1%, mainly lead and phthalates, this DEHP. Also, they concluded most probably from PVC recycling from older PVC where high amount of lead and DEHP were used. Unfortunately, in that study, they did not analyze the short and medium chain chlorinated paraffins because that analysis is quite complex, and at the ETH at that time, this analysis was not available. So for Tunisia, that would be an interesting study. You could look to your PVC floorings and what kind of additives are there. So also, I give you one study, because I know you had in Tunisia a study about EPS and XPS and HBCD in that material. And in future, there will be the question on EPS, XPS, if in the demolition of a building, if it contains HBCD or not. And a friend of mine from Fraunhofer Institute, Dr. Schlummer, he invented a method, which is a simple testing method, which you can do directly on site. And you do not need to take a sample and bring it to the laboratory and wait 1 week to decide if your samples contain HBCD. So here, what he has done, he has taken an XRF, and then first you screen your EPS, XPS for bromine. If it contains bromine, then you take a little bit acetone and you put your EPS in the acetone, and then EPS shrinks. And if you have HBCD, the HBCD is going into the acetone phase. And if you have the other flame retardant, which is used in Tunisia, this is the polymeric flame retardant. This polymeric flame retardant does not go into the acetone phase. So therefore, in the first step, they analyzed the EPS, and in the second phase, they analyzed and screened with the XRF also the acetone. And you see here, by this method, you can distinguish very easily between here one EPS which contain the polymeric flame retardant. You see here, the PS is bromine positive, but the acetone is negative. Yeah, while for others, yeah, where you have positive EPS, and also a positive acetone phase, you know, okay, this contain hexabromocyclododecan. Unfortunately, today there are more products on the market, and this also includes some additive flame retardants. Therefore, this method need to be refined when you are doing monitoring. There are many more polymers which are flame retardant actually in buildings materials, but there are hardly any study on that. PBDEs have been used frequently, as you have also seen in the Swiss study, but there is actually no study in the whole world about PBDE in products in buildings. Yeah, so therefore we have initiated a year ago now one monitoring study on PBDE in plastics in buildings, where we also did a screening, and these samples are currently analyzed. So this time, unfortunately, I cannot show results. Maybe next time. Yeah. But this kind of monitoring of POPs in construction and demolition is very important. Pierre, in the next presentation, will show you more, because it is the biggest waste flow in future, also for your country. And in Germany, we had now the first project about what kind of plastic might be recycled from buildings and materials, and also guidance documents have been developed. A last case study, what we have done on monitoring of POPs in plastic and recycling. We have done recyclates in middle and low income countries, which was related to the global monitoring plan. So here in that study, we have sampled 270 plastic pellet samples and 100 shred samples in 3 different world regions. From Africa, we have selected Nigeria and Ghana at that time. From Asia, Mongolia, Vietnam, Thailand, Indonesia. From South America, Brazil, Argentina, and Chile. We have sent the samples to 6 different laboratories: National Laboratory of Japan, Fraunhofer Institute, Germany, Tokyo University, Spanish National Laboratory, the colleagues of Begoña in Barcelona, and the National Material Institute in Thailand. And the different institutes have screened for different POPs. I just show you very few results in a minute. One is on PBDEs. These were found overall in the highest concentration. And you see from these recyclates, we have first screened with bromine. You see here from the 270 pellets, 190 pellets were below 15 milligram per kilogram. Yeah. And this shows nearly 3/4 of all samples didn't contain any brominated flame retardants. Yeah, and this you do not need to analyze. Yeah, and the others we analyzed. So there we found that 9 samples had PBDE concentrations above 1,000 milligram per kilogram. Further 3 samples were above 500 milligram per kilogram. And 12 samples further were between 50 and 500 milligram, and then 25 samples were between 15 and 50 milligram per kilogram. What you also see with the colors is that basically only high impact polystyrene and the ABS plastic were above the 500 milligram per kilogram. So you see also here that some flame retardants were very specific in the application of the different polymers. Yeah. Also for this, it would be nice to have more such detailed studies. Some major findings of the studies: the plastic recycling in the assessed low-income country was largely uncontrolled. So therefore, also when you look now in Tunisia about plastic recycling, it's quite interesting to understand what plastic is recycled and what products are produced. So here for our developing countries, we have seen that often from this recycling, it directly went into food contact products or toys or skin contact products. Then PBDEs and short and medium chain chlorinated paraffins were detected in major relevant polymers, sometimes above basal low POP content and also above the unintentional trace contaminant of Europe. Yeah. but major other countries do not have at the moment unintentional trace contaminant. Yeah. So when you think about POPs in products, I think that's the first step. Then Decloran Plus and UV328, we also have screened about 120 samples, and we found that they were frequently below detection limit. So overall, from the 120 samples, only 3 samples contain Decloran Plus above 1 milligram per kilogram, and only 3 samples contain UV328 higher than 1 milligram per kilogram. Yeah, so you see, this is another concentration class compared to the PBDs, yeah, and the chlorinated paraffins. Also, we analyzed teeth that was analyzed in the Spanish National Laboratory. So they were in the nanogram per kilogram level. And plastic recycling is a field for monitoring and assessment and regulatory control. Currently, major plastic additives have several provisional low POP content in the Basel Convention. So also there for countries at the moment, and maybe you can tell me afterwards if Tunisia already has decided for Tunisia low POP content. But it will be especially interesting to develop unintentional trace contaminant limits. And also here, maybe it's interesting for the science community to think what would be science-based levels in respect to exposure. Of course, POPs are only the tip of the iceberg in recycled pellets. Therefore, in our study, we also, like in the Swiss study, we used bioassays where we evaluated extracts from these recyclates in respect to endocrine effects, in respect to genotoxicity and dioxin-like toxicity. So I think considering the complexity of plastic and plastic recycling, this bioassay approach need to have more attention. And I know, for example, that Nestle, the biggest food producer in the world, they are using bioassays to evaluate the dioxin at the endocrine compounds in their packaging material. And the policy of Nestle is to have no endocrine disrupting effects in their food packaging. So this is now nearly the end. So there's an update of the guidance documents. At the moment, I am working on that, including the POPs listed in 2023 and 2025. This means also UV328 and Decloran Plus. Also updating international and national standards on analysis of POPs and adding some new case studies. Also, we had in that project from the Global Monitoring Plan, we had a 5-day webinar, each around 3 to 4 hours. And the topic is just to analyze POPs in plastic. Yeah. So now I gave you 45, 50 minutes, but here you have 18 hours of webinars, which is online of the website of the International Panel on Chemical Pollution, where I'm a member. And those which are interested, part 1 is understanding POPs in plastic, part 2 is on sampling of plastic, and part 3 is on extraction, cleanup, and analysis of POPs in plastic. So, depending on the time, Jordi, is the time over? Jordi?
Yes, you can.
Is the time over, or do I have a few minutes left?
It's almost over, but if you have these 5, as the Rainer say, as a German one, you can have 5, but not more, 5, 10. You can continue, Roland.
Let's say that's a small addition, and I think it's interesting. It is. Yeah, but it's only a few slides on unintentional POPs in products. Yeah. Also, unintentional POPs are present in a range of chemicals and products, such as pesticides, pigment dyes, or food and feed additives, and can enter consumer products, for example, in paints or in the food chain. Europe has recently set a law in unintentional trace contaminant for hexachlorophene in chemicals, mixtures, and products which is 10 milligram. Currently, Europe is establishing a low unintentional trace contaminant limit for PCBs in mixtures and protein and food, and where already gave on the analysis. And also, there are some unintentional trace contaminant limits of dioxins. For example, in Japan has a limit of dioxin in pesticides. So this is a good case study from Japan, which shows PCBs in pigments, which are used for paints. And Japan has a unintentional trace contaminant of 50 milligram per kilogram, and you see here that there are some pigments up to 2,000 milligram per kilogram of pigment, And so in Japan, these pigments are then taken out of the market, This is another example. This is tetrachlorophthalic acid or anhydride. This is a high-volume product which is used to produce a range of high-volume pigments. So here also Japan did a market survey, the Japanese government, and hexachlorobenzene were found up to 3,000 milligram per kilogram. This means 3 grams of hexachlorobenzene in the chemical product, which finally goes also in the paint and pigment, which is partly used also in children toys or in printing products. And this is one of my favorite slides. Overall, it's the historic inventory of dioxin released in the Japanese environment, which showed that actually the biggest pollution of dioxin in the world did not come from open burning or from incineration, but that actually in the 1940s, 50s, 60s, 70s, and 80s, the chlorinated aromatic chemicals released tons of TEQ into the environment. This is here only for Japan. So here in the rice fields, pentachlorophenol pesticide and CNP pesticide every year around 30 kilogram TEQ into the rice field, into the environment. In total, Japan had nearly released a half ton of TEQ into their rice field. And this you can compare to the total release of dioxin in the world of around 100 kilogram TEQ per year. The total of India, China, everybody combined, is 100 kilogram TEQ. Just the aromatics in Japan in the 1960s and 70s were half a ton into the environment. And we have done a monitoring of pesticide in Australia in 2010 in a PhD, and we analyzed around 25 pesticides for dioxins, and all pesticides contained dioxin, all, which we analyzed. So this second study here, where I have some data, is from the United States. This is, they have analyzed also 2,4-D for dioxin levels. But what was special is that they have used the instrumental analysis and also a Calux TEQ. This means a bioassay for dioxins. You see the correlation was quite nice here for the 2,4-D, but then there were some pesticides where you didn't find any TEQ with the instrumental analysis, but the pesticide, the bioassay, showed very high TEQ. So here, 1,700 picogram per gram TEQ. This is comparable, no, that's per gram, like a fly ash. And you see the reason is that they did not contain chlorine, they contain bromine. So this means that there were brominated aromatic compounds in these pesticide, or here with this nitrogen group, which had actually a very high dioxin-like toxicity, but we would never understand from instrumental analysis. So therefore, I think that the dioxin-like toxicity in pesticide would be one of my favorite to screen in countries. And I think there will be a very interesting outcome. Only 3 samples on food and feed. Here, screening of eggs and dioxin-like toxicity. So Brambilla and another study here found high dioxin levels in the eggs. And finally, what was the source? The source was wood. Yeah, and this was recycled wood. Contained pentachlorophenol, and pentachlorophenol is always related to dioxin contamination. So also here, where I said we have wood sampling and wood screening is quite interesting in respect to waste wood. This is a screening from China on copper sulfate. Copper sulfate is an important mineral supplement for animal nutrition. So the last 2 decades, recycled copper is used in copper sulfate production partly. And in China, it was mainly used from recycled copper sulfate. The levels were above the European limits for feed. And the source, finally, was actually copper sulfate, which were recycled with secondary HCl from various processes from electronic industry. And the dioxin contamination actually came from HCl, because about 2/3 of all HCl, hydrochloric acid, is secondary HCl from industry. And sometimes they come from processes with very high levels of dioxins. Yeah, so here for China, they contaminated the copper sulfate, which were used as a feed additive. Last example, zinc oxide. Also, zinc oxide is partly used as feed additive and food supplement. Zinc oxide can be produced either from virgin ores or can be produced from recycling processes. Here from Dr. Mali's laboratory in 2014, you see very low levels in zinc oxide from virgin ores, but there were zinc oxides detected from a food case in Chile, where they contaminated meat in the worth of $200 million dollars. And the level here was 17,000 nanogram TEQ per kilogram TEQ, sufficient to contaminate the whole meat from Chile. So the source of such highly contaminated zinc oxide is zinc recycling with the Wells process. So after the Wells process, you get zinc oxide, but there you need a very, very strong cleaning if you would want to use this in the food and feed industry. Yeah, thank you for your attention.
Thank you very much, Roland. Thank you very much. And now that all the people knows that they have 18 hours to watch more explanations, they are happy. And now nous allons faire la pause café et on revient dans un quart d'heure maximum, plus ou moins.
Peut-être on ne va pas faire le pause café directement. On va continuer la dernière présentation. En même temps, il y a une attestation de participation pour...
D'accord.
Donc, celui qui veut peut-être quitter, il y a une attestation. Donc, s'il vous plaît, vous pouvez continuer la présentation.
C'est bon pour vous, Pierre? D'accord. Mais après écouter Pierre, s'il vous plaît, vous pouvez sortir un petit moment pour prendre le manger, parce que sinon on va le gaspiller, et ce n'est pas le cas. Mais maintenant, c'est à vous, Pierre.
Merci. Bonjour. Donc, je vais parler en français. Donc, je sais qu'il est tard. Hein. On va essayer d'aller droit au but. Voilà. Alors, surveillance des POP dans les déchets. Donc voilà le plan de l'exposé. Les POP, je ne vais plus vous les présenter, vous les connaissez aujourd'hui. On va se centrer sur les plastiques, puisque les plastiques sont largement additivés avec des substances qui étaient autorisées à l'époque de la fabrication de ces articles, mais qui sont devenus POP depuis. Et les plastiques sont recyclés le plus largement possible. Voilà, il faut vérifier la présence de retardateurs de flamme bromée dans les plastiques recyclés. Alors, par quelle méthode de mesure? Donc, 3, la mesure. Ça ne va pas être des mesures de labo, ce seront des mesures de terrain que je vais vous présenter. Ensuite, on rentre dans les résultats, c'est-à-dire que, et vous l'avez vu dans les présentations précédentes, on a toujours des distributions de concentration asymétriques, c'est-à-dire beaucoup de valeurs faibles ou inférieures à 0, et puis quelques valeurs fortes, donc jusqu'à 5%, 15%, puisque un retardateur de flamme bromée, il est utilisé normalement à 10 ou 15% en concentration dans le plastique, sinon il n'a pas d'effet retardateur de flamme. Donc 15%, ça fait 150 000 mg par kilo. Et donc vous comprenez tout de suite que il faut isoler, ce que dit Roland d'ailleurs, il faut absolument séparer les quelques particules à 100 000, 150 000 mg par kilo parce qu'elles font monter la moyenne de tout le lot, donc des 99 autres pourcents de particules, de 5, 6, 7 mg par kilo à 1500, 2000, 2500, et donc font dépasser les limites autorisées pour le recyclage. On va vous présenter tout ça. Donc les conséquences, il faut trier. Il faut augmenter le taux de collecte pour capturer correctement tous ces retardateurs de flamme bromée. Et quand on fait des contrôles de conformité, il faut échantillonner correctement, puisqu'il faut être sûr que si ces particules très concentrées sont présentes dans la population, dans ce qu'on veut échantillonner, rares, il faut que dans l'échantillon soit suffisamment grand pour qu'il y ait la même fréquence de ces particules rares dans l'échantillon que dans la population. Sinon, vous sous-évaluez la concentration. Alors, la gestion, voilà, quels sont les modes corrects de gestion? Ce n'est pas le stockage. Et des questions donc, plus organisationnelles ou plus politiques, c'est-à-dire, bon, qui paye, puisqu'il faut incinérer les POP, donc c'est une dépense, c'est un coût. Qui? Donc, en Europe, on a... Après beaucoup de tâtonnements, on a réglé ça par le principe de la responsabilité élargie du producteur et sa mise en œuvre par des organisations qui ont un mandat public. Je vais vous expliquer ça brièvement. Et donc la conclusion, c'est qu'il faut construire collectivement, donc toutes les parties, les metteurs les autorités publiques, les instituts scientifiques, les metteurs sur le marché, les recycleurs, les consommateurs, les associations, les fédérations professionnelles, un système qui permette d'éliminer ces substances. Alors, les POP, donc vous les connaissez, voilà, ça c'est une partie d'un tableau, ce sont des pesticides. Regardez à droite, donc la dernière colonne, c'est une colonne qu'on appelle annexe 4, c'est-à-dire c'est la teneur maximale de chacune de ces substances qui peut se trouver dans un matériel. Par exemple, des bidons plastiques ayant contenu le pesticide ou des emballages de produits phytosanitaires qui ont contenu le pesticide et où il y a eu une certaine imprégnation du polymère, puisque dans la préparation commerciale, les pesticides, ils vont être à 200, 300, 400 grammes par litre. Donc, vous comprenez bien qu'il y a une partie qui va un polymère, c'est comme un plat de spaghettis. Le polluant, le principe actif, le pesticide, va diffuser dans ce plat de spaghettis. Donc, au-dessus de 50 mg par kilo, vous ne pouvez pas recycler, par exemple, des emballages phytosanitaires. Pour les retardateurs de flamme bromée, donc il y a des différentes concentrations. Bon, l'hexabromodiphényle, il est obsolète. J'essaie d'avoir le pointeur là, mais je ne le vois pas. Ah pardon, je me trompe. Voilà. Donc l'hexabromodiphényle, il est... Pardon, j'ai changé de dia. Je remonte. Non, excusez-moi. Alors, l'hexabromodiphényle, bon, sa production a été limitée aux États-Unis, voilà, on n'en trouve jamais. Bon, les bromodiphényléters donc, sont importants, présents. Ce qu'il faut retenir, c'est 1000 mg par kilo pour la Somme. Et en Europe, il y a eu des décisions donc, de baisser progressivement au cours du temps la limite dans les plastiques recyclés. L'hexabromоcyclododécane, donc ça c'est un exemple qu'on vient de voir, c'est dans le polystyrène d'isolation des bâtiments, 1000 mg par kilo avec une baisse progressive. Bon, il y a encore d'autres substances, donc je vais passer ça puisque vous connaissez toutes ces listes de POP. L'important, c'était la colonne limite maximale de concentration. Alors, il faut évidemment pouvoir déterminer dans un lot de broyeurs de plastique venant de l'automobile, dans un lot de plastique venant de la construction, contiennent-ils des retardateurs de flamme bromés interdits? Première étape, donc c'est la sélection par la teneur en brome total. On dispose d'un appareil. Voilà, donc c'est un fluorimètre portable qui a été présenté déjà plusieurs fois. Donc en 30 secondes à 1 minute, vous mesurez environ 40 éléments. Il faut que vous ayez une calibration pour les plastiques. Cet appareil existe par exemple chez les ferrailleurs qui vont déterminer les alliages, la qualité des alliages inoxydables, la teneur en chrome, en vanadium, en nickel, puisque la valeur de ces déchets, qui vont être de ces ressources, dépend de ces teneurs. Ils vont déterminer les différences entre le bronze et le laiton, donc qui sont des alliages cuivre, zinc, étain, etc. Donc ça existe. Ça existe chez les géologues qui font de la prospection minière. Je suis sûr qu'il y en a plusieurs en Tunisie. Ça existe dans les bureaux d'études de cités sols pollués, etc. Mais, donc il faut s'assurer qu'il y ait l'option du logiciel plastique si vous faites de la mesure de brome, de chlore. Alors, donc contrairement à ce qu'a dit Roland avant moi, malheureusement, donc on peut pas mesurer. Enfin, on mesure le fluor. Il existe un appareil qui mesure le fluor total, mais seulement à des concentrations entre 1 et 10%, avec une chambre spéciale à l'hélium et un équipement spécial. Donc, mesurer 1 à 10% de fluor, je n'ai pas présenté les limites pour les PFAS, etc., mais c'est très, très, très au-dessus. Donc, vous allez détecter du téflon ou donc des plastiques qui sont pas encore interdits, c'est leurs précurseurs qui sont interdits. Le téflon, c'est très utile voilà, dans tout ce qui est frottement, joints, bagues, etc. Donc vous allez détecter qu'un plastique est du téflon, vous n'allez pas détecter de façon significative des PFAS. Donc pour l'instant, c'est chlore et brome. Alors voilà, vous avez tous les intérêts. Donc si un plastique contient du brome total, ça ne veut pas dire qu'il contient des retardateurs de flamme bromés POP, puisqu'il y a eu substitution des molécules au cours du temps. Donc c'est darwinien, hein, c'est-à-dire l'industrie a toujours évolué. Elle, par exemple, dans les bromodiphénylétères, elle a fait le penta, puis l'hexa, puis l'hepta, puis l'octo, et puis le déca. Voilà, elle a toujours évolué. Voilà, je ne me souviens plus du cas, mais il y a un cas où en fait ils ont rajouté un hydroxyle à un endroit dans une molécule. Oui, c'est ça, c'est le substitut du décabromodiphényléther qui porte un nom, je ne me souviens plus. Ils ont rajouté un groupement OH dans la molécule, voilà. Sauf qu'elle a le même effet endocrinien que l'hexabromodiphényléther, que le décabromodiphényléther, pardon. Donc c'est une course permanente entre l'industrie qui sait que ça va être interdit, qui substitue, et les labos, la recherche, les instituts publics qui identifient, qui font les dossiers, qui aboutissent à une discussion scientifique, à l'interdiction. Et pendant ce temps-là, l'industrie a déjà préparé l'additif suivant. Alors, voilà un exemple. Tout ça, c'est publié. Vous avez la liste des références à la fin. Ce que je veux vous montrer ici, donc, c'est sur 5 groupes, c'est-à-dire déchets d'équipements électriques et électroniques, véhicules en fin de vie, plastique de la construction, textile et ameublement, et emballage non alimentaire. Donc, pour ces différents retardateurs de flamme que vous connaissez ici, donc le nombre de données de la littérature, au total, là, tout ça, ça fait environ 5700. Donc, on a épluché pendant 3 mois des publications, etc. Alors, ce que je veux vous montrer, c'est la différence entre la médiane et la moyenne. Donc, la médiane, vous savez que c'est la teneur atteinte par 50% des échantillons quand vous les classez par ordre croissant. Hein, c'est comme l'espérance de vie, c'est la durée de vie atteinte par 50% de la population. Et la moyenne, c'est la moyenne que vous connaissez. Donc, à partir du moment où vous avez 7 mg par kilo de teneur médiane et 2600 de teneur moyenne, ça veut dire que vous avez quelques particules, vous voyez, 154 000 mg kilo, qui vont complètement tirer la moyenne. Sauf que si vous ne les enlevez pas du lot, que vous broyez tous ces plastiques, vous les recompondez, comme on dit, vous en refaites des granules qui repartent dans la plasturgie, vous allez avoir cette teneur moyenne, et qui est, dans ce cas-ci, au-delà des 1000 mg par kilo qu'on avait vu, annexe 4, la colonne de droite des tableaux. Vous voyez? Donc, ce sont des distributions complètement asymétriques. Alors, voilà, ce sont les mêmes données, quelques exemples. Donc, ça, c'est un histogramme de fréquence, c'est-à-dire ici vous avez des concentrations, ce sont des gammes, c'est pas présenté mais ce sont des gammes sur une échelle linéaire, et sur l'axe Y, donc la fréquence cumulée. Donc vous avez environ 90% des données qui sont à 0, limite de Canty, et puis quelques valeurs, ce sont des fréquences cumulées qui font augmenter, enfin quelques valeurs qui aboutissent, donc qui sont présentes jusqu'à 150 000 mg par kilo. Ça, c'était dans les plastiques d'équipement électrique électronique. Dans les plastiques de véhicules, c'est la même chose. Vous voyez, de nouveau, 90% de plastique propre, entre guillemets, et puis on monte jusqu'à des valeurs très élevées. La même chose dans les plastiques de construction, la même chose dans les textiles. On retrouve toujours cette même distribution. En fait, vous l'avez vu plusieurs fois dans les exposés précédents, mais les auteurs n'utilisent pas toujours une échelle linéaire ou définissent eux-mêmes des gammes, mais en réalité, ce sont toujours ces mêmes distributions. Voilà, l'hexabromocyclododécane dans les plastiques de construction, donc dans le polystyrène, vous voyez, toujours 90% 100 et 10% contaminés jusqu'à des concentrations très fortes. Alors, les mêmes données, donc présentées en pourcentage d'échantillons dépassant les limites. C'est un travail qui a été fait pour la Commission européenne, donc auquel j'ai participé. C'est-à-dire, bon, la limite était à 1000 mg par kilo, par exemple pour le décabromodiphényléther. Et donc, on leur a produit ce graphe en disant, voilà, vous avez 84% des données de la littérature qui sont inférieures à 1000 mg kilo. Si vous descendez la limite réglementaire à 500, vous avez 80% des données. Donc, on perd 4% du plastique qui ne sera plus recyclable, puisqu'il sera au-dessus de la nouvelle limite. Si vous mettez la limite à 250 mg kilo, vous allez descendre à 79% de plastique recyclable. D'accord ? Donc, ce sont des études d'impact pour les législateurs qui permettent de fixer un curseur raisonnable, puisque dans l'économie circulaire, il faut accepter qu'on n'arrivera pas dans les recyclats à la pureté de produits neufs qui viennent de la pétrochimie, du raffinage, donc il y a toute une série d'étapes, et puis de la synthèse des chimiques dans l'industrie chimique, des retardateurs de flammes bromés. Voilà, il y aura une moindre pureté. Donc les plastiques seront un peu moins purs. La question, c'est est-ce que c'est acceptablement pour l'environnement et pour la santé publique moins pur, ou est-ce que non, il faut arrêter? Alors, toujours un exemple de distribution. La distribution, on a vu des distributions bimodales, c'est-à-dire 90% à zéro et puis des valeurs. Ici, ce sont des tubes cathodiques, c'est-à-dire c'est les caisses des grosses télévisions, comme l'étude du Nigeria qu'a présenté Roland. Et là, c'est trimodal, c'est-à-dire que c'est 350 données, ça a été produit par moi-même. Donc, vous avez une grande partie des échantillons qui sont à zéro. Puis, vous avez des échantillons qui sont environ à 3000 mg kilo, ce qui n'est pas ignifugeant. Ça ne retarde pas les flammes. Et on le voit, d'autres chercheurs ont trouvé ça. On pense que c'est du plastique ignifugé, c'est-à-dire la dernière partie, là c'est 80 000, 100 000, 150 000 mg kilo, qui a été recyclé. en petite proportion, et donc qui aboutit à des caisses de télévision où il y a un peu d'hexabromоcyclododécane, mais pas assez pour avoir un effet iniffugeant. Vous voyez, ça c'est un cas de mauvaise économie circulaire, où des plastiques avec de l'hexabromоcyclododécane ont été recyclés, voilà, sûrement de bonne foi, mais donc ce qui donne en distribution, voilà, des distributions comme ça, trimodales. Alors, quelques données rapidement sur les perfluorés, parce qu'il y en a très peu dans les déchets. Donc, vous voyez, voilà, vous commencez à connaître, toujours la même chose. Donc, ce sont des données de la littérature. Donc, vous avez toujours 90% des données très basses, et puis quelques teneurs plus élevées, donc jusqu'à 600 mg kilo. Voilà, ce sont des articles, différentes choses. Ça, ici, c'est un focus sur le supérieur à 10 mg kilo. Donc, vous voyez l'échelle. Donc, c'est un zoom de la première partie ici de cette distribution, puisque donc l'échelle X s'arrête à 10 mg kilo. Vous avez là un détail, c'est 83% des données de l'ensemble de l'étude. Non, pardon, de l'ensemble des plastiques inférieurs à 10 mg kilo qui sont inférieurs à 1. Qui est la limite pour recycler aujourd'hui en Europe. Donc, voilà. Le problème, c'est comment extraire les 17 autres %. Alors, bon, ça, je passe. Donc, voilà ici un exemple. Enfin, on a recherché quels articles quels articles avaient une concentration supérieure à 10 mg par kilo. Et donc, voilà, ce sont des agents d'imperméabilisation, la photographie, ça c'est nanospray, cleaner, etc. Voilà, bon, vous voyez que ce sont des teneurs faibles, ce sont des traitements, des additifs. Les fortes teneurs sont des membranes perfluorées qu'on trouve dans des batteries de véhicules électriques, donc ça va être un sujet, dans des électrolyseurs, dans des... c'est utilisé dans l'industrie des semi-conducteurs, mais comme solvant, donc ça ne se retrouve pas dans les chips électroniques. Voilà, il y a quelques secteurs professionnels qui sont vraiment concernés, qui utilisent beaucoup de PFAS. Sinon, par exemple, le textile, c'est fini. Depuis 5 ans déjà, par exemple, Decathlon, qui était un gros utilisateur de Gore-Tex, je ne sais pas si vous avez vu que Gore-Tex contenait des... Donc, vous voyez ce que c'est le Gore-Tex? Donc, c'est des textiles respirants. Donc, votre transpiration s'en va, mais quasiment imperméable à l'eau. On peut vous pleuvoir dessus, vous n'allez pas être mouillé. Donc, c'est miraculeux. Ça fait passer dans un sens et pas dans l'autre. Eh bien, donc, depuis plus de 5 ans, le groupe Decathlon a trouvé un substitut non fluoré secret qu'il ne mentionne pas, et il va contrôler chez ses fournisseurs en Asie une fois par an que c'est bien cette molécule-là qui est utilisée. Voilà, ils visitent leurs producteurs, ils vérifient, ils demandent les étiquettes, les factures, les bidons, etc. C'est Dixit Decathlon. Donc, ils ont éliminé les PFAS. Donc, par exemple, dans les textiles, déjà, c'est très faible. On est dans les milligrammes kilos. On n'a pas de méthode de terrain pour les trouver. On ne peut pas analyser chaque textile au labo. Et de toute façon, l'industrie est déjà un pont plus loin, comme on dit dans la guerre. Donc, ils sont déjà une étape avant nous. Donc, il faudra se concentrer, à mon avis, pas sur ces sujets-là, mais sur les déchets de l'industrie donc des électrolyseurs, voilà, certaines parties des industries électriques, électroniques qui utilisent ça et qui se retrouvent dans leurs articles, qui de toute façon sont des articles qui ont de la valeur. Les batteries électriques, les batteries des véhicules électriques, personne ne va les abandonner, personne ne va les laisser. Au contraire, les constructeurs souvent louent la batterie à l'acheteur de la voiture. On vous loue la batterie, donc on vous la reprend quand elle est usée. Parce qu'il y a une lutte mondiale pour les métaux, donc lithium, vanadium, lithium, tantal, cobalt, etc. Et donc, voilà, ils cherchent à assurer leurs ressources pour les productions futures. Donc, ces déchets-là, ils ne seront pas abandonnés, ils seront gérés par des grandes sociétés industrielles et donc contrôlables et gérés de façon sérieuse. Donc, personnellement, je ne suis pas tellement inquiet pour les PFAS, mais bon, j'espère ne pas me tromper. Alors, voilà, ça c'est ce que je disais. Donc, malheureusement, pour les perfluorés, d'après Brucker, donc, qui est le seul fabricant d'instruments à fluorescence exportable, il annonce une limite qui est sur son site de 1 à 10%. Donc, ça n'a pas d'utilité vraiment pratique. Alors, donc, c'est toujours les mêmes données. Donc, comment faire donc, face à ces problèmes de distribution asymétrique? Alors, donc, je conclus. On a de façon générale ces distributions asymétriques. Il est impossible de prédire la concentration d'un retardateur de flamme dans un objet donné ou même dans une population. Il faut faire des mesures. On n'est plus dans une logique de distribution gaussienne ou normale. Et on a énormément de cas qui illustrent cela. Alors voilà, toujours les mêmes données. Je vais passer. Donc, ce sont les derniers centiles qui créent la moyenne, comme je vous l'ai dit. Je passe. Oui, pardon. Juste, excusez-moi, je reviens en arrière. Ça, c'est intéressant. Donc, vous avez ici donc des plastiques bromés vrac, voilà, avec leur distribution simple et la distribution cumulée. Et là, des plastiques bromés triés, c'est-à-dire qui sont passés dans une machine que je vais vous montrer plus tard. Et même après tri, vous avez encore cette distribution, mais vous ne dépassez pas les limites de concentration. Mais donc, apparemment, c'est vraiment inhérent à ces plastiques, c'est que vous avez à chaque étape, même dans la partie tout au début de la courbe, vous avez toujours cette distribution asymétrique. Alors, une conséquence de ça, et on peut faire un calcul, on va supposer qu'on a un plastique où on a 90% des particules à 0 mg/kg. Vous voyez, on a vu ça fréquemment dans toutes les distributions. Et 10% des particules à 100 000 mg/kg, ce qui est la concentration fonctionnelle. D'accord ? Donc, on a un broyat des équipements électriques et électroniques, on sépare les métaux, et puis on a un broyat de plastique ou une série de plastiques, et on va faire un calcul théorique pour savoir s'il vaut mieux, pour éliminer les POP, c'est-à-dire ne pas qu'ils partent dans le recyclage, dans les nouveaux articles qui reviennent en contact avec les consommateurs, ensuite qu'ils soient recyclés, etc., pour arrêter la boucle des POP. Comment faut-il faire? Est-ce qu'il faut abaisser la limite de concentration réglementaire ou est-ce qu'il faut collecter plus? Bon, il faut faire certains calculs qui sont simples. Donc, je reprends. On a une population, on a 90% à 0 mg/kg et 10% à 100 000 mg/kg. La moyenne, c'est 0,9 fois 0 plus 0,1 fois 100 000. Donc, ça fait 10 000. Bon, on est au-dessus de la limite de 1000. Alors, on suppose que le taux de collecte initial, c'est-à-dire l'ensemble de ces plastiques dans toute la société, dans toute la ville, il n'y en a que 50% malheureusement qui sont collectés et qu'on autorise dans les matériaux recyclés 1000 mg/kg. Donc, pour l'instant, ce lot-là, il ne peut pas aller en recyclage, il est en teneur moyenne 10 000. Donc, on va calculer un effet de la réduction de la concentration autorisée ou un effet de l'augmentation du taux de collecte. Alors, c'est publié, c'est sur Internet, c'est pas très compliqué, mais enfin, voilà, voilà. Et ça donne ceci, c'est-à-dire, en termes de déchets, quand on passe d'une limite de concentration de 1000 mg/kg à 500 mg/kg, on va perdre 2,5 kg. C'est-à-dire on pourra recycler 455 kg de plastique et on va passer de 455 à 452,5 kg. Voilà. Si on augmente le taux de collecte de 50 à 75% en gardant la même limite de concentration initiale de 1000 mg/kg, le taux de plastique recyclé va monter à 682,5 kg. D'accord ? En gris, c'est le plastique qui est pas recyclé, donc il va se retrouver typiquement dans les décharges. Donc lui, en augmentant le taux de collecte, il passe de 500 kg, puisqu'on collectait à 50%, à 250 kg, puisqu'ici on collecte à 75%. D'accord? Bon, ça c'est le plastique. Ça, maintenant, la substance concernée, c'est-à-dire un POP, eh bien, dans le premier cas, donc situation initiale, on suppose que les POP séparés, c'est-à-dire les fractions les plus traitées, les plus bromées, sont mises de côté et partent à l'incinération. Donc, dans le premier cas, on va détruire, incinérer 4,5 kg de POP. Dans le deuxième cas, c'est-à-dire j'abaisse ma limite de concentration, on va détruire 4,75 kg de POP, donc on a gagné un peu. Et dans le cas où j'augmente ma collecte jusqu'à 75%, avec la même limite initiale, on va détruire 6,75 kg de POP. Donc le plus important, c'est de collecter. Et en Europe, on a ce problème de collecte insuffisant. Donc, il y a des campagnes télévisées en permanence, etc. Les éco-organismes dont je vais parler sont obligés de le faire. C'est dans leur cahier des charges. Il faut convaincre la population de mettre les équipements électriques, électroniques, etc., dans des systèmes de collecte séparés. Une fois qu'ils sont dans les ordures ménagères générales, c'est perdu. Et si ça part en décharge, eh bien, les lixiviats de décharge contiennent des POP qui vont dans le milieu naturel, qui partent dans la biosphère. Et donc, comme le docteur Kay l'a montré, ça finit par circuler sur la Terre entière. Donc, il faut mieux augmenter le taux de collecte que baisser les limites. Le législateur, il a tendance à baisser toujours les limites, laver plus blanc, comme on dit. C'est bien, mais en réalité, il faut aussi que les consommateurs, les recycleurs, les vendeurs, ceux qui gagnent de l'argent en vendant ces produits, fassent chacun leur part d'effort pour que le taux de collecte augmente et que ces matériaux soient correctement recyclés. Alors, troisième conséquence, échantillonnage représentatif. Ce sont des questions pratiques, c'est-à-dire un recycleur produit un lot de plastique, il doit montrer à son acheteur qu'il contient moins de 1000 mg/kg. Comme on l'a vu, avec cette distribution asymétrique, c'est pas facile. Bon, la réponse, elle est là. C'est-à-dire, c'est 17e siècle, Bernoulli, c'est les tirages aléatoires, les boules blanches et les boules rouges. Donc, j'ai une population de boules, j'ai 1%, 10% de boules rouges. Si je tire 20 boules, qu'est-ce que j'aurai comme... J'aurai un certain nombre de boules rouges et de boules blanches. Si je retire 20 boules, j'aurai un autre, le plus souvent, c'est la loterie. Vous n'allez pas tirer, vous n'allez pas avoir la même fraction de boules. Ça va varier d'un échantillon à l'autre. Donc, c'est ce qui est représenté ici, dans ce cas-là, c'est-à-dire... donc, j'ai une population où j'ai 5% de particules rares, c'est-à-dire de boules rouges. Je tire 200 boules. Bon, j'arrive pas trop à lire parce que je suis un peu sur l'angle là. Donc, si je répète ce tirage de 200 boules, je vais avoir parfois 1 ou 2 boules rouges, en moyenne 10 boules rouges, puisque 5% de 200 boules, ça fait 10 boules. Mais j'aurai parfois 15, 18 boules rouges. Voilà, c'est la variation. Donc, la moyenne, elle est exacte, mais vous avez une variation assez importante. Je n'arrive pas à lire les chiffres là, mais je vois. Si vous prenez, si vous voulez, l'intervalle de confiance à plus ou moins 95%, vous allez avoir entre 3 ou 4 boules rouges et 14-15 boules rouges. Si vous répétez, si vous répétez l'échantillonnage. Si vous augmentez la taille de votre échantillon, c'est-à-dire ici je prends 2000 boules et pas 200 boules, évidemment j'ai une meilleure représentativité, puisque j'ai plus de chances que le nombre de boules rouges dans mon échantillon, la proportion des boules rouges soit la même que dans la population. Donc, et plus j'augmente la taille de l'échantillon, plus la distribution des résultats, si je répète l'échantillon, se resserre. Donc, la précision de mon échantillonnage est meilleure. D'accord ? Alors, on choisit typiquement une précision de 10%. Ce sont les carrés verts, là. Donc, on détermine le nombre de particules à prendre par la loi binomiale en fonction de la fréquence des particules rares par ce niveau cet intervalle de confiance que l'on veut dans l'échantillonnage. Alors, tout ça se trouve dans la littérature qui a été publiée. Je vais directement en conclusion, c'est que vous devez, pour avoir 10% de variabilité dans vos échantillons, vous devez utiliser cette formule. C'est-à-dire, si j'ai 1% de boules rouges, P c'est la fréquence des particules rares, donc le pourcentage de boules rouges, mais exprimé en fraction, donc 0,01, 1%. Pour avoir, si je répète mon échantillonnage dans cette population à 1% de particules rares, il faut que je prenne n égale 100 sur P, c'est-à-dire 100 divisé par 0,01, donc ça fait 100 fois 100, donc ça fait 10 000. Il faut que je prenne un échantillon de 10 000 boules pour être sûr, avec une répétition de 10%, que j'ai bien la même fréquence de particules rares dans mon échantillon que dans ma population. À partir du moment où j'ai le nombre de particules, la masse de l'échantillon est égale au nombre de particules fois la masse d'une particule. Je parle de broyat d'articles. Donc, si une particule a une masse de 10 grammes et que dans le cas précédent, on avait calculé pour une fréquence d'1 millième n égale 100 000, eh bien, la masse de l'échantillon doit être 100 000 fois 10 grammes, donc 1 million de grammes, donc 1 tonne. Vous voyez, c'est pas je prends un seau, même au hasard, etc., dans un gisement. Non, non, c'est 1 tonne, c'est-à-dire vous devez organiser un échantillonnage et vous ne pouvez pas réduire cette masse d'1 tonne si vous n'avez pas rebroyé, recréé des particules, remélangé, pour reprendre de nouveau, dans cet exemple-ci, 100 000 particules. Vous voyez, c'est une chaîne, voilà. J'avance. Donc, attendez, je vais vous montrer quelque chose. Voilà. Donc, la chaîne, c'est ça, c'est-à-dire, j'ai le gisement, je dois broyer, donc je crée des particules. Je peux prendre un sous-échantillon, parce que j'ai beaucoup de particules. Je dois rebroyer, je reprends un sous-échantillon. Et c'est logique, puisque on part de 50 tonnes, 100 tonnes des lots, on prélève 1 tonne, et à la fin, le laboratoire, il va utiliser dans son extracteur entre 0 et 1 gramme. Et oui, vous devez évidemment préparer en détail l'échantillon et le broyer, le mélanger à chaque étape. Sinon, c'est impossible que ce gramme, à la fin, il représente 100 tonnes. Bon, donc je reviens en arrière. Alors, on a... le problème, c'est de comment connaître la fraction des particules rares. Hein, puisque tout est... Je retourne en arrière. Donc, n égale 100 sur P, m égale n fois la masse. Donc, l'inconnu là-dedans, c'est P. Alors, finalement, on a de la chance. C'est-à-dire que, je vous laisse lire, on a 2 grandeurs. On a la concentration fonctionnelle en additif, c'est-à-dire, par exemple, on sait qu'un retardateur de flamme doit être utilisé à 10%, 100 000 mg/kg. Ça se trouve dans les catalogues des producteurs. Et on connaît la concentration moyenne que ne doit pas dépasser un lot pour pouvoir être recyclé, la limite de concentration. Donc finalement, par un calcul simple, c'est-à-dire que la fraction non contaminée, c'est 1 moins P, la fraction contaminée, c'est P, la fraction des particules rares qu'on cherche, fois la concentration fonctionnelle. Donc, on a que la concentration moyenne de la population, c'est P fois CF. On a une limite, et donc, on n'a donc que P fois CF, c'est-à-dire la concentration moyenne, doit être inférieure à la limite de concentration. Et donc, finalement, P est inférieur à la limite de concentration sur la concentration fonctionnelle. J'espère ne pas vous avoir perdu. Exemple concret. Décabromodiphényléther, limite de concentration dans les recyclables 350 mg par kilo, c'était un des premiers tableaux qu'on a vu. Concentration fonctionnelle 10%, 100 000 mg par kilo. P égale LC sur CF, 0,035. N égale 100 sur P, il me faut 28 500 particules pour être sûr d'échantillonner correctement ce lot. Et si j'ai 10 grammes par particule, donc de plastique déjà broyé, j'ai un échantillon pour labo. En pratique, on va le rebroyer sur site parce que beaucoup de labos n'acceptent pas des échantillons de cette taille, de 285 kg. Voilà, ce n'est pas 5 kg dans un sac qui partent au labo vite fait, c'est tout un travail qui aboutit à des échantillons représentatifs. Sinon, et on l'a vu dans tous les éco-organismes en France, vous avez 9 fois sur 10 des teneurs très basses, et puis tout d'un coup, vous avez un échantillon qui est au-dessus du lot, et qui montre que le lot, qui entre-temps souvent a déjà suivi sa vie, ne doit pas être recyclé. Alors, c'est une erreur de labo. Mais non, parce que bon, parfois on va au labo, on vérifie. Enfin, une erreur, il faut démontrer factuellement l'erreur. Il y a eu une transcription erronée manuelle, mais aujourd'hui dans les labos, vous avez une chaîne électronique continue depuis le devis, la commande, la constitution de la liste des analyses, l'analyseur, le résultat de l'analyseur, les dilutions, la masse, la prise d'essai et le résultat. Donc, il n'y a plus des techniciens qui sont là avec du cahier ou des calculettes, puisque quand on fait de la saisie manuelle de données, il y a 1 à 2% d'erreur. Donc ça, c'est un vrai problème. Aujourd'hui, ce sont des chaînes électroniques continues, donc il faut montrer. Et non, ce sont en fait, de temps en temps, si vous prenez des petits échantillons, 9 fois sur 10, vous n'aurez pas les particules rares, donc ça vous est dans les 90% à zéro. Et puis de temps en temps, vous aurez un échantillon avec une particule rare. Pim, 2000, 3000, 5000. Alors que vous étiez à 5, 6, 7, 8. Donc, ce n'est pas le labo qui s'est trompé, ce n'est pas une aberration. Si vous avez regardé les présentations dans l'air, dans l'eau, vous aviez chaque fois, donc là je m'adresse à Bégonia, vous avez chaque fois certaines teneurs maximales que les analystes n'aiment pas, qu'ils éliminent parce que les distributions ne sont plus gaussiennes, donc vous ne pouvez plus faire la statistique classique. Test de comparaison de moyenne, test de Tukey, etc. Donc, mais ce ne sont pas des erreurs, à moins qu'on prouve que le labo s'est trompé, qu'on a, je ne sais pas comment, mais non, ce sont des données qui existent, qui ne plaisent pas, mais en fait, on se rend compte que chaque fois que l'homme intervient dans un milieu naturel, sur un processus, on a ce genre de distribution. On va avoir quelques points concentrés, et puis avant ça, une distribution qui va s'étaler. Voilà, donc ce ne sont pas des erreurs, ce sont des réalités. Alors, je passe au traitement. Donc, ça c'est donc du texte, c'est copié du guide de l'UNEP, Programme des Nations Unies pour l'environnement, sur le traitement des POP. Donc, il y a 4 opérations qui sont acceptées. Le traitement physico-chimique, c'est-à-dire une transformation irréversible, bon, ça c'est vraiment des choses spécialisées où on commence pour certains phtalates, on commence pour certains retardateurs de flamme, et bon, la rentabilité est toujours très... Ça se fait dans les labos universitaires, ça ne se fait pas dans l'industrie, on va dire aujourd'hui. L'incinération, et donc c'est après validation, c'est-à-dire il faut qu'il y ait des essais très solides de teneur dans les fumées, voilà, pour vérifier les performances effectives de l'incinérateur, donc 850 degrés, 2 secondes, régime turbulent, etc. Refroidissement rapide des fumées pour éviter la formation des dioxines et furanes. Voilà, c'est toute une technologie. Donc, il faut valider, ce n'est pas n'importe quel incinérateur. Utilisation comme combustible, donc typiquement dans le monde, ce sont les cimenteries. Vous avez 7 ou 9 cimenteries en Tunisie, donc voilà, il y aurait des possibilités. Il faut valider, c'est-à-dire faire un essai où on entre une quantité de plastique connue, vous voyez l'importance de l'échantillonnage, parce que, voilà, hétérogène, et on analyse donc les fumées, les résidus d'épuration de fumée, les cendres, voilà, et pour vérifier que la destruction des POP est effective, que vous ne créez pas, en détruisant des retardateurs de flamme bromée, que vous ne créez pas des dioxines et furanes chlorées, bromées et mixtes chlorées, bromées, il y en a 5000, je crois, les chlorées, bromées. Bon, Voilà, donc tout ça, ça doit se faire par la science, mais vous avez certainement des labos et des bureaux d'études qui sont capables. Et vous avez aussi, donc, en des opérations de métallurgie, voilà, une possibilité. Donc, je continue. Alors, donc, il faut, quand vous avez des lots de plastique identifiés, il faut emballer, et je pense en particulier au polystyrène, hein, qui contient donc de l'HBCDD, certains. Donc, l'hexabromocylododécane. Je ne sais pas si vous vous souvenez, mais il y a 5-6 ans, il y a une tour qui a brûlé à Londres. Donc, une tour qui était isolée par l'extérieur. Donc, on fait un immeuble en béton et puis on colle du polystyrène à l'extérieur. Ça coupe tous les ponts thermiques, donc thermiquement, c'est très bien. Le problème, c'est que vous imaginez, si ça prend feu en bas, vous avez une colonne de combustible pour l'incendie. Donc, tous les 5 étages, il faut mettre du polystyrène bromé qui va arrêter. Donc, ça va être tumescent, c'est-à-dire la flamme va être... Le polystyrène va devenir un peu liquide, il va couler sur la flamme. Ça ne va pas tout à fait éteindre, mais ça va arrêter la propagation rapide. Et donc, les pompiers ont le temps d'intervenir, etc. Donc, il y a pas... Dans les immeubles en Europe, je ne sais pas ici, du polystyrène bromé. Alors, Roland vous a montré un test de terrain, voilà, je ne reviens pas là-dessus pour savoir, parce qu'il existe aujourd'hui enfin, quand j'ai dit polystyrène bromé, il y a du polystyrène qui contient de l'hexabromocylododécane, et l'industrie a fait du polystyrène où le brome est directement greffé sur la chaîne du polymère styrénique. Donc, ce n'est pas POP, ça ne se libère pas. Donc, le problème de l'hexabromocylododécane, c'est qu'en fait, il n'est pas fixé par des liens covalents au polystyrène. Et donc, par exemple, en décharge, il va lentement éluer et partir dans les lixiviats de décharge. Donc, l'industrie a fait comme substitut du polystyrène avec un lien covalent carbone-brome fixe. Il y a aussi d'autres, ils appellent ça des additifs réactifs. Il y a aussi d'autres substituts. Donc, je reviens sur le sujet de la dia. Donc, l'emballage, c'est que quand vous transportez du polystyrène, vous comprenez bien qu'il faut l'emballer. Sinon, ça s'envole du camion, tout simplement. Que ce soit avant tri ou après tri. Étiquetage à trier, si ce n'est pas trié. Alors, les déchets normalement non dangereux avant tri, l'hexabromocylododécane, donc le retardateur de flamme du polystyrène, normalement n'est pas dangereux puisqu'il a une concentration fonctionnelle qui est là, donc environ entre 9000 et 14 000 mg/kg, c'est moins que les polybromodiphényléthaires. Le DKBDE, lui, n'a pas de mention de danger, mais il a une mention persistant, bioaccumulable, toxique, polluants organiques persistants et substances hautement préoccupantes. Bon, ça, ce sont des règles européennes, je n'insiste pas. On trie les plastiques. La fraction dense, je vais vous montrer une machine ensuite. Il faut l'étiqueter à incinérer et puis il faut faire un transport vers un incinérateur qui doit être un transport conforme aux déchets dangereux en fonction des teneurs. Donc, je n'insiste pas sur cette question de transport maintenant. Alors, le tri, donc vous avez ici, ça c'est une image d'un brevet américain qui est tombé dans le domaine public, mais les principes sont toujours les mêmes. Donc vous avez un mélange de fractions denses et noires et pas denses claires. Une flottation, donc c'est un bain dont la densité est ajustée en Europe à 1,1 kg par litre. Entre autres, il y a une société franco-belge qui a développé ça depuis les années 80, qui a vendu des machines au Japon, qui en vend dans le monde, etc., qui a plus des machines qui tournent partout. Donc vous avez une suspension et donc les particules denses tombent et les particules légères flottent. Voilà. Donc ça c'est un peu la théorie, parce que si vous avez une vis ou un boulon dans une particule légère, évidemment elle va tomber, etc. En fait, vous imaginez qu'à l'échelle de milliers de tonnes, c'est plus compliqué que ce qui est là. Donc ici vous avez un égouttage, de la suspension qui est reprise, qui est réinjectée ici, voilà, etc. Donc, ce sont des machines qui tournent. Alors, pourquoi cette densité? Donc, ici, vous avez en X des densités, la densité des matières plastiques additivées, donc de 0,9 à 1,4 kg par litre. Et ici, donc, le polypropylène, le low density polyéthylène, donc polyéthylène basse densité, polyéthylène haute densité, vous voyez, qui sont inférieurs à 1. Donc, ce sont ceux-là qui flottent, ce sont ceux-là qu'on retrouve dans la mer ou dans les rivières. Tous les autres, dans une rivière, ils sont censés couler, à moins que ce soit une bouteille plastique qui contienne de l'air et qui avec son bouchon fermé. Voilà, celui-là, il va flotter, mais sinon, il coule. Alors, ensuite, vous avez le PP20, c'est du polypropylène avec 20% de talc. On trouve ça dans les meubles de jardin, par exemple. Puisque le polypropylène, c'est une matière chère, donc on le dilue, entre guillemets, au talc. Alors, high impact polystyrène, donc c'est le polystyrène choc, c'est le polystyrène des caisses de télévision, d'articles ménagers, d'ordinateurs, c'est-à-dire, bon, c'est du polystyrène choc qui ne va pas casser facilement. Acrylonitrile butadiène styrène, donc un autre plastique, des mélanges polypropylène et polystyrène, etc. Voilà, donc c'est classé par ordre de densité. Bon, pour info, vous voyez le PVC dur, il est très loin, il est très lourd. Le polycarbonate, voilà, ils sont lourds. Le PVC, soft PVC, donc c'est le PVC avec des plastifiants, voilà, il est plus dense aussi. Donc vous voyez qu'on peut séparer. Et donc typiquement, l'industrie en Europe, elle a mis la limite à 1,1 kg par litre. Et donc, elle a en flottant ce qui est à gauche et en coulant ce qui est à droite. Je reviens sur la diapo précédente. Donc, ce qui va flotter ici, voilà, c'est le polyéthylène. Le polyéthylène n'a pas de valeur. Le polypropylène a de la valeur et le polystyrène a de la valeur. Et donc, je retourne. Vous voyez qu'ici, on va avoir le polypropylène, le polystyrène, un mélange PPE-PS. Voilà, ce sont les plastiques et on va avoir l'ABS. Après, il faut des séparations. C'est encore un mélange de plastique, donc il faut une séparation. Ça se fait par tribo. Enfin, on fournit l'électricité statique aux échantillons séchés et on les sépare suivant un champ électrique. Bon, c'est hors du sujet ici. Mais donc, voilà, il faut encore... On a une fraction mélangée. Vous voyez avec ce graphe qu'on va avoir plusieurs types de plastiques qui vont se retrouver dans la fraction légère. Alors, donc, je continue sur la gestion. Donc, on peut faire un stockage, toujours selon le guide UNEP, on peut faire un stockage temporaire, puisqu'évidemment, par exemple, un collecteur de déchets, bon, il a besoin de stocker jusqu'à pouvoir faire 1 camion, 5 camions, etc. Donc, voilà, alors les autorités doivent fixer des volumes donnés, des temps de résidence, etc., pour éviter les dérives donc, qui sont arrivées en Europe de gens qui accumulent, qui encaissent l'argent du traitement des déchets, qui encaissent, et puis qui laissent tout, et qui s'en vont, ou qui ça atteint des quantités telles, un jour il y a un incendie, enfin voilà, que des problèmes de la très mauvaise gestion. Donc il faut fixer des règles de maximum de stockage. Pas de stockage dans des décharges permanentes, puisque ça finit par lixivier, c'est montré, donc uniquement dans des incinérateurs après validation, comme je vous ai déjà dit. Alors, j'arrive vers la fin, donc c'est un peu plus politique. Alors, les déchets contiennent des parties rentables, hein, le fer, l'aluminium, le cuivre, les circuits électroniques, et des parties non rentables. Bon, qui va gérer les parties non rentables? Alors, à l'échelle mondiale, la solution réussie consiste à inscrire dans la loi le principe de la responsabilité élargie des producteurs, c'est-à-dire ou des metteurs sur le marché, des importateurs, puisque ce sont ces personnes qui ont gagné de l'argent en vendant les produits. Voilà. Alors aujourd'hui, il n'y a plus de substances POP dans les produits qui arrivent aujourd'hui, enfin, sauf exception, puisque ces substances sont interdites et l'industrie a toujours pris de l'avance. Mais on est obligé de gérer le passé, l'héritage. C'est des télévisions qui ont 20 ans, des véhicules qui ont 25 ans, 30 ans, où ces substances n'étaient pas encore interdites. Donc, il faut obliger les parties prenantes à la mise en œuvre de cette responsabilité élargie par une ou plusieurs organisations de responsabilité des producteurs, d'une part, puisque c'est eux qui, comme ils ont gagné de l'argent, c'est eux qui doivent organiser la collecte et le recyclage, et les recycleurs doivent être certifiés. Hein, vous avez tout un système de certification qui se développe à l'échelle mondiale où il y a des inspecteurs qui viennent vérifier que telle entreprise a bien les capacités de traiter correctement tel flux. Et donc, l'organisation des producteurs qui a organisé la collecte peut envoyer les déchets vers ce recycleur. Alors, pour ce faire, dans certains cas, l'État donne le droit aux entreprises privées à but non lucratif, non, donne le droit à une entreprise privée qui a un but non lucratif, qui est créée, cette entreprise, elle est créée pour organiser la collecte de l'argent et financer les coûts de collecte, de transport, d'entreposage, de tri et traitement de ces déchets. Je m'excuse, la phrase est mal rédigée, mais donc l'idée, c'est qu'il y ait une société privée qui a des buts précis fixés par la loi et qui a le droit de collecter une taxe. L'État définit les objectifs, quantité, taux de collecte, etc. Est-ce qu'il faut un point de collecte par commune, etc. Et contrôle les résultats. Généralement, les objectifs sont négociés avec les professionnels pour être réalistes. Hein, c'est-à-dire, bon, par exemple, un taux de collecte des vieux équipements électriques, bon, je ne sais pas, la première année, ce sera peut-être 15%. Hein, on ne peut pas atteindre directement 50% en plus. Alors, les ORP, c'est-à-dire les organismes de responsabilité des producteurs à but non lucratif, sont acceptés après une procédure d'appel d'offres pour qu'il y ait une libre concurrence et doivent rendre des comptes 1 à 4 fois par an sur les tonnages, les objectifs, etc. Afin de vérifier qu'ils ne sont pas en train de ne pas travailler ou qu'ils sont très loin de leurs objectifs ou qu'ils les ont dépassés, pourquoi pas. Alors, l'expérience montre que la gouvernance de ces sociétés privées, les organisations de responsabilité des producteurs, doit inclure les recycleurs et le secteur informel. S'il n'y a que l'industrie productrice vendeuse, vous avez des problèmes. Je vous donne 2 cas. Donc, un cas où il y a un organisme, c'est des cas français, l'éco-organisme écosystème, qui est en procès avec un recycleur, enfin un réparateur qui s'appelle Envie, qui utilise des personnes en insertion professionnelle, qui le forment. Donc c'est des gens qui collectent dans les déchetteries des machines à laver, des frigos, les réparent ou pas et les remettent en vente avec un certificat. Bon, personnellement, ma machine à laver, elle vient de là-bas, par exemple. Bon, eh bien, écosystème veut avoir la propriété du métal, du cuivre, du fer, etc., des machines à laver que Envie récupère en déchetterie et qu'ils n'arrivent pas à recycler. Et Envie dit non, écoutez, nous on a fait tous les frais d'études, etc., de traitement, de collecte. Donc non, la matière, elle est pour nous. Et bon, mais ça part en procès. Un autre cas, donc c'est Renault en France qui fait son propre système de responsabilité élargie du producteur. Ils ont le droit selon la directive cadre déchets. Et donc, ils passent des contrats avec des broyeurs automobiles en disant, à un moment, vous allez broyer que des Renault et les marques associées. Et là, bon, d'accord. Mais là où ça va plus, c'est que Renault dit, je suis propriétaire des matières sortantes, la fraction valorisable, pas la fraction non, ça ils n'en parlent pas, hein, la fraction non rentable, là, voilà. Mais je suis propriétaire du fer, du cuivre, parce que ça devient stratégique aujourd'hui, et c'est moi qui vous fixe les prix de rachat. Et donc, FEDEREC, la Fédération des entreprises de recyclage en France, est en procès avec Renault, puisque ce n'est pas possible. C'est-à-dire le client, il ne vous oblige à travailler qu'avec lui, et il fixe lui-même le prix d'achat. Et donc, le débat, c'est qui est propriétaire de la matière. Et bon, moi, je pense que c'est le recycleur, c'est-à-dire il a fait tout l'effort. Le producteur, il a déjà gagné sa vie, entre guillemets, voilà. Il ne peut pas dire, voilà, j'ai une Renault, mais vous me l'avez vendue, vous ne pouvez pas, après, bon, elle est en fin de vie, je la mets dans un centre chez un broyeur automobile, Renault ne peut pas dire, attendez, c'est à moi. Non, c'était à vous, c'est plus à vous. Voilà, c'est à celui qui a collecté, trié, enlevé les pneus, les batteries, les big bags, fait tout dépolluer, l'essence, le carburant, broyer les métaux, séparer le cuivre parce qu'on ne veut pas de cuivre dans l'acier, traiter les plastiques, etc. Voilà, et tout ça, ça coûte pas zéro. Hein. Donc, voilà, vous voyez, il y a des conflits. C'est pas une solution super miracle. Et donc, ce qu'on pense aujourd'hui, c'est que la gouvernance doit inclure toutes les parties. Ce n'est pas que les metteurs sur le marché. C'est d'ailleurs écrit comme ça dans la directive cadre déchets. Et il y a une autre question qui se pose. Il y a une mission parlementaire récente en France qui a remis un rapport. C'est le réemploi, donc qui est quelque chose qu'on veut favoriser puisque c'est le plus économe de carbone et de gaz à effet de serre. Réparer un téléphone, réparer un ordinateur, réparer une machine à laver, c'est beaucoup moins coûteux pour la planète que d'en broyer une, de recycler, ce qui est très vertueux, mais d'en faire une autre. Donc le réemploi doit-il être géré par les organismes de responsabilité du producteur, c'est-à-dire ceux qui vendent des machines neuves, parce qu'évidemment, bon, on va vous dire, bon, je ne sais pas chez vous, mais chez nous, c'est oui, mais attendez, monsieur, vous savez, votre machine, là, il faudra la réparer, ça va coûter 300 €. Mais pour 350 €, vous en avez une neuve ici. Hein, qu'est-ce que vous choisissez? Bon, voilà. Donc, le vendeur, il ne va pas favoriser le réemploi. Enfin, s'il est dans sa logique à lui. Donc, il y a des discussions. Est-ce que le réemploi doit être géré par ces mêmes sociétés ou pas? Bon. Alors, donc il y a, voilà, ça c'est une suggestion, bon, je répète un peu, donc il faut savoir qu'il y a beaucoup de documentation technique sur tout ça, voilà, c'est facile. Alors, est-ce que ce système existe en Tunisie? Ça m'intéresse de savoir. Est-ce qu'il y a des groupes de travail par secteur avec les parties prenantes? Est-ce qu'il y a des projets? Est-ce que c'est déjà réalisé? Et bon, est-ce qu'il y a un règlement? Voilà, ça m'intéresserait de savoir ce que vous avez réussi à faire, parce que voilà, en Europe, ça a été une construction d'au moins 30-40 ans, voilà, c'est pas si évident. Alors, je conclus. Donc, la gestion des produits en fin de vie pouvant contenir des POP, donc qui est une fraction non rentable, nécessite un système de collecte séparé, un système de traitement, un système de destruction, une chaîne de responsabilité, une chaîne de financement et une chaîne de certification. Voilà, donc c'est sûr que c'est lourd, c'est du travail, mais au total, ça avance. Alors, vous avez, bon, j'ai favorisé mes propres publications, donc je m'en excuse, mais elles sont toutes en libre accès, donc vous avez voilà, elles sont toutes disponibles. Et vous trouverez quasiment toutes les données que je vous ai présentées ici. Voilà. Merci.
Merci beaucoup, Pierre. Merci beaucoup. Donc, c'est bon que vous avez fini avec ces deux questions que vous vous posez, parce que maintenant, je reviens à la volonté de vivre et ce poème, et je vais prendre l'autre vers que j'avais, que c'était « La vie se fait et se défait ». Puis recommence « Le rêve de semences émerge de la nuit, enveloppé de la lueur obscure de l'aurore. Où est la brume matinale? Où est le soir magique? Où est l'éclair de lune? Où sont les rayons de la lune et de la vie? Où est la vie à laquelle j'aspire? Je désirais la lumière au-dessus des branches. Je désirais l'aube sous les arbres. Et Et pourquoi c'est important ça? Parce que maintenant, c'est le moment de poser toutes les questions à tous les experts qui sont venus ici. Vous êtes venus, vous avez posé beaucoup de questions, je suppose, à vous-même, je suppose, et vous devez souhaiter, vous devez désirer de les exposer. Donc maintenant, on va changer toute cette présentation. Il y aura 6 fauteuils, il y aura tous les experts. Donc on fait une petite pause café de 15 minutes et on revient parce qu'à ce moment-là, on aura la réponse à la question que Pierre se pose, à la question que vous vous posez, et tout le monde, on pourra discuter avec Roland qui sera aussi présent. Donc, c'est une demi-heure pour poser des questions. 10 minutes et on revient. Merci beaucoup. Rainer, you will be sitting on the first one, Pierre on the second one, Roland, you are on the back, so you don't have to sit in a new sofa. Kiyono, please sit on the third one. Begoña, you can sit next to Kay. Monsieur Sidi, vous pouvez vous asseoir. Et maintenant, moi. Donc, on va commencer les questions. Tout d'abord, est-ce que quelqu'un a une question pour démarrer? Ah, je suis content.
Merci. Je me présente, Mohamed Wassim El-Hani. Je suis directeur de contrôle environnemental à l'Agence nationale d'évaluation des risques au ministère de la Santé publique. Ministère de la Santé. J'ai quelques questions. La première, ça sera par rapport au échantillonnage, par rapport aux POPs dans l'air. Est-ce que ça a été fait dans l'air ambiant ou bien dans l'air intérieur? Ce qui a été présenté maintenant. I can ask it in English.
Yes.
For POPs in air, it was done in internal outdoor or indoor air? Yeah, outdoor, OK. Il y a une deuxième question par rapport au dosage de POPs dans de matrices biologiques humaines, dans le lait maternel. Est-ce qu'il y a de niveaux de référence basés sur les effets sanitaires, c'est-à-dire du niveau de référence de doses internes ou d'exposition interne, sans effet sanitaire pour les différents POPs, ou pour certains, disons?
You have one mic on the table. Each table will have one.
Yeah, the question, if I understand okay, now it works. If I understood your question correctly, it was a question, are there no effect levels? And I think that the toxicological assessment is quite complex. So I'm not a toxicologist. I only can refer, and that was what I tried, to the assessments done by EFSA, the European Food Safety Agency, and I gave a number of reference to these assessments of EFSA. So I think there are a number of effects to be assessed. That was what I tried to show with the example of the PBDE assessment, which is true for other contaminants as well. And what EFSA then tries to assess, say, the minimum doses from above which you don't have effects. But again, I'm not a toxicologist, and I only can refer to the toxicologist. So
I will explain again. I understand you speak about the intake exposures. This is for risk assessment for food risk assessment. But when we dose in biological matrix, in blood or in lait maternel, I don't know, milk. So we have measures to say if we have a hazard situation or not, if these persons are at high risk to develop some other but health effects or not. If there is, like in some heavy metals, there is some reference for internal exposure for, understand me?
Again,
we need to know which level of concentration of POPs in the body of women that can be acceptable.
Yeah.
This is
Yes.
You mean for breast milk? What is safe in breast milk so that then this can be fed to babies? What I mean is that was a question repeatedly addressed to WHO. So also for the last round of WHO UNEP coordinated exposure studies, that is something UNEP cannot perform, but would be in the responsibility of WHO. I'm aware of WHO assessments of earlier times, for example, including also for dioxins and PCBs. But as far as I know, WHO has not addressed these issues recently. And so that is difficult. For the levels as well of PCDD, PCDF, dioxin-like PCBs, and DDT, Martin Vandenberg has assessed the levels we found in human milk. Martin Vandenberg is a toxicologist, a Dutch toxicologist, who worked also as a professor of the university for many WHO tasks. So he has addressed a couple of years ago the issue of, say, safe levels, or what the levels in human milk exceed TDIs. But what you would need probably is an assessment of all levels of the, say, 30 listed compounds as we analyzed until 2019, or now 37 analytes. And I'm not aware that WHO would do such a risk assessment for all these 30 POPs. That was the reason why I tried at least to give, say, some orientation by trying to derive a priority list which was just based only on lipid concentrations for chlorinated and brominated POPs. And that is what I had in mind from the assessment of Martin Vandenberg a couple of years ago. DDT was assessed partly as a risk. For dioxins and dioxin-like compounds, it was clearly a risk. So this has always been a kind of motivation that the levels found in human milk would be of concern then for babies. However, that has been, say, a kind of argument since the 90s or so. However, this has always been also a quite critical issue, because you do not wish then to raise concern of breastfeeding. And so it was always, say, a conclusion, something, this gives concern, or this gives reason to further reduce emissions to get safer levels. So that is roughly the overall context. Does this answer your question?
I have others, but okay, no, perfect.
Also recommend 6 months breastfeeding, right? I mean, also considering they know pollutant levels, but I think the WHO concludes that these levels still breastfeeding has more advantages and overcompensate, let's say, the pollutants.
Directrice projet industriel au niveau de l'Office national de l'assainissement. Bon, ma question, je vais la poser en français pour qu'elle soit plus claire. Donc, je voudrais savoir si pour les POPs présentes dans les eaux usées, que ce soit domestiques ou industrielles, quel type de traitement on peut procéder afin de minimiser ces POPs-là? Et est-ce que après traitement, est-ce qu'on va les trouver dans les boues ou ils seront dégradés? Et merci.
Yes. Yes. You have 1 minute. Here. No, sorry.
Yeah, so the question was whether the wastewater, like domestic or industrial water, if it contains POPs, whether it can be treated. And I think I heard in the beginning it was about PFAS in water, or just persistent organic pollutants in general.
In general.
Yeah, okay. So PFAS and other POPs are a bit different. So persistent, when it is hydrophobic and then it is bind to suspended particles, it's easier to remove because you can do sedimentation, you can have it through mechanisms that mechanical treatment or also oxidation. During the usual treatment, it could be removed. However, as you know, during the heavy rainfall, the wastewater will be discharged often in urban cities directly to the water environment, and that would escape the normal treatment process, and you can find elevated level of POPs discharged to the environment without treatment. And then, as you know, persistent organic pollutants are all very persistent, and it could remain. And then some of those other hydrophilic substances, like PFAS, and also like pharmaceuticals, personal care products, they are more difficult to be removed. So sometimes waste treatment plants, they need like third treatment, radioactive? No, is it radio? Oxidation or ultra? Yes, additional treatment can be done, but yeah, exactly. But then, and then for PFAS, there are also more emerging technologies, especially designed for more hotspot or contaminated sites. But these techniques are quite expensive, or they are still at the innovation stage, but they exist. But challenges, again, is once it is released, it's quite persistent and it remains. PFAS, or let's say PFOA-related compounds, for example, there are several of such chemicals, but in the environment, they degrade to PFOA, or PFOS as well. There are precursors that could be used in the industrial processes, and then in the environment, it becomes PFOS, which is the most stable form, and that is what you can detect in the environment as it remains intact for many years.
Normally for PFAS, you use activated carbon filters for drinking water. It can also be a technical resin just to absorb the PFAS. So this is done in many countries, especially when you have drinking water limits. It comes to the same what I said for standards and limits for products. It's the same for drinking water. Normally only after you have drinking water limits, then the government need to act and the drinking water companies need to act. But this happens now in Europe. We have a regulation on Europe, which is then implemented for the individual countries. So they set PFAS drinking water limits, and then you check the drinking water levels for PFAS. And based on this, you decide if an additional activated carbon filter or other filtration system is needed to reach that limits.
Well, I am Lazar Haji, representative of the Ministry of the Health. I will be not tedious and then will be fast for my questions. First, the first question for Dr. Kionu. Yeah, it's not a question, but it's confirmation. You illustrated and we show us the world map of controlling in the PAPs in the air of the world. And it seems that in Tunisia we have only one site. In Europe there is many and many sites. But in the United States of America, it seems that there is few sites, in contrary of the countries of Latin America. So I have a question. Maybe it's not you find it is political, but I am not. It's not political. What about the government that the bad government that is in the Palestine land? What about this? Second, I have this for the second question for the Dr. Reina Malish. I can see it. I'm tired. I am for the Dr. Reina. I am familiar for your best work, your best investigation for since 10 years. As we know, and that the harmful chemical of the POPs can cause various health problems such as acute toxicity, nephrotoxicity, cancerogenic for the reproduction, etc. As we know, all the POPs are the cause as we know that the POPs are bioaccumulative, especially in the fat, so in the lipid, and are not hydrosoluble in water. Here I speak about the human health. As we saw, your study were about the human milk. That means the women milk. So my question is about, are you seeing, or if you will see and control the hormones of secreted in the blood of each woman and her milk? Why I demand solicitate this question? Because I have done my PhD in Spain, and it's the first time in the world that I work in the drug anti-cancerogenic, and it's the first time that we found that there is a correlation between the oxidation of tumors and the oxidation of the drugs. And that's all.
Right. So thank you for these questions. The first question was, the number of sampling sites that was shown in the monitoring, that air monitoring data that contributed to GMP3. There was a global map. And indeed, in Tunisia, I think there are 1 point or 1 or 2 points that are just, overlapping in your countryside. So it's not this is not a map of existing all of the monitoring data in the world. It's a data map showing which data contributed to GMP3, which means that the government, the parties to the Stockholm Convention focal point, has sort of approved or agreed that these are the sites that can contribute to the monitoring. And so for this case, maybe next time we can discuss further and then identify if we can include more sites in Tunisia. Of course, this also relates to the availability of resources, whereby the UNEP supports this monitoring activity. So that is why some of the countries have more sites, some are not. And I also mentioned that in Latin America, there is a GAPS network. It's a regional monitoring network that contributes to this GMP exercise. So without funding from Secretariat or the GEF, they already have the monitoring program, ongoing monitoring program, that contributes to this GMP3, which was being agreed upon by the government, the parties to the Stockholm Convention. The State of Palestine is also a party to the Stockholm Convention, and they could contribute to the data. The data is first collected at the regional level. So the State of Palestine belongs to the Asia-Pacific region, which is coordinated by 6 regional experts, with China being the coordinator. So we would need to look into that and then have the lead coordinator to ensure we will have the data from as many countries as possible. But as you might remember, the Arabic region, Central Asia region, and Africa are where we have a big gap in data existence.
Again, if I understood correctly, human health in general, levels found in human milk and humans in particular. What I have understood, again, I'm a chemist, an analyst, and I only follow talks of toxicologists. What I mean is the general idea also of the Stockholm Convention is to prevent possible risk for human health and the environment. And in Germany, we have developed, 20, 30 years already ago, a system of measurement of precautions, which was also introduced then in the EU in legislation. What I mean is, so for example, in the field of food and field, we got maximum levels. Is it better now? Better? Okay. Okay. So that is that if you exceed a certain level, whatever, with one intake or so, this does not immediately cause any health effect. So that is what the toxicologists try to understand then, the difference between acute toxicity, chronic toxicity, and therefore these measures of precautions aim that also after, I have the feeling that there is a reflection, that also over lifelong intake, you do not get any health impacts. So that is the general idea of measures of precaution. And that is also what I understood, that even if somebody gets whatever cancer or affects years later, you won't be able to trace it back to any certain exceedance or whatever. There are so many different factors which finally define on safe levels, that is not easy to answer in the individual case. All, again, to sum it up from my understanding, everything is directed to reduce possible human health effects also in the long run, although in any particular case, for any particular concentration, it is hard to define or to justify or so. Does this answer what you're... Okay.
Merci à tous les panélistes. Donc, je me présente, je suis Taoufir Ben Abdallah, un journaliste spécialiste en cause environnementale. Donc, j'ai deux questions spécifiques, donc très courtes. La première à M. Youssef Zidi et la seconde à M. Pierre Humbert. Donc, je commence par M. Youssef Zidi. Vous avez souligné dans votre présentation qu'une troisième campagne donc, de surveillance des POPs est en cours de préparation. Je voudrais savoir au moins les grandes lignes de cette campagne et au moins un petit résumé des deux premières campagnes. Donc ça, c'est la question adressée à M. Soufzidi. Quant aux questions adressées à M. Humbert, une première question concernant ce produit de substitution fluorée en termes de textile dont vous avez parlé et que vous avez qualifié de secret industriel. Donc, est-ce que, en termes de POPs, en termes d'un thème très sensible, donc d'impact sanitaire, environnemental, on peut parler aussi. On peut parler de secret industriel. Ça, c'est un point d'interrogation. Donc, selon la législation, est-ce que on peut parler de ça aisément? Ça, c'est une première question. La seconde, vous avez cité que vous voudrez savoir c'est-à-dire que comment on gère nos 3 œufs en Tunisie. Donc, c'est une question qu'un expert pose et que je peux signaler au moins deux grands indicateurs, excusez-moi, pour le traitement de ces déchets. Le premier, c'est que nous sommes arrêtés à 2 peut-être petites expériences avec les Coréens et avec les Allemands, la GIZ et l'agence donc de coopération coréenne, pour gérer 2 petits sous-produits de ce grand gisement que présentent les 3 œufs en Tunisie. On est arrêté là. Donc, le gisement, il est là. Et on aimerait bien s'inspirer de l'expérience française dont vous avez peut-être exposé quelques lignes et quelques process. Et peut-être, est-ce que c'est un process généralisé de par le monde pour sortir de notre un petit peu coin, là où on est fixé pour nos 3 œufs. Ça, ce sont mes 2 questions et merci.
Merci, M. Taoufir, à la question. Donc, en fait, la négociation en cours pour entamer une 3e campagne d'analyse et de suivi de POPs en cours, c'est vrai, mais elle va concerner pratiquement les mêmes sites et les mêmes matrices. C'est-à-dire, on va faire la même chose avec le lait maternel, l'eau, l'air et certaines matrices agroalimentaires telles que l'olive, l'œuf et le beurre. Donc, pour les anciennes campagnes aussi, ils ont traité le même sujet, les mêmes lieux, les mêmes matrices. Pourquoi on doit choisir le même et pour avoir une idée sur l'évolution et le changement. De temps en temps, qu'est-ce qu'il a changé? Est-ce qu'il y a une évolution, que ce soit négative ou positive? C'est pour cette raison-là, on doit choisir le même site et le même paramètre. Ça. Et merci.
Bonjour, merci pour les questions. Donc, le substitut qu'utilise Decathlon est non fluoré. Non fluoré. Donc voilà, il a franchi il est sorti des fluorés. Il faudrait leur demander, puisque je travaillais à l'Institut national de l'environnement et des risques pour le compte du ministère de l'Environnement français sur les déchets dangereux. Donc, je leur posais des questions. Ça a été la réponse à un institut officiel à l'époque. Donc, il faudrait leur demander. Peut-être que, 3-4 ans plus tard, peut-être que leur produit est devenu plus commun et qu'ils seraient prêts à le dire. Mais voilà, c'est pour dire quand même que les grands groupes sont très conscients, suivent de très très près tous les travaux BRS, etc. et anticipent. Voilà. Donc, oui, il faudrait leur demander. Alors, sur la gestion des équipements électriques et électroniques en Tunisie, donc vous avez eu 2 projets, un avec la coopération coréenne et un autre avec la GIZ allemande. D'accord? Donc c'était pour mettre en place des collectes séparées ou c'était pour... C'était...
Des collectes, des mini-exploitations, c'est-à-dire des exploitations ciblées, c'est-à-dire qu'on exploite la partie électronique, donc la carte électronique,
oui,
par exemple pour les ordinateurs et
oui.
pour le reste,
Alors, les cartes électroniques ont de la valeur. Il y a un marché mondial des cartes électroniques, riches en or, pauvres en or, etc. Il y a le tantal des condensateurs. Enfin voilà, ce n'est plus un déchet. Les cartes électroniques triées, c'est plus un déchet. C'est un produit qui circule dans le monde entier. Vous pouvez avoir des cartes électroniques collectées en France, pyrolysées en Pologne, rachetées par le Japon. Enfin voilà, c'est un marché, c'est plus un déchet. Donc voilà, donc ça c'est bien. Normalement, ça s'organise tout seul. Le problème, c'est qu'il faut que les gens qui démantèlent les téléphones ou les ordinateurs et qui prennent la partie qui a de la valeur, la carte, gèrent correctement la partie qui n'a pas de la valeur, donc qui sont hors métaux et qui typiquement sont les plastiques. Et le problème, c'est qu'il n'y a personne qui va racheter des plastiques électroniques, même non bromés. On n'a jamais réussi. Les constructeurs d'équipements électroniques ont tellement de spécifications, c'est tellement optimisé, ils ne prennent pas le risque d'aller acheter des lots de plastique inconnus sur le marché mondial pour fabriquer des appareils comme ça, parce que vous vous rendez compte, s'il y a un problème quelconque, ils perdent des milliers de fabrications. Donc il n'y a pas de marché, enfin, à ma connaissance, il n'y a pas de marché pour ces plastiques, pardon, en Europe, il y a un marché aujourd'hui pour les plastiques triés séparés, donc absolument non bromés. Et donc, l'entreprise que je connais le plus, c'est Galou au nord de la France. Ils ont créé une société séparée, Galou Plastics, qui granule, compound, comme on dit dans le jargon des plasturgistes, à la demande. Donc, fait des lots de plastique mélangé, granulé, que les injecteurs, ou les plasturgistes n'ont plus qu'à utiliser telles quelles directement pour fabriquer. Alors moi j'ai vu des prises de courant, des boîtiers de prises de courant murales en polystyrène recyclé. Ce qui est très connu, c'est le polypropylène, donc les pare-chocs. Ça fait 25 ans que Renault récupère du polypropylène recyclé pour faire ses pare-chocs. Voilà, il y a quand même certaines fractions. Mais ça ne repart pas en usage très noble. Hein, voilà, donc, alors petit à petit, ça progresse. Et une dernière chose, donc il y a une décision en Europe pour les automobiles, c'est très important. Une automobile moderne, c'est 300 kg de plastique. Une automobile moyenne de gamme, c'est 200 kg de plastique. Donc avec on compte plastique, le textile des sièges, les mousses, tous les isolants, toutes les gaines électriques, toutes les cartes électroniques. Voilà, c'est beaucoup. Et donc il y a dans le règlement européen fin de vie des véhicules, les constructeurs devront intégrer 25% du plastique de l'automobile en plastique 25% du plastique devra être du plastique recyclé. Donc ça fait quand même 50 à 75 kilos par automobile. Et dans ces 25% de plastique recyclé, il y a 25% qui doit venir de l'automobile. Donc ça fera 6,25% début qui font la boucle. Parce que les plastiques automobiles, ils contiennent de l'essence pour les tubes et tout ça, de l'huile. Ils sont très techniques. Il y a des tas de plastiques différents. Voilà. Donc tout ça, voilà, tout ça avance petit à petit. Et donc, j'ai une question, si vous connaissez ces deux projets-là, d'accord pour prendre la cerise sur le gâteau, c'est-à-dire la carte électronique du téléphone, mais que devient le reste?
Le reste, il est en stand-by, donc je ne veux pas monopoliser la parole, mais il est en stand-by. C'est pour cela que peut-être il faut profiter de ces occasions-là, par exemple, de ce séminaire, et je m'adresse à M. Youssef et peut-être à d'autres institutions aussi présentes, de s'intéresser à de telles solutions par benchmarking, donc des solutions déjà qui ont apporté leurs solutions quelque part en France ou je ne sais pas, quelque part en Espagne, pour au moins minimiser la présence des POPs dans la nature, dans l'environnement. Voilà, c'est ça. Parce que le stock, le reste du stock, c'était inexploitable, qui n'est pas rentable, il est en stand-by en Tunisie. Donc, ça augmente et c'est des montagnes de déchets qui sont en train d'attendre, voilà, d'être gérés ou valorisés. Merci. Voilà. Donc, c'est plutôt une recommandation à bon entendeur. Merci.
Merci beaucoup. L'Asad Chouba, chercheur à l'Institut national de sciences et technologies de la mer. Je m'occupe un peu de POPs et des hydrocarbures, de pesticides. Donc, pour moi, juste quelques remarques ou peut-être questions. Au niveau de la méthodologie utilisée pour les tendances qui ont été réalisées pour la biosurveillance, est-ce que la méthodologie utilisée par les différents pays est la même? Primo. Secondo, est-ce que 5 ans, c'est suffisant pour faire les tendances? Et d'après ma connaissance, il y a des logiciels bien déterminés pour faire ces tendances, parce que là, pour moi, j'ai l'expérience de faire les tendances. J'ai surveillé depuis 2000 jusqu'à 2010. Et pour faire les tendances, je trouvais beaucoup de problèmes, parce que ce n'est pas une régression. Les tendances, c'est autre chose. Il y a plusieurs paramètres qui peuvent rentrer en jeu. Donc, selon les différents pays et les résultats, je pense que 5 ans, c'est pour ça même au niveau de votre de graphique que j'ai vu, toujours il y a les tendances de diminuer. Il n'y a pas quelque chose que ça monte, c'est-à-dire ou bien en moyenne, quelque chose comme ça. Ça, c'est pour les tendances. Pour le deuxième question, c'est pour le rejet. Le rejet, vous avez parlé un peu de rejet de pesticides qui sont périmés, où ils sont partis, par exemple en France spécifiquement, ou bien est-ce qu'il y a des lois en Europe, par exemple pour l'Espagne et tout ça, parce que je m'adresse à notre collègue, parce que je vois que la même chose que ce qu'elle a fait sur les bateaux, on a notre bateau aussi ici pour notre institution, on a prélevé beaucoup des échantillons, on a fait tout ce que le manip qu'elle a fait en Espagne, mais toujours il y a des rejets au niveau des laboratoires, et ce rejet par où et comment vous faites pour ce rejet de pesticides qui sont périmés. Et je termine, comme je vois, je veux remercier les organisateurs de l'atelier, les panélistes, et comme je vois pour l'atelier, c'est détermination et surveillance des polluants organiques. La détermination, on va en Tunisie, on commence à déterminer, mais est-ce qu'il y a un laboratoire maintenant qui s'occupe de cette surveillance? Je pense que de prime abord, il faut penser à mettre en œuvre l'installation d'un laboratoire, d'initier cette méthodologie et commencer à travailler convenablement avec les autres pays pour parler, par exemple, avec la Russie, l'Amérique et tout ça, et parler de pesticides. Parce que là, dernièrement, j'ai travaillé un peu sur les PFAS ici en Tunisie, et je suis obligé de faire les analyses en France. Je ne peux pas faire ici, alors que j'ai un laboratoire, mais je n'ai pas l'appareillage. Ça manque l'équipement, mais on a la méthodologie, ça existe. Je vous remercie.
I think if I understood correctly, the first question was addressed to me.
And if I understood correctly, the issue was on monitoring, deriving time trends or so, whether this is a kind of reliable established procedure. What we have done or otherwise. That is one of the main ideas of the WHO UNEP coordinated exposure studies, to minimize any effects which could cause variations. So that starts with collection of, say, representative samples. So then we as reference laboratory would get samples sent to us by the national coordinator, who has selected, after sending out questionnaires, 50 individual mothers which are considered to fulfill certain criteria, so that then these pooled sample can be understood to be representative for a country. Then second, there is always a possible analytical variation, and therefore this reference laboratory system makes sure that there is as little analytical variation as possible. Therefore, I spent some time explaining that we have a strict quality control program. In other words, for example, we wanted to make sure when we received the first sample of human milk from New Zealand in 2000, that then if the last sample in this 2000-2003 round from US, we received 3 years later, if there are differences, that these are not analytical variations, but differences in the levels. So that is the concept as such, that the factors, the external factors, are minimized. Then I tried to explain that usually you derive time trends by comparing minimum, median, or so levels. If you do this, then you have a variation, because it depends just which countries participated in a certain round. This might change. Therefore, we found that it is much more reliable to assess time trends only from countries with repeated participation. So, and then I'm not a statistician. I have to admit that this was done by our Czech co-workers. So from Recetox, Kiono just has mentioned that the GMP data warehouse is in the hands of Recetox, and so they have excellent statisticians, which then could help me in a joint paper to address the time trends. And from these, colleagues also come then the differentiation between trends and tendencies. Trends which are statistically significant and tendencies which are not statistically significant. So that was then the basis to calculate time trends over 10 years, because that is one of the requirements of the GMP data warehouse, that studies should be able to determine time trends over 10 years. And that is what I tried to clarify. There was a misunderstanding also in the publication that countries were assessed whether they have time trends over 10 years increasing or decreasing. This is not the case. So this is not a requirement of the Stockholm Convention. It's only a requirement for reliability, scientific reliability of studies. So therefore, we choose this 10 years period, and then our Czech colleagues assessed with this tail-10 estimator, whatever this is, the time trends, which then were statistically significant over 10 years. So that is the overall background. Does this answer your question?
Ou la gestion de pesticides obsolètes. C'est un déchet dangereux. Il suit les dispositions de la loi 96 sur la gestion des déchets. Donc, il faut les traiter dans des sociétés autorisées où la seule technique, c'est l'incinération. Actuellement, c'est l'incinération pour les pesticides, oui. Mais c'est un déchet dangereux, il faut le conserver convenablement dans un site bien aménagé. Sinon, il faut le céder à une société autorisée. Sinon, il faut l'exporter ailleurs pour qu'elle soit incinérée. C'est ça.
Oui, donc la question des emballages vides de produits phytosanitaires, si j'ai bien compris. Il y avait les pesticides périmés, interdits, et puis, bon, il y a par exemple aujourd'hui la question des emballages vides de produits phytosanitaires. Bon, normalement, c'est plus un sujet POP, puisque ces POP sont interdits et les pesticides sont interdits depuis longtemps, sauf le chlorpyrifos depuis. Donc, c'est pas un sujet POP, mais juste 2 mots en France. Donc, la profession agricole et ce qu'on appelle l'agrofourniture, donc les vendeurs de produits aux agriculteurs, se sont organisés spontanément depuis longtemps dans une association qui s'appelle Adivalor, dont le siège est à Lyon, et qui a tout pris en charge, tous les plastiques agricoles, les emballages de balles d'ensilage, les plastiques de serre, le matériel d'irrigation à usage unique. Voilà, il y en a je crois qu'il y en a 30 000 tonnes par an. Alors, les emballages vides de produits phytosanitaires et de produits vétérinaires sont considérés comme déchets dangereux. Et je vais vite. Donc, typiquement, il y a 2 voies. C'est que, ils essayent, c'est du polyéthylène principalement, ils essayent que les entreprises phytosanitaires réutilisent ce plastique pour refaire des emballages de produits phytosanitaires, puisque c'est pas très. S'il y a quelques centaines de milligrammes par kilo d'un pesticide, c'est pas très grave quand on met un autre produit à 200 grammes ou 300 grammes litres dans un emballage qui contiendrait un tout petit peu d'un autre pesticide. Bon. Sinon, c'est l'incinération. Voilà, on en revient toujours à ça.
For the laboratories that can measure POPs, for the GMP, indeed, not any laboratory can be the laboratories for measuring the concentration that would contribute to GMP. It has to pass the test, I mean, sort of intercalibratory exercise, and certified through the project. And then, so there's a list of laboratories that can participate in this monitoring exercise. And if you know any laboratories, let us know. And it could then participate in the interlaboratory exercise or other calibration opportunity, and could be considered also in the system. But in absence of such laboratories in some countries, then you need to send the sample to, for example, Resetox for measurement. But what is very important is the sampling stage. For sampling, it has to be done locally. And then when it could also be very critical stage to avoid cross-contamination. Like if you use a Teflon sheet for covering samples, then you will have a high PFAS contamination. So for this purpose, we send experts to train. They follow the standard methodology for sampling and avoid contamination so that we can contribute to the measurement. Also, it would be great if samples can be stored for future analysis in cold temperature when new POPs are sort of listed. And yeah, sometimes it's difficult because of such a possibility of contamination. But yes, indeed, sampling is another step where we really need the local experts, and then also connection with the government, because that's where we can use that data as a global monitoring plan report. Thank you.
Just equipment.
Yeah, okay.
Juste les équipements, c'est tout. Parce qu'on participe avec les intercomparaisons à l'échelle internationale, ça fait longtemps et tout ça, mais ça nous manque les équipements, les appareillages. Merci.
Thank you for giving me the floor. If you allow, I have if you allow, I have two general comments and two questions. I start with comments. If we look at the expected outcomes of this workshop, there is 7 outcomes. I target the number 5 and number 6. Number 5. Identification of technical regulatory gaps which prevent the efficiency management of POPs, and the formulation of practical recommendation to address this issue. I think this outcomes needs further work. We didn't treat it as it is. I think among other gaps, the issue of standard, the limit value, the limit value of POPs. For your information, until now there is no agreement recorded in the framework of BRS Convention. I think this issue raised by Dr. Weber. The second outcome, put in place a national specialist network on the issue of chemical pollution in order to collaborate on the future chemical pollution, such as pilot project, research and development. My question, how to implement these outcomes? I will finish by the two questions addressed to Mrs. Kay. We are interested to, first one, we are interested to let us know the opportunities available for Tunisia for party including Tunisia in terms of program project for better implementation of POPs Convention and ESM of POPs products and wastes. The second question with regard the global motoring program, GMP. I ask you kindly to let us know the advantage of this program for party in terms of using data and report in order to undertake the appropriate measure and action. I think that Tunisia is interested to contribute in this program, but on the other hand, it needs capacity building and financial means to be provided to do this. How to provide this technical and financial assistance. Thank you very much.
So Roland, if you want to answer about the standards, you have the floor.
Yeah, I think it was rather a statement from him, right? That there are at the moment, and I think he means the standards in Tunisia, which might be missing. I mean, I showed regulatory limits in products in Europe. And in respect to the convention, normally the convention does not prescribe limits. For example, unintentional POP, the BAT-BEP is mentioning that there is 0.1 nanogram TEQ dioxin emission from incinerator, but it does not prescribe. Finally, the countries need to decide what kind of limits they choose. The same for the Basel Convention about the low POP limits in waste. So for a range of POPs, there are 3 provisional low POP limits. But finally, the country have to make the legislation. I mean, the Basel Convention low POP limit is not legislation for Tunisia. Tunisia finally need to decide what kind of low POP limit they might consider, or what kind of unintentional trace contaminant they might consider. This is also for Europe. Yeah, I mean, it is finally the country, and the limits are normally not prescribed. Maybe Kay can make an addition on this.
What the convention subsidiary bodies are trying to do is at least to provide guidance in order to facilitate decision making at the national level, and provide more information about the risks of these chemicals when it is present in products or articles or in waste and so on. So yeah, indeed it is not simply you can take the number under the convention and apply to your country, but rather you have to also assess available information and take the decision at the national level. I think you had a few more questions. So one was about the support for implementation of the POPs convention. And indeed, every country is facing different stage of development or economy situation and has different levels of environmental challenges. So for example, big countries like China or Brazil, India, they have big economy, but also have concentrated levels of contamination. And they also need support in technical assistance. There are also small island developing states. They have their own challenges, a small community, but has limited waste management possibility to install facilities and so on. And therefore, as a secretariat, we would need to hear from your country, each party, to express what is the need for your assistance. You need to explain to us what do you specifically is needed and helpful for supporting your country's situation. And this is called needs assessment. And once we have the information, we will try to mobilize funding. There are some opportunities, like obvious ones are JEF projects. There is also a special program for institutional strengthening. And the Secretariat, we also get some funding from the European Union, Germany, Norway, and etc., etc. I have developed a big project on plastic waste, thanks to contributions from, yes, indeed, Norway and Germany, France, and so on. We were able to support countries. But this is really on the basis of need expressed by parties. And we don't just go to random country and provide help. So please do send me email if you have specific areas that require support, and we would be happy to explore the opportunities. And then another question, very good point, how GMP data can be useful for countries in policy making. And this is really the question that I would like each country to think about in next 6 years and then the upcoming cycle. Because as I explained in the beginning of the Stockholm Convention, when the GMP was adopted, the objective was to use this information for evaluating the effectiveness of the Stockholm Convention. So if you observe declining trend, then it means that the Stockholm Convention is working. If you observe no change or even increase, there's something wrong with the Stockholm Convention. However, as I mentioned, now in the Arctic region, you might observe increasing trend, not because of the Stockholm Convention, but possibly through climate change. Or even in the background data, you might observe increasing trend, not because increasing level of use, but the urbanization of the place. So it used to be a remote area, but now you have more direct impact from human activities that it is not really reflecting background data. So many factors might be changing the trend, which is very difficult to interpret. And then also just a declining trend might not be so helpful for additional measures by policymakers. If it is telling you that you have a problem, like you find a hotspot, then policymakers might put some more attention to that issue. But if you only hear that, okay, the level of endosulfan in the air is declining, then it's, it might not trigger the further action. However, at the same time, data could be very sensitive. We have experience in the past, a party didn't like the elevated level of PFOS found through GMP project. And then we had to remove that number from GMP report. And yes, so it could happen, right? And then what is it? What is it that we're doing? On the other hand, I can see that in academia, there are so many studies, right? Like you have many national data available, or the universities or institutions, the researchers. There's a lot of publications out there. Maybe we could look into these publications and then make a general observation, not necessarily government-approved data, but have like a general review of available POPs data. That might be less costly. We just need some very good consultant or expert to look into these desk studies and then make some report. That might be an idea. But indeed, we need to really try to make the GMP data more useful for policymakers because it's a very costly, very expensive program, I must say. Thank you.
Thank you very much. I am okay. Undo this last question. Yes, for sure. This last one. You will be not able to ask the third, the fourth, and the fifth.
Hello. First of all, thank you for all these insightful informations that you shared with us. I'm Sarah Heshmi. I'm an assistant professor at Water Research and Technology Center here in Tunisia. And today I'm representing a national NGO called AEFG, which is the hub of IPEN in MENA region. So my first question is about research. So my concern is how are we going to keep research and monitoring, especially when most of these chemicals are globally banned. So what are we going to use for monitoring these chemicals? I know that XRF and FTIR can be used, but for elementary analysis, not specific compounds. So first question. So the second question, I wrote that PFAS can be measured with GCMS. So if I'm mistaken, please correct me. And lastly, so it's for Mr. Zidi. So about the analysis that were done in Tunisia. So what are the chemicals that were analyzed? And were they analyzed in Tunisia or in a foreign country, for instance? Thank you.
So maybe for the first question about the chemicals that are globally banned under the Stockholm Convention, but it is not banned until national regulation really bans the chemical and it is enforced. So even if it is listed under the Stockholm Convention, we know that the use could continue until it is really nationally banned and it is enforced. And some of the chemicals have exemptions that could continue the use for these allowed parties, or even parties haven't registered, but they just continue using it without knowing the requirement. And so even pesticides, this could be the case. But more complicated are the industrial chemicals. So you mentioned about XRF and so on. Why do we need that? Because like car spare parts, they could contain flame retardants, and they can be plastic waste that could be sent for recycling. And you want to know in a quicker way to eliminate those that might have possibility to contaminate the recycled plastics. So if you are able to eliminate bromine containing plastics, then, well, you don't know whether it is a deca-BD or penta-BD or octa-BD, but at least you know brominated something is contained. So you can screen it. It's a screening method. And then, yeah, PCB also has a number of screening tests. However, if you really want to be sure about the level, you need to, use more accurate measurement methodology. As for PFAS, normally we use liquid chromatography mass spectrometry, LCMS or LCMS-MS, but I guess other... Yeah?
I think this information was from the presentation from Roland, maybe, or well, also in my
like
presentation, I said that there are some PFAS which could be analyzed by GCMS, but that is for the ionic form. Usually, most of PFAS are analyzed by LCMS-MS or high resolution MS.
Yeah.
Okay.
You know, I said that this Kenyan doctor, meanwhile, it's Professor Urata. When he was in Germany, he used GCMS. Maybe the background was that in many African countries, you do not have LCMS-MS, but you have a range of GCMS in the laboratories. And so a range of PFAS can be analyzed with GCMS. Maybe you can look to his studies. And also he is in Kenya, he's at the university. I invited him last year to a workshop to give an overview on PFAS contamination in Africa, which was quite good. So you could, let's say, approach him and see what he says, what is possible and what is not possible in respect to GCMS and PFAS. But I know that for Tunisia, you have a LCMS in your national laboratory. So then if you have a LCMS, you can go with the LCMS, of course. In respect to the question of POPs in products, and that, for example, the PBDEs and HBCD are now restricted and production has stopped. The issue is, yes, in products, they will be there for years and even decades. In products in construction, even it can be 50 years or 100 years that you have still these products, and then coming out in the waste stream, and possibly if you establish recycling. So therefore, even the legacy POPs can be a topic for the decades to come, depending on the service life of products. And then, of course, when you look to other brominated flame retardants, they are also highly brominated. And Pierre Hennebert, he wrote a publication where he listed other brominated aromatic flame retardants in Europe, which are listed, which are also persistent and toxic and currently evaluated by the European Chemical Agency. And actually, in Europe, they have proposed a strategy for flame retardants for the evaluation. And one proposal there is to restrict all brominated aromatic flame retardants. So I think it's interesting to look to the publication of Pierre. Maybe Pierre, you can give the link about your assessment, and also to look to the European strategy on flame retardants. This includes not only brominated, but also phosphorus flame retardants, where there are some hazardous ones, but also some which are considered at the moment not hazardous. Yeah, so, and then you can look at it, and when you do your monitoring and assessment, not only focus on the POPs, but also other chemicals of concern. We have written our report for UNEP, Chemicals in Plastic, a technical report. There we have listed 13,000 chemicals in plastic, and more than 3,200 has some hazardous properties. So the issue is, of course, in plastic also bigger than the POPs in plastic. So maybe also this report might be a good starting point. There we have listed 10 chemical groups of concern, which are also beyond POPs. And therefore, I mean, when you are doing your plastic research, consider the bigger picture.
Merci Madame Hesmi pour la question qui concerne les POPs qui ont été mesurés au niveau de la Tunisie. Ce sont des séries de PCB et séries de pesticides organochlorés. Le résultat il est déjà abrité au niveau de la Convention. Vous pouvez le constater, il y a des résultats locaux, régionaux et mondiaux. Sinon, je peux vous envoyer la totalité du rapport qui a été réalisé dernièrement. Merci.
Je crois oui, on termine, mais vous devez répondre à la question de Pierre maintenant, parce qu'il a fait des questions avant de finir. Donc, si vous voulez, Pierre, vous le faites à nouveau, la question, et il va répondre avant de finir.
Y a-t-il un système de responsabilité élargi du producteur en Tunisie, et pour quelle filière? Et comment fonctionne-t-elle? Voilà, le financement, le contrôle, la certification, les résultats, le taux de collecte, la collecte séparée, enfin, toute la chaîne de mesure. Merci.
En tout cas, pour la Tunisie, il y a 2 ou 3 cas de système national de récupération ou de valorisation des déchets dangereux. Mais pour la responsabilité élargie des entreprises, on n'a pas encore mis en œuvre. Mais on a fait une étude très approfondie, très détaillée, et on a même préparé un projet de loi qui va mettre en place ce système-là. Donc, c'est en cours, Inch'Allah. Bon, code de l'environnement, oui. Le code de l'environnement, c'est quelque chose. Mais ça, c'est spécifique. Il y a un projet de loi, une étude détaillée qui existe, mais en phase de finalisation pour mettre en place le système de responsabilité élargie de l'entreprise, surtout pour les piles, et les déchets électriques, électroniques, et les déchets encombrants tels que les déchets de voiture et les déchets de matériel roulant. Okay.
Donc, now, if you want, I leave the floor to each of you to give one sentence as the conclusion for this workshop. So we can start with you, Rainer, if you wish. Okay, on fait the last one. Okay, short one, please. Short one, because we are very late.
La majorité de questions ont été répondues par les autres collègues, mais il y a les données à M. Hubert, la question, par rapport aux données de l'IPEN sur le POPs dans le produit. Il y a beaucoup de données et peut-être qu'il ne l'a pas présenté, je ne sais pas pourquoi. Il y a une deuxième question par rapport au projet espagnol de contrôle des POPs dans la Méditerranée qui va très bientôt démarrer la mission le 10 juin, je crois. C'est ça. C'est un projet 100% espagnol. Tous les participants sont des Espagnols. Il n'y a pas une possibilité que quelconque des universités ou de recherche puisse participer. Et la dernière demande à M. Jordi s'inscrit sur le programme que les prochaines étapes. Quelles sont les prochaines étapes de ce projet? Merci.
Pour participer, non?
Est-ce que quelqu'un de l'université,
Oui.
anyone for the research can participate in your company in the Mediterranean?
Yes, I
Yes?
understand the question.
Yeah.
No, I'm sorry, but it's not possible anymore, of course.
Close.
I was discussing with Jordi this 1
Yes,
month
because
ago.
now I will take
Maybe
the
you
floor.
prefer to explain the idea, but it's not possible anymore now.
C'est-à-dire, c'est une très bonne question, celle que vous faites, parce qu'on a discuté ça. Donc, on avait discuté ça dans le contexte de la Méditerranée. Donc, avec UNEP-MAP, on avait pensé de prendre ce bateau, Sarmiento de Gamboa, et faire un projet sur toute la Méditerranée en cherchant les hotspots, les points chauds. Donc, en savant, par exemple, les données que la Tunisie a pour faire les SNPs et pour faire les SNAPs. Donc, on a fait les National Action Plans pour UNEP-MAP qu'on doit présenter dans l'année prochaine. Et en savant toutes ces données, on devait prendre le bateau et aller là-bas et faire des connexions avec les universités régionales ou de chaque pays. C'est une possibilité. Et je me suis battu pour ça. Mais le résultat, c'est que ça n'a pas abouti. Donc, c'est dommage, c'est dommage. Mais, dans le futur, qu'est-ce qu'on peut faire dans le futur? Si moi, je suis le responsable du pays, je continuerai à me battre pour ça. Donc, parce que c'est une possibilité de continuation. Par rapport au monsieur d'avant qui l'a dit, sur le point 5, qui disait « Création ou consolidation d'un réseau de spécialistes nationaux engagés sur la question de pollution chimique, prêts à collaborer à des projets futurs. » Ça, c'est le point. C'est-à-dire, aujourd'hui, on a discuté tout ça pour commencer à mettre une petite pierre, on va dire un galet, un caillou, si vous voulez, pour des projets de futur. Medwave, c'est le centre régional et c'est pour aider. Donc, c'est comme maintenant un pays qui réclame un atelier sur un domaine, on le fait. C'est que Yono vient de dire aussi. C'est-à-dire, si on fait une demande au BRS, il y a la possibilité. Je ne peux pas parler pour moi-même parce que dans 2 mois, je ne vais pas continuer dans mon poste. Mais le GF9, il va arriver. Le MED programme, les activités, par exemple en Tunisie, par rapport à Medwave, ça finit aujourd'hui. Donc vous aurez la présentation et tout, mais les activités de Medwave, dans le contexte du MED programme, dans tout l'ensemble, ça finit dans 1 mois. Au mois de juin, ça finit. On ne va pas continuer. Mais il va arriver le MED programme 3. Il va arriver. C'est le moment, par exemple, de tous les gens qui sont engagés dans ces discussions, de proposer au ministère quels sont les points que vous considérez les plus utiles. Donc, par exemple, Roland a mentionné ça de peinture, par exemple, des cas d'études sur peinture. Est-ce que la peinture, le secteur de la peinture, c'est un secteur stratégique? Est-ce que le secteur de la construction, c'est un secteur stratégique? Est-ce que la personne qui vient, par exemple, du journalisme a des informations, par exemple, des choses de la chaîne, par exemple, des gens qui collectent, qui sont vulnérables? Parce que, par exemple, au Monténégro, par exemple, on fait un projet avec les gitans. Donc, les personnes qui cherchent, par exemple, tous les déchets électroniques, quel est le rapport avec la santé? Donc, on travaille sur ça. Par exemple, en Libye, on va faire un autre atelier sur la reconstruction après la guerre. En Albanie, on a fait un atelier sur la mousse anti-incendie. Donc, on travaille dans beaucoup d'aspects. Et c'est maintenant le premier pas pour continuer à l'avance. Donc, je comprends très bien ça. Je comprends que les résultats attendus, c'était très ambitieux, mais on a discuté tout ça. Maintenant, on est très en retard, donc on ne peut pas continuer. Mais vous savez qu'il y a Medwave, il y a les institutions de recherche de beaucoup de ces pays, l'Allemagne, on a mentionné différents, la France, la Belgique. Il y a plein. Donc, par exemple, quand M. Sidi a été le représentant de l'Afrique, par exemple, de la Convention de Stockholm au dernier BRSCOP, notre site event, c'était celui-ci que j'ai dit au début, c'est-à-dire le transfert de connaissances depuis le nord de la Méditerranée vers le sud. et du sud de la Méditerranée vers toute l'Afrique. Donc, c'est travailler ensemble, c'est ça. Et quand vous dites qu'il manque, par exemple, des instrumentations, il manque tout ça, c'est vrai que chaque pays ne peut pas avoir un laboratoire. Parce que pour avoir un laboratoire sur chaque pays, il faut avoir une chaîne des échantillons qui vont venir dans le laboratoire chaque mois pour que ça soit viable. Sinon, on va dépenser, gaspiller de l'argent, c'est vrai. Mais si on a une stratégie de futur, c'est faisable. Vous avez un an pour proposer des actions sur les F9, par exemple. Il y a beaucoup d'actions sur le VRS, qu'on dit, par exemple, Plastic Waste Partnership, des projets de 1 000 millions. On présente des propositions. Si vous êtes engagé et proactif, il y a des options de faire des choses. C'est seulement stratégie. Parlez tous ensemble et continuez. Donc, je ne vais pas m'extendre beaucoup parce que sinon, on ne peut pas faire la phrase résumée de chacun. Donc, maintenant, Rainer, it's your one sentence.
Nous avons une petite demande.
Solamente una pregunta a signora Bogonia, que Mr. Wassim quiere te preguntarte. ¿Por qué? Porque esta mañana لكني ما فهمتش.
Vous faites en français et je traduis très vite. En français, en français.
Mismo mi francés es no bueno.
Je me suis perdu maintenant. Oui,
pasa
oui.
nada, pasa nada.
No, 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 no.
No pasa nada. Muchísimas gracias.
No, no, pose la question, pose la question. No, pose la question parce que c'est intéressant pour la discussion. C'est-à-dire, je comprends. Pose la question. Posez la question en espagnol. Je vais la traduire en français, pas de soucis sur ça.
Muchísimas gracias. ¿Por qué? Porque mi cabeza ahora tengo muchísimo lengua, idiomas, y ahora quiero hablar en español. Entonces, sí, y ahora mi cabeza es en español. Entonces, no puedo hablar mismo en árabe.
Vale.
Sabes que ya, pasa nada, pasa nada.
Faites la question parce que ça va être très intéressant pour la discussion.
Es malo.
Mais d'accord. Après, oui, c'est la chose que j'ai pensé. Oui, oui, oui. D'accord. Donc, on fait la phrase pour la troisième fois, Rainer. Donc, vous avez bien réfléchi.
So, my final conclusions or it's a huge amount of data available and many options, and I hope that at least from what I could contribute, I could help to give you some guidance on, say, possible priorities, at least regarding analytes of interest from the perspective of human health. So that if that would have been helpful, that would be nice from my perspective.
Alors, ce que je vous souhaite, c'est que vous arriviez à rassembler toutes les parties prenantes, y compris le secteur informel. Je ne connais pas le secteur informel en Tunisie, j'étais en Côte d'Ivoire. Par exemple, bon, le secteur informel, c'est le secteur numéro 1. Voilà. Pour la construction des futurs organismes de responsabilité. Ah, Monsieur Zilli est occupé, non. Parce que c'est comme ça que ça pourra fonctionner et ensuite baser vos... Pardon, je répète, Monsieur Zilli. Rassembler mon souhait, c'est que vous arriviez à rassembler toutes les parties prenantes, y compris le secteur informel, en lui demandant de se structurer. Ce n'est pas un individu, ce sont des fédérations, des associations, pour que le système fonctionne, qu'il n'y ait pas des passages latéraux dehors du système. et que toutes vos décisions soient basées sur de la science, des données, des résultats de la science, parce que sinon il y a des discussions à l'infini, vous voyez. Si c'est basé sur des opinions, des avis ou des impressions, on discute à l'infini. Si c'est basé sur de la science faite par des universitaires, des partis indépendants, à la fin, tout le monde accepte. Au début, on dit non, il n'y a pas de pop là-dedans, non, ça n'est pas chez nous, ça n'existe pas, etc. Et puis on mesure, et puis on trouve, et puis les positions évoluent. Voilà, donc je pense que vous êtes sur le bon chemin.
Right. No, thank you very much for active discussion. I really enjoyed. The theme of the conference of the parties that just concluded was make visible the invisible. And it's the numbers who can make such invisible chemicals to,
This day, the nice discussion, and for me it was really inspiring. My idea is that we are lucky that we have all the conventions, and what we have to do is to work and to fight against POP and to communicate. And if we need help, we have to call to the door, and my door is open for anything you can need from our side. Thank you.
Roland, you have the floor, Roland. Il est connecté, Roland?
My presentation. Can you hear me, Jordi?
We don't listen, Roland.
Okay. Yeah. So, I mean, also my presentation was just a first introduction into the guidance. Yeah. And like I said, we have the webinar, which is 18 hours. So the first step was today into introduction of POPs in products. So I hope that in the next step, you can look to the guidance, you can look to the case studies, you can look to the webinar, and then decide what can be interesting for your country. What is for sure interesting for the North African region are PFAS. I know that in Tunisia, there is an interest to develop PFAS monitoring. So maybe I hope that for today, in the meeting with Begonia, there might also be a first step, maybe in a cooperation in future. So therefore, I wish you good luck. I mean, here for monitoring of POPs in products, but also look into the PFAS, because this is really serious in respect to water safety.
Donc, de ma part, je voudrais remercier peut-être les présents ici pour leur qualité d'intervention, leur patience et leur participation active. Je remercie aussi nos experts pour leur représentation, pour leurs conseils, pour leurs idées. Même si le travail terminera cette mois-ci avec le Medwave, je pense qu'il y a des grandes potentialités de coopération avec le Medwave et autres organismes. Probablement, on va essayer de déclencher un processus de concertation pour avoir la possibilité d'un MED-programme 2, c'est-à-dire si les choses qui n'ont pas été terminées dans cette cycle-là, pour peut-être les priorités, pour le besoin, peut-être on va se concerter, on va organiser un grand séminaire pour identifier nos besoins nationaux en matière de hotspots et en matière de gestion des POPs. Donc, merci beaucoup. Et on se voit, Inch'Allah, dans les futurs événements de concertation et de discussions pour d'autres sujets.
Merci beaucoup, M. Sidi. Je vous remercie la coopération du ministère dans tous ces presque 2 ans. Je remercie la participation de tous les experts, bien sûr. Je remercie beaucoup tous les gens qui sont restés jusqu'à la dernière minute ici en faisant une participation très active avec beaucoup de questions. Donc, moi, je suis très ravi de ça. Je remercie la participation et toutes les traductions des traducteurs. Et maintenant, je vais finir tout ce long voyage qu'on a fait. j'ai démarré avec le roi de la Numide, Jugurtha. Je suis allé vers le poète national du XXe siècle, mais maintenant, je vais finir avec la Tunisie indépendante. Donc, je vais prendre une phrase de Havik Bourguiba, que vous connaissez très bien, et la phrase c'est parfaite pour ce workshop, pour cet atelier. Être réaliste, c'est préférer une réforme modeste qui en permet une autre à un miracle impossible. Donc, qu'est-ce que ça veut dire? Si on va petit à petit, on peut faire des choses. On ne va pas résoudre le problème des PFAS de pop, c'est impossible. Mais on peut faire des petits pas vers ce futur. Donc, il faut apprendre de ces grosses phrases. Et avec ça, je conclue cet atelier. Merci beaucoup à tout le monde et à la prochaine. Au revoir.